Ninja Warriors, welcome to yet another power-packed session. I am Namrata, your mathematics expert, and we are doing complete mathematics revision in this particular session. Before I start any further, do let me know in the chat box whether I am perfectly audible and visible to you so that we can proceed with the session without any further ado. Alright, in the chat box I can see Anugna, Harshita, Jia, Manas, Tanuj, welcome to the session. Keep joining. I can see comments pouring in. All right. Keep joining, keep liking the session, and as I always request you that please do share this session with your fellow JEE aspirants so that we can get maximum interaction, maximum doubt solving. Right? Yes. And you must be wondering, you must be having some doubts that how it's gonna be, how the session is gonna be, what should be the agenda of the session. Well, you have already read the title, Complete Mathematic Revision. So in this session, we will discuss each and every chapter involved in your JEE Mains 2024 Mathematics, right? Yes? Okay. Audible, visible, just give me a big thumbs up so that I can just proceed with today's session, because I am super duper prepped up, super duper charged up to start this session. You know what? Yes. Okay, Naveen. Yes. PDF of this session. So you all know that I share the PDF of the session right after the session gets over. And one more doubt which I receive very often, that what would be the duration of the session. So, you know what, we are revising the complete mathematics. You know what, complete mathematics, algebra, calculus, vector 3D geometry, statistics, you know what, geometry as well. So the session is going to be a bit longer. So I would request you to keep your water bottle beside you, grab your notebook, grab your pen, so that you avoid any type of distractions, because this is the final revision we are doing for your JEE Main examination, right? Yes, so I got the thumbs up. I guess we can proceed with today's session, right? So I will tell you that how are we going to go about this session, right? So first of all, in the beginning, we will tap the algebra part, and you know what all chapters are there in algebra. So I have done a brief analysis so that you can calculate for yourself that which portion is how much important for you, right? So here is the analysis of algebra. You can clearly see quadratic equation. We'll start with quadratic equation. Quadratic equation is again associated with complex number, so we'll tap complex number. Then sequence and series, permutations and combinations, binomial theorem, and matrices and determinants, right? So this whole session will be all about concepts and the important questions. Yes, the good news is concepts plus important questions, because without questions, so what is there in mathematics, right? Yes, all clear. So let's just begin with the very first topic of today's session. Are we excited for quadratic equation? Yes, definitely. I will give you breaks in the middle, because I will also need water break, right? Yes, so quadratic equation, let's just begin. Let me just tell you that what all topics are there which we need to focus in our JEE Main 2024. So first thing is relation between roots and the coefficients. Yes, so it has been seen in past few years that NTA is showing extra favoritism towards this roots and coefficient topic. Along with that, nature of roots, so we all know, we are studying since grade 10. Without this, we cannot operate in quadratic equation. Then we will focus on transformation of equation and the common roots, right? So in 2023, NTA has shown again extra favoritism towards the common roots as well. So we'll tap all the topics, right? Let's just begin. So the very first thing, nature of roots. So if you are given a quadratic equation, this is your quadratic equation where leading coefficient cannot be 0 and your B and C other coefficients should belong to real numbers, then only we can call it as a quadratic equation, right? You know how to calculate roots of this quadratic by this formula, minus b plus minus square root of d by 2a, right? This is the formula. Now you must be wondering, ma'am, what is d? So let me just write d is discriminant, which is equal to b square minus 4ac, and this discriminant decide what is the nature of the roots, right? This discriminant decide the nature of the roots. This we have studied in your grade 10, right? So if discriminant becomes 0, what does that mean? That both the roots, put value of d over here, both roots become minus b by 2a, and you know what, the roots become real and equal roots, or you can say we will get only one root. Both statements are correct, right? And yes, so the quadratic equation, this quadratic equation will form a complete square, right? The quadratic equation will form a complete square in this particular case. When discriminant, that is b square minus 4ac, is greater than 0, that means this expression is positive, then roots are real and distinct. This we all know. But one more thing, if you want your roots to be rational number, you know what is rational number, right? Free from roots. If you want your roots to be a rational number, this d should be a perfect square. What is a perfect square? Suppose if d is coming out as 4 or 9 or 144, 196, 425, there are so many perfect square, right? So if this d is perfect square now, then what happens? This your value of x will be a rational number. So this is very important point. If you want your roots to be rational number, then your d should be what? Perfect square, right? Got it? Yes. Yes. Okay, yeah, this is live, my students. This is live. Okay, all right. And if your discriminant is less than 0, then inside the square root you will get a negative quantity which is imaginary. So your roots will be imaginary. You can call them non-real roots as well. And along with that, you know what? Non-real roots always come in pair, right? So if someone is saying you have a real quadratic equation whose one root is what? 3 minus 2 iota. So you can automatically conclude, okay ma'am, if one root is 3 minus 2 iota, na, then another root would be 3 plus 2 iota. Why? Because they always occur in pair. This root cannot go alone at all if I'm talking about the real quadratic equation, right? I hope this part is clear. I hope the nature of roots is clear. I won't spend much time on nature of roots because this you have already covered in your examination, right? Grade 10, right? Okay. So this I already told you that b square minus 4ac is discriminant, and this helps to identify the nature of roots. Now we will talk about relation between roots and coefficients. Now this is something which again we have studied this in our grade 10 as well, right? Sum of roots. So if you are given with a quadratic equation, right, again leading coefficient cannot be equal to 0, then your sum of roots alpha plus beta, right? This quadratic equation is associated with two roots. Alpha plus beta would be equal to what? Minus b by a, and product of roots alpha beta would be equal to c by a. This is what I want you to remember. You all know this already. Sum of roots and product of roots. And you know what? We have one more formula which you eventually forget. And you know what? This formula was asked in 2023. Yes, JEE Mains 2023 had this particular formula. Question related to this particular formula. So alpha minus beta. Now you must be telling, ma'am, in the last time you are telling me a new formula which I'm not sure whether I will remember this or not. So I have another solution for you as well. So what you can do, you know alpha plus beta, you know alpha beta. What you are looking for is alpha minus beta. So I have a solution for you. This is the formula you can apply, right? If you know alpha plus beta, if you know alpha beta, you can calculate the value of alpha minus beta whole square, right? And by this formula only I have calculated this formula, right? So either remember this, but my recommendation is use this formula, okay? Even if you remember this, you should know this formula. This formula will help you in more problems as well. Okay? So this was all about relation between roots and coefficients related to what? Related to quadratic equation, right? Yes, but here is a catch. When I always teach quadratic equation, this part is also important in quadratic equation, which is related to cubic equation. Yes. Okay. So this cubic equation, so we will actually discuss relation between roots and coefficient of cubic equation as well. Let me show you. So this cubic equation is associated with three different roots. Yes or no? Alpha, beta, gamma. Yes. So sum of roots. Sum of roots would be what? Minus of b by a. Minus of b by a. Sum of roots alpha plus beta plus gamma is minus b by a. What is product of roots taken 2 at a time? Basically sum of product of roots taken 2 at a time. Alpha, beta, beta, gamma, gamma, alpha taken 2 at a time. So that would be plus times c by a. Can you see the alternate sign? Minus b by a plus c by a. And last taken 3 at a time. So there will be negative sign. So alpha, beta, gamma would be minus d by a. Right? There will always be plus minus plus sign. And it will always start with the negative sign. Then positive, then negative. Right? Yes? Yes. Yusuf, there will be PYQs in the class. Definitely, I already told you this in the beginning of the session itself. Okay? Because without actually questions, I can't operate in mathematics, right? Okay? Yes. So this is what? Transformation of equation. Transformation of equations. Okay? Right? So this is also again one very important portion if JEE Main 2024 is concerned. Right? So in the question itself it is given that roots of this quadratic are alpha and beta. Then equation having roots 2 alpha 2 beta would be, equation having roots 1 by alpha 1 by beta would be, equation having roots this and this will be. So I will just tell you the shortcut of this particular thing. So if you are given a quadratic equation whose roots are alpha and beta, and you are looking for another quadratic equation whose roots are 2 alpha and 2 beta. So what you need to do is you need to follow the reverse process. Yes, you need to follow the reverse process. In here, you have to replace x by 2. That's it. The moment you do it, you will get what? The equation whose roots are 2 alpha comma 2 beta, right? So plus bx by 2. I'll tell you about the shortcut and I will tell you what is the reason behind this shortcut as well. Just take the LCM. So it will become ax square plus 2bx plus 4c is equals to 0. Right? So this is what it is. Okay? Ax square plus 2bx plus 4c is equals to 0. Right? So this will be roots. So the roots of this equation will be 2 alpha and 2 beta. Again, next thing. Now 1 by alpha, 1 by beta. So you just need to replace x by 1 by x. The moment you replace x by 1 by x, it will become a by x square plus b by x plus c is equals to 0. Once you solve it, you will get cx square plus bx plus a is equals to 0. Right? And in here, what you will do? You need to do the reverse process. Are you getting my point? You are looking for equation whose roots are alpha plus 2 and beta plus 2. Right? Okay. So you need to replace x by x minus 2. You need to do the reverse process. Right? X minus 2. So this will become what? A x minus 2 ka square plus b x minus 2 plus c is equal to 0. Yes? Yes? Perfect. Are you getting my point? Expand this, you will get. Now ask me in the chat box, ma'am, why are we doing this? Why are we following the reverse process? In the expression, it is given that alpha, beta and 2 alpha, 2 beta. You should be replacing by x with 2x only. Now, why you are doing this? Why are you doing the reverse process? Let me just show you. Let me just tell you the reason why we are actually doing the reverse process. Okay? Yes. Where were we? Okay. Yes. So, suppose this ax square plus bx plus c is equals to 0 and you are looking for something whose roots are what? Alpha dash. Let alpha dash will be equal to 2 alpha and beta dash will be equal to 2 beta. And what you are looking for is equation whose roots are alpha dash and beta dash. Correct? That's what you're looking for. Alpha dash and beta dash. Now, in here, what you can do is you can definitely satisfy value of alpha. A alpha square plus b alpha plus c is equals to 0. Right? You can plug in the value of alpha in here. You can't put alpha dash in here. right? Because this equation is designed to satisfy alpha only. Now let me just get the value of alpha from here. It will become alpha dash by 2, right? Alpha dash by 2 is the value of alpha. Now alpha can be replaced with what? Alpha dash by 2. So A alpha dash by 2 ka square, B alpha dash by 2 plus C is equals to 0. Again, the moment you solve it, you will get this only. You will get this only, right? The moment, this is the same thing we have done. So now you know why are we reversing the things? Yes, I'll be covering the whole mathematics, right? Don't worry about that. Okay, so now I guess you are sorted in your brain that always you have to do the reverse process while you are looking for transformation of equation, right? Okay, perfect. Given two quadratic equation, there are two possibilities. Okay, so this is the last topic of quadratic equation, which involves common roots. Okay? Alright, so suppose you have two equations, a1x square plus b1x plus c1 is equals to 0, a2x square plus b2x plus c2 is equals to 0. If both the roots are common, then what can happen? Both the roots of this equation are common, then simply a1 by a2 would be equal to b1 by b2 would be equal to c1 by c2. If both the roots are common, we will have this condition for both roots common. Okay? But if they have one root common, then we have to put in some effort. This is effortless. Both roots are common, you are sorted. Be happy that both roots are common, that means easy condition. Basically coefficients are proportional. But when single root is common, then you are gone. Then you need to do something, right? Then you need to make some effort, right? So what you can do, we have three methods related to one single root common. The very first method says that, okay, if you actually, so you are given with two equations, right? Suppose you know that the first equation has root 2, 3, right? And one root is shared by these two equations. So what you can do is you can take the cases, like that case number 1, that 2 is the common root for this equation, or case number 2, that 3 is the common root for this equation. So in first case you will satisfy 2 in here, and in second case you will satisfy 3 in here. Yes? Okay. Yes. Okay. So when we know both roots of one equation, make them satisfy equation 1 by 1. So that's what I was telling you. 1 by 1, if you know both the roots of equation 1 by 1 start satisfying in the second. Okay. So method 1 is, I guess, clear. Okay. Okay. And what about method 2? So method 2 is actually my favorite method, wherein what you do is, so suppose you have two equations and you have single root common. So you just solve these two equations. You just solve these two equations by eliminating x square. We will do it. I will show you how we actually apply method number 2. What is method number 3? So method number 3 is you have to remember this particular formula. For one common root, we have a condition. Now you must be wondering, ma'am, we can't remember this. But I am here to show you the trick, and the trick is chartered accountant trick. CA, chartered accountant minus chartered accountant, is equal to, now CA is done, start with A. AB minus AB. Now B, start with B. BC minus BC. Getting my point? Now write 1, 2, 2, 1. Don't forget the square on the left hand side. 1, 2, 2, 1. 1, 2, 2, 1. This is the condition of single common root. Okay? Alright. Yes, integration will be covered in this video. Do not worry about that. Okay? So this was all about quadratic equation, the important stuff about quadratic equation. Now we need to figure out the sum of roots of this particular equation. Right? Sum of roots of this particular equation. Okay? So this equation is what? X square minus 8x plus 15. So x square minus 8x plus 15 ka mod minus of 2x plus 7 is equal to 0, right? Yes, okay. So the moment I split this, I will get x minus 5 and x minus 3. ठीक है? Minus 2x plus 7. Now you need to take the cases. Case number 1. Case number 1 says x is greater than or equal to 5. ठीक है? When x is greater than or equal to 5, what will happen? Both the factors will open with a positive sign. So the whole modulus will get open with a positive sign. So finally you will get x square minus 8x plus 15 minus 2x plus 7 is equal to 0, right? X square minus 10x plus 22 is equal to 0, right? So the moment you solve it, 5 plus minus square root of, 10 plus minus square root of b square 100 minus 88 upon 2. ठीक है? So you will get two values, 5 plus something and 5 minus something. This will become what? 12. So 5 plus minus root 3, right? But you have taken the case x should be greater than or equal to 5. So 5 minus root 3 is rejected. Only 5 plus root 3 is accepted from this case. ठीक है? So I'll be actually accepting this only, rejecting minus sign. From here, if x lies between 5 and 3, then what will happen? If x lies between 3 and 5, then this will be negative, this will still be positive. So overall modulus will get open with a negative sign this time. So minus x square plus 8x minus 15 minus 2x plus 7 is equals to 0. This will become x square minus 6x and this will become what? 5. So minus 8 उधर जाके plus 8 is equals to 0. X is equals to 4 comma 2. But you know what? Between 3 to 5, you cannot accept 2. Only 4 will be accepted, right? So this is your second case. This is case number 2. What about case number 3? So case number 3 says that x should be less than or equal to 3. When x is less than or equal to 3, both factors will get open with a negative sign. 2 negative sign, overall positive. So that means this will get open with a positive sign. That means the whole calculation will be same. So roots will be 5 plus root 3 comma 5 minus root 3. 5 plus root 3 so doesn't lie in this interval. So we are rejecting. 5 minus root 3 also does not lie in this interval x. It is not less than 3. Neither it is equal to 3. So case 3 is altogether rejected. Only two values are accepted, 4 and 5 plus root 3. So option B is absolutely right. Okay. Plus 6x you are saying? उधर जाके minus हो गया ना? हाँ. I have shifted everything towards the right hand side. Okay. Yes. A and D same option hai. Okay. Anyway, A and D both are incorrect. Yes, option B is absolutely right. All right. So these kind of questions are like hot questions for your JEE Mains 2024 as well. Now, you know what? NTA is actually after common root. Actually, single common root is their favorite topic these days. So single common roots, here we have this question which says that these two things, these two quadratic equation have one common real root. Single common real root. What does that mean? So I already told you that my favorite method is method number 2, when you have to solve these two equations and you know what, solve these two equations and get that common root. So just simply subtract these two. So x square minus 5ax plus 1 minus x square minus ax minus 5 is equal to 0. Subtract these two. X square gone, minus 5a, so this will become minus 4ax, right? 1 plus 5, 6 is equal to 0. This is 2, this is 3, right? So 2ax is equal to 3, x is equal to 3 by 2a. X is equal to 3 by 2a, right? This is what your one common root. So your common root is coming out as 3 by 2a. But I still don't know the value of a. Put this common root either in the first equation or in the second equation to get the value of a, so that you get a final proper common root. Put it 9 by 4 a square minus 5a times 3 by 2a plus 1 is equals to 0. Putting x is equals to 3 by 2a. So it will become 9 by 4a square. This is gone. 15 by 2 plus 1 is equals to 0. So 13 by 2, 9 by 4a square, a square. So a square value is actually coming out as what? 26 by, a square is coming out as 26 by 9. A square is coming out as 26 by 9. Put the value of a over here. So 3 upon 2 root 26. So this will become 9 by 2 root 26. This is equal to this common real root 3 by root 2 beta. Right? 3 3s are 9. Okay? And yes. Root 2. So root 2 will get cancelled out. Root 2 and this would be 13. So beta would be what? So beta, the value of beta should be equal to So the value of beta is, they are asking the value of beta. So this is alpha square is 9 by 26, alpha is 3 by, yes. So the value of beta should be 13. Eventually the value of beta should be 13. Okay? Alright? Yes? Yes, 13. Beta is coming out as 13. Yes, alright, perfect. Now we have another question again. You know what, 2023 was all about common roots from quadratic equation. Okay, alpha comma beta be the roots of the equation this, and alpha comma gamma be the roots of equation this. You know what, alpha comma beta roots of equation this, alpha gamma roots of equation this. That means clearly it is showing that single common root, right? Yes, a is equals to 9 by 26. Now I have made some mistake, I guess. 9 by, so a is 9 by 26. Yes, 9 by 26. A square is 9 by 26. Okay, let me just correct my mistake. 9 by 26. In here, let me just correct my mistake. So 9 by 26. So x is equals to 3 upon 2 and a. So 9 root 9. So this will be 3 by 26. Okay, 3 cancel out. X is equals to root 6. Root 26 by 2 is 3 by 2 beta. Okay. And alright, I am not doing the calculation. Just put the value of a over here and you will get the answer. Okay? Yes, they asked the value of root or a. They have a common real root. Okay. So the value of a. Okay, alright. Yes. 9 by 26 ka root. So okay. Yes. So 3 by 2 root 2 beta ka root will be equal to what? Root of 9 by 26. So clearly beta is coming out as 13. Yes. I have made the question unnecessarily complicated. Okay. But you know the gist of it, right? The point was you need to subtract these two equations, get the value of common root, put the value of common root, and then everything will be sorted. The type of question demands this type of algorithm, right? Yes, okay. Let's just move on to this question which says that again they have common roots, okay? So alpha and beta are common roots of this. Tell me the value of sum of roots over here. Alpha plus beta is what? So 31 by 41. What about alpha beta? This is nothing but 3 lambda by 14. Okay? So we have beta, gamma, right? So beta and gamma, alpha and gamma, sorry, alpha and gamma. So alpha and gamma roots. Alpha plus gamma would be what? Tell me. 53 by 35. Alpha gamma is what? 4 lambda by 35. Okay? 4 lambda by 35. This is alpha. Now we need to solve these 4 equations. That's it, right? We need to solve these 4 equations. Because we have actually 4 equations and we have 4 unknown. If you notice, we have 4 unknown. What are the unknowns? Alpha, beta, gamma and lambda. These are the 4 unknowns. So the whole problem is all about your equation solving skills, right? So I'll be just telling you the algorithm. So first of all, you need to divide the second and fourth equation. Divide second and fourth. The moment you divide it, you will get beta by gamma, which is equal to what? Lambda, lambda cancels. So 3 by 14 upon 4 by 35. 7 2s are 14, 7 5s are 35. So it will be 15 by 8 is your beta. 15 by 8 gamma is coming as your beta. Okay? So now what you can do is you can plug in the value of what? Beta. Where? So alpha is eliminated, right? The value of beta, what you can do is you can actually plug in the value of beta here. Yes. So it will become what? Alpha plus beta, alpha beta, alpha plus gamma. Yes. So plug in the value of beta, beta minus gamma. Okay. Yes. So subtract these 2 equations. Subtract these 2 equations. The moment you subtract these 2 equations, alpha will be eliminated. This will become beta minus gamma. 31 by 41 minus 53 by 35. So now you can replace this beta by what? 15 by 8 gamma minus gamma is equals to this, right? 41 into 35, 35 into 31 minus 41 into 53. Okay, so you will get the value of gamma from here. Yes, you will get the value of gamma from here. This is the equation. So 2 things we have done. Divide second and fourth and subtract first and 2. So here alpha is gone and here also alpha is gone. So the whole question will be about what? Beta and gamma, right? The moment you divide it, you will get the value of gamma. Once you get the value of gamma, you will definitely get the value of beta. So beta is done, gamma is done. Okay? Beta is done, gamma is done, and yes, if you have beta, you can calculate the value of alpha as well. So alpha you have, beta you have, gamma you have. You can calculate anything you want. So let me just show you the values. Okay? So yes, that's what we have did. This is first, this is second, third and fourth. So divide third and fourth. Alpha will get cancelled out, lambda cancelled out. So you get beta is equals to 15 by 8 gamma. Okay. Subtract these 2, beta minus gamma you may achieve. So beta minus gamma is 7 by 10. And from here, if you put beta as 15 by 8 gamma, you will get the value of gamma as 4 by 5. The moment you get gamma as 4 by 5, put the value of gamma over here, 4 by 5. So you will get the value of beta as 3 by 2. Right? So you have gamma, you have beta. Alpha can be calculated, put anywhere. Alpha can be calculated because you have beta 3 by 2. And gamma can be, okay, so alpha, beta, gamma, everything you have. Right? You have all the values. 3 alpha by beta, 4 alpha by gamma. You can calculate easily. So this would be sum of roots. Product of roots will be multiply these 2 values and put it in the equation. You will get this equation. So the question is a bit lengthier on calculation, heftier on calculation, but the algorithm, the question is extremely easy, right? Yes, perfect. Okay. Now let's just pat your back because we have finished quadratic equations and we are moving on to our next topic, which is complex numbers. Okay? Alright, so let's revise complex number in a very efficient way and let's just look at the problems which were asked in 2023. Are we ready? Yes. Are we ready? Okay. Chalo. So सबसे पहले we will discuss what is the complex numbers, the theory of iota. ठीक है? We will discuss conjugate and its properties. We will discuss modulus, argument, right? We will discuss cube roots of unity and different forms, polar form, Euler's form, and then we will discuss the problems. Okay, iota and powers of iota. So you know that iota is nothing but square root of -1. If I square this, what do I get? Iota square will be equal to -1, right? If I multiply iota on both the sides of this equation, what do I get? Iota cube will be equal to minus iota. ठीक है? And if I multiply iota on both the sides, iota की power 4 will be equal to minus iota square. So there will be a +1. So this is basically the cycle of iota. Again, if I multiply iota both the sides, what do I get? Iota की power 5 is nothing but iota. Iota की power 6 is nothing but -1. Iota की power 7 is minus iota. Iota की power 8 is nothing but 1. Can you see that iota की power 4, iota की power 8? That means iota की power 4k is always 1. That is one thing, right? Yes. Now iota की power 4k plus 1 will always be equal to what? Iota की power 1. So this will become iota, right? Now iota की power 4k plus 2 will become what? Iota की power 4k will be 1, right? Left out will be iota square, which is what? -1. So this will become -1. Iota की power 4k plus 3 will become iota cube. Iota cube is minus iota, and next iota की power 4k plus 4 will be this only. So all these actually the generalized versions you need to remember. Remember the generalized versions. Okay. Perfect. ठीक है. So complex numbers and its algebra. So in complex numbers we have argand plane, right? This is our real axis and this is our imaginary axis. We consider this as y and this is your x, right? Okay. And a complex number z denotes x plus iota y, which is denoted by ordered pair x comma y, where x is nothing but real part of complex number, y is nothing but imaginary part of complex number. Okay, cool, nice. Basics about the complex numbers, nothing very tricky or difficult about it till now, right? I will tell you once the things start getting a little bit difficult. Till now it's very smooth. Now let's talk about conjugate. What is conjugate? You all must know the conjugate term. So basically conjugate term says that whatever is the sign of the imaginary part. So here imaginary part is y. Sign of imaginary part is positive. So just reverse the sign. If it is positive, make it negative. If it was negative, make it positive. You just need to change the sign. So if I ask you, okay, write down the conjugate. It is denoted by bar. Write down the conjugate of -2 iota -3. So what will you do? So this is your z actually, and I am looking for conjugate. What would be your z bar? So z bar would be find the coefficient of iota. Find the imaginary part. So if imaginary part is 2, it should be +2 iota -3. Rest everything should be same. Rest everything should be untouched, right? So this is how it is. Okay. Cool. This is all about conjugate. So there are some properties of conjugate which I want you to be aware about. So if I tell you that 3 plus 2 iota is a complex number, and you want to take conjugate of this complex number, so 3 minus 2 iota, and again if you take conjugate of this conjugate, this will become 3 plus 2 iota, which is nothing but z. So if you take conjugate twice, or even 4 times, or even 6 times, or even 8 times, basically even number of times if you take conjugate, you will get back to the z, right? But if you take conjugate once, or thrice, or 5 times, or 7 times, you will get the same z bar, the simple z bar, okay? Right? Perfect. Now if you are stuck with multiplication of two complex number and you want to take the complete conjugate, what you can do is you have two ways. First you multiply z1, z2 and finally obtain the standard form and then take conjugate. But you know what? You can avoid this. You have an alternative as well. So first take individual conjugate and then multiply. Right? That also you can do. Alright, same thing. If you have to find 3 plus 2 iota ki power 9 whole conjugate. So what you can do is, first of all, find conjugate. So 3 plus 2 iota ka conjugate and then power 9. So 3 minus 2 iota ki power 9. So this is it. ठीक है? Alright, same goes with division. First divide and then take conjugate, or what you can do is first take conjugate individually and then divide it. Right? Same goes with addition. Add and then take conjugate, or take individual conjugate and then add. Okay? And here you have same with multiplication. Now this is something which is important. Real part of z and imaginary part of z. Yes. Real part of z and imaginary part of z. So if you have z is equals to x plus iota y, z is equals to x minus iota y. The moment you add it, what do you get? Z plus z bar is equals to what? 2x. Or you can simply write this, z plus z bar by 2 is equals to x, which is real part of x. And if you want to subtract these two, it will become z minus z bar by 2 is equal to what? 2y times iota. So this is 2 iota times imaginary part of it. Just add an iota over here, right? So imaginary part of z and the real part of z. This is also very important. Yes? Okay. Alright. So these are all the properties of conjugate. Now, okay. So yes. So this I already told you that in conjugate what happens, properties of conjugate done. Now modulus and argument. Yeah, this is my favorite. So modulus of any conjugate modulus of any complex number is what? So this is your x comma y point, right? So distance from origin, this is modulus, this we all know. Suppose you have a point 3 comma 2, right? So distance from origin will be what? Your modulus. Okay, so I won't spend much time on modulus, but okay, but argument, what is argument? So argument is nothing but the angle which OP makes with the positive direction of real of x-axis. So this angle theta will be the argument. So I'll be just teaching you the 4 cases: 1 plus iota, 1 minus iota, minus 1 plus iota, minus 1 minus iota. We will be actually checking the, so the formula of argument is theta is equals to tan inverse y by x. This is a generalized formula, but this formula is not sufficient. The theta will depend upon the quadrant as well. So first of all, 1 plus iota. So 1 plus iota, that means it is in, so this theta will be 45 degree, or you can call it pi by 4 simply because this lies in first quadrant, right? This 1 minus iota, so 1 minus iota, 1 is here, minus iota is here, so you are somewhere over here. The moment you apply tan inverse y by x, you will get tan inverse minus 1. So this is the angle, minus pi by 4 is the angle, right? Minus 1 plus iota, so minus 1 plus iota will lie in the second quadrant. This angle is again pi by 4, but we are not looking for this angle. We are looking for this angle. So that basically this angle would be pi minus theta. So pi minus pi by 4 this time. So this is 3 pi by 4. Right? So this angle is theta. This is minus theta. This is pi minus theta. And last but not the least, when both are negative, so minus 1 over here. So we are looking for this angle, and this would be pi plus theta. Pi plus pi by 4 is equals to 5 pi by 4. Right, so pi plus theta, pi minus theta, theta are the answers. Alright? ठीक है? Yes? Alright. Properties of modulus. So properties of modulus, mod z is given as equal to 0. That means z is equals to 0. So that means mod z is equals to 0. Mod z is equals to 0. Okay. Mod z minus a is equals to k. Okay. So I will tell you about this, the geometrical interpretation of this. Geometrical interpretation of this statement. Who can tell me the geometrical interpretation of this particular statement? Who is going to tell me? Who has actually studied this complex numbers nicely? So basically mod of z minus z1 is equals to k. What does that depict? This depicts, so we have a fixed complex number z1 in our Argand plane. We have a moving complex number z. Distance between these 2 points is nothing but k. That's how it is interpreted. Very important. Mod of z minus z1 is equals to k. है ना? Distance between z and z1 is nothing but k. That's how it is. ठीक है? Now please help me interpret this. So this can be written down as mod of z minus 0 is equals to 0. That means distance between z and origin is nothing but 0. So there is a complex numbers whose distance from origin is 0. So that complex number will be what? 0 only. Right? So 0, 0. So that means agar distance with origin is 0, that complex number itself will become what? 0. ठीक है? So this is the first property. Second property is what? Mod z is equals to mod of z bar. So if you want to take conjugate or the modulus of conjugate or modulus of complex number itself, both will be same. You know the reason. You know it, right? So if I talk about 3 plus 2 iota ka modulus should be equal to 3 minus 2 iota. Why? Because square root of 9 plus 4, 13. 13. ठीक है? Alright. Okay. And the same properties which we follow in conjugate, we follow in modulus as well. You can separate out in the multiplication, in the division as well. And this very property is very important, which is what? Z bar is equals to mod z square. Z bar is equals to mod z square. Very important. Please write it down in your notes as well. Z bar is equals to mod z square. Don't worry. I will make sure that you remember this property. Give me just 5 to 10 minutes. Okay. Just switching to the properties of argument. Okay. Properties of argument. Now you know what? I already told you. Conjugate की properties and modulus की properties is somewhat similar. ठीक है? But argument की properties is exactly same as logarithm वाली properties. Yes. So properties of argument and properties of logarithm are similar. I'll show you how. So the moment you see argument of z1 multiply z2, it would be argument z1 plus argument z2. ठीक है? The moment you see argument z1 by z2 is equals to argument z1 minus z2. Now you know why I was saying this logarithm. Log m by n is equals to log m minus log n. Same, right? And you know what? One more thing. Argument of z ki power n will be equal to, so this n will come in the front. So n times argument z. And this is something which is thoda different. Argument z bar is equals to minus of argument. Now this is something which is addition to the logarithm property. So this you should remember. Yes. Okay. Now there are few things about the argument that I would like to show you about the argument itself. If you say that theta is an argument, if you say, for example, this I showed you this, right? If you see 1 plus iota has which argument? Pi by 4, right? This pi by 4 actually is a principal argument. Principal argument is pi by 4, but if you use this term argument only now, that means it will have pi by 4 plus 2 pi as an argument. Pi by 4 plus 4 pi also will be the argument. Pi by 4 plus 6 pi will also be the argument. There are infinite arguments. But if you specifically use this word principal value of the argument, or you can call it as amplitude as well. Somebody was writing it amplitude as well. Fourth is wrong. Fourth क्यों wrong? Fourth is wrong. Why it is wrong? ठीक है, तो amplitude या principal value of argument, if this is mentioned, then your angle should be lying between minus pi to plus pi. Minus pi to plus pi. ठीक है? All right? Yes. Minus pi to plus pi. Argument of purely imaginary number is plus minus pi by 2. ठीक है? Argument of purely imaginary number is what? Plus minus pi by 2. What does that mean? That simply means that यहाँ पे if you are here or if you are here 0, 2, right? Z is equals to 2 iota or Z is equals to minus 2 iota. Can you see that 0, minus 2? In this case, can you see this? This is 90 degree and this is what? Minus 90 degree. So plus pi by 2 and minus pi by 2, right? Yes. And argument of purely real number is 0 or pi. So again, so this is what? 2. This is what? Minus 2. So purely real number is what? Purely real number is 2. Purely real number is what? Minus 2. So purely real number, if it is positive, the argument is 0. And if it is negative, the argument is pi. Okay? And if the complex number is z is equals to 0, then argument z is not at all defined. Argument A is not at all defined. Okay? All right. Perfect. Chalo. Let's move on to the next thing, next properties, some important properties. So I was already telling you, hold for one property, which was that property. So that one property was z bar is equals to mod z ka square. This is something which is really important. So suppose you are given with mod z is equals to 1. Mod z is equals to 1 in this property implies your z bar is nothing but 1 by z, and we are going to apply this property in our upcoming question as well, right? So if your z, mod z square is what? 1. Mod z is 1. So z bar will be 1. So z bar is equals to 1 by z. You must be wondering, ma'am, ये क्या बोल रहे हो आप? What are you saying? What is this property? I'll show you what I am trying to say. So this, if I want to prove it, z is what? X plus iota y. Z bar is what? X minus iota y is equals to mod z ka square is what? X square plus y square. Can you see that if you solve it, you left hand side is also x square plus y square. That's the proof, right? That's the proof. Clear? Perfect. So I guess this property now is sorted. This again is sorted because in case mod z is not 1, it is some a constant. So your z is equals to a square by z bar, right? Okay. All right. Now what about this? Okay. So basically z1 bar plus z2 bar all the way up to zn bar. If you want to solve this, what you can do is you can just remove this bar and take the complete modulus, right? So the whole expression conjugate, right? And you know what? You know this property, mod z bar is equals to mod z. Apply this property. So this bar is also of no use because modulus is involved. So this will become mod of z1 plus z2 plus z3 all the way up to zn. And if you understand this property, this is again same thing. Just remove the smaller conjugates, apply the bigger conjugate, and remove this conjugate, because if you remove this conjugate also, the property says that it doesn't matter. Right? Are you getting it? Yes? Yes? Okay. Shall we move on to the problems? Before moving on to the problems, two small topics and then problems. Okay? Before moving on to the problems. Okay? So give me some time to show you the transition between all the forms. And you know what? These type of problems, I know that you all struggle with these types of problems. So if you have x plus iota y as a complex number, I will show you that how we are going to do that. Okay, let me just take the example. Z will be equal to, so this is theta now, 1 plus 2 iota. Okay, Z is 1 plus 2 iota. Cos theta 1, sin theta. Okay, x plus iota y. So you all know about this. Mod z is what? Tell me the value of mod z. So mod z is square root of x square plus y square. And in here, theta would be what? Tan inverse y by x. So tan inverse y by x. So tan inverse y by x, right? So it would be tan inverse 2. उल्टा कर लो. ऐसे कर लो इसको. Sorry. It is root 3 by 2 and 1 by 2. Yes. So tan inverse y by x. So it should be what? 60 degree. Calculate this for me. Theta is what? Tan inverse 1 by 2 root 3 by 2. So this is what? 30 degrees. So pi by 6 now. Pi by 6. Yes. Pi by 6. So pi by 6 is theta. What about mod z in your case? So mod z is nothing but 1. Correct? Correct calculation. Okay? If we want to go into the polar form, right? So your polar form, you need to know the r. R is nothing but modulus only. And theta should be what? Your argument. And you are sorted. Okay? So let's just convert this into which form? R cis theta form. So z will be equal to r times. R is what? 1 cos of pi by 6 plus iota of sine pi by 6. Okay? Cos pi by 6 plus iota sine pi by 6. Cool? And z will be equal to 1 times e ki power iota pi by 6. Yes. So this is the conversion. These are the conversion, right? These are the conversion. So can you see the same thing in normal form of complex number x plus iota y algebraic form? This is your polar form and this is what? Your Euler's form. All three values are equal, by the way. All the three values are equal. Why are you laughing? What? Something happened kya? All in one. You are talking something in Telugu. I don't understand Telugu. Okay? Alright. Now one very important thing. Now this is something which many students fail to understand. Okay? So basically, here can you see one thing? Have you noticed one thing? Cos theta plus iota sin theta can be replaced by e ki power iota theta. These two are actually same thing. Cos theta plus iota sin theta is equal to e ki power iota theta, right? Yes. So what if I do one thing? I take power of both side. I raise to the power n. So if I raise power n over here, and here it will look like this. What about this? E ki power iota n theta. Right? E ki power iota n theta. And you know what? I already told you in the beginning. E ki power iota theta will be cos theta plus iota sin theta. Right? e की power iota theta will be cos theta plus iota sin theta. Tell me, if I replace theta by n theta, what will happen? Tell me. E की power iota n theta will be equal to cos of n theta plus iota sin n theta. And that's what I'm going to do it. E की power n theta will be what? Cos of n theta plus iota sin n theta. So is it now making sense? Is it now making sense? Because this, basically this thing, this n will go inside this theta and this theta. This doesn't make any sense to some students, but now I have proved it by using Euler's identity. Now you know why I am replacing this theta by n theta all the way, where n is an integer, right? Yes. Perfect. Let's just okay, cube roots of unity is something which is very important. So I will discuss cube roots of unity, but I want to solve a question. JEE Mains 2023, can you see? And the question is saying that this complex number is purely imaginary and we are looking for sum of elements in A. So this complex number, let me just write this complex number, 1 plus 2 iota sine theta upon 1 minus iota sine theta. है ना? This is what? Purely imaginary. Purely imaginary when a number, when a complex number, if I say x plus iota y is purely imaginary, what does that mean? That means real part should be equal to 0. That means x should be equal to 0. This is the condition I will be applying in this, but before that, I want to get rid of iota from the numerator, from the denominator, right? Because then only I will be able to fetch the real part. Let's just rationalize it. So 1 plus 2 iota sine theta and 1 minus iota sine theta. Okay, multiply. 1 plus iota sine theta upon 1 plus iota sine theta. ठीक है? A minus B, A plus B. So A square minus B square. So A square minus B square will be plus sine square theta. That's it. In the numerator, find only real part, because that's what you have to make it 0. Do not chase the imaginary part. Iota thing ignore, only talk about the real part. So 1 will get multiplied, I will get a real number 1. 1 will get multiplied with iota, I don't care. Okay, 2 iota will get multiplied with 1, I don't care. But 2 iota and iota will get multiplied, I will get iota square, which is minus 1, which will give me a real number. So that would be minus 2 sine theta. So this is my real part, plus iota times I will be getting something over here which I am not at all interested in, because now this is my complex number and this complex number is purely imaginary. That means this part should be equal to 0, right? Square. This part should be equal to 0. So 1 minus 2 sine square theta should be equal to 0. So sine theta is either plus 1 by root 2 or minus 1 by root 2. So in this interval 0 to 2 pi, I can get pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. These 4 values I'm gonna get, and if you add, because we are looking for sum, if you add all these 4 values, these 2 values will get 2 pi and 2 pi. So 4 pi is absolutely right. Yes? Okay. Perfect. Yes, nice question by the way. Let's move on to the next problem, and this problem involves 2 things. What are those 2 things? One property, which is z bar is equals to mod z square. Another Euler's form, which I taught you. ठीक है? All right. So if you know those 2, these questions will be solved in fraction of seconds. Yes. So take some moment, identify a few things about this question. So the value of 1 plus sine 2 pi by 9 plus iota sine cos 2 pi by 9, sine 2 pi by 9 minus iota cos 2 pi by 9. So I can clearly see if I take this as my z as a complex number, this will become what? Z bar, because this is conjugate of it, right? So I can write it as 1 plus z upon 1 minus z, 1 plus z bar, right? And power is what? 3, and z I am assuming it as sine 2 pi by 9 plus iota cos 2 pi by 9. And you know what? If you try to find out mod z, you will get what? You will get actually 1. Mod z is 1. When your mod z is 1, then z bar is equals to mod z square. So z bar is 1. Z bar is nothing but 1 by z. This property I already taught you, by the way. Yes or no? Z bar is 1 by z. So this z bar will be removed and replaced by what? Right? So this is what? So if you solve it, everything will get cancelled out. Take LCM. Z plus 1 gone. This z cube. So basically what you are looking for is z cube. Right? Z cube is what? That means cube of this quantity. Right? So z cube, that means cube of this quantity, sine 2 pi by 9 plus iota cos 2 pi by 9. And you know what? Basically, the familiar thing which I know is cis theta. So cos theta plus iota sin theta is something which is standard. This is what we follow. Cos theta plus iota sin theta is what we follow, right? But this is something distorted. What I can do is, I can actually take minus sign, I can actually take iota common. Take iota common because I want cos theta plus iota sin theta. The moment you take iota common, it will become iota cube. It will become cos 2 pi by 9, and it will become what? Plus 1 by iota sin 2 pi by 9 whole cube. Right? Now just rationalize it. Iota square will be minus 1. So this will become what? Cos 2 pi by 9 minus sin 2 pi by 9 iota ka cube. And this cube will join this theta. I told you now that property. This power will come in and join this 9. So cos 2 pi by 3 minus iota sin 2 pi by 3. Right? Cos 2 pi by 3 is minus half. And sin 2 pi by 3 is what? Plus root 3 by 2 iota. And outside this I have iota cube, which is what? Minus iota. So multiply it with minus iota as well. Multiply it. Get the answer. So plus 2 plus 1 by 2 iota. Okay? Iota will get multiplied. So iota will get, it will give me minus 1. Right? So iota cube is what? Minus iota, right? And this is what? 2 pi by 3 is what? Minus half. Sin 2 pi by 3, sin 120 degree is positive, so this is negative. Yes, minus. So it will become what? Plus, minus plus, and again 1 minus root 3 by 2. This is your answer. Half iota minus root 3 by 2 is your answer. Right? Half iota minus root 3 by 2 is your answer. So half iota, can you see this? Half iota and minus root 3 by 2 is only matching with option B. Ma'am, how do you know modulus of z is 1? Avinash is asking. Avinash, very good question, but you are a little bit late. If I assume this as my z, so this is my x, right? Plus iota y. X plus iota y. Sin square theta plus cos square theta is 1. Modulus is what? Square root x square plus y square. Yes. Okay. I hope your doubt is clear. Thank you for asking, because maybe many students were having this doubt. Okay. Alright. Chalo. So we are done with what? Quadratic. We are done with complex numbers. Okay. Cube root of unity. Chhod diya. Cube root of unity. Cube root of unity. This is very important, huh? This is very important. So suppose we have z cube is equals to 1 as my equations, right? So z cube is equals to 1 can be solved as what? Z cube minus 1 is equals to 0. So a cube minus b cube is what? A minus b, a square plus ab plus b square, right? So this will give me z. First root will be 1, of course. One of the roots is 1. What are the other two roots? Because this is a cubic equation, it will give me 3 roots. So one root is 1. Another 2 roots are imaginary roots which occur in conjugate pair, right? And this will give me those imaginary roots. Apply the quadratic formula, -1 plus minus square root of b square minus 4ac. So this will be what? Root 3 iota by 2. So this is what it is, -1 plus root 3 iota by 2, -1 minus root 3 iota by 2. This you can call it as omega, and this would be what? Omega square. Because if you try to find out square of this, now you will get this only. This is the another next level magic thing. Okay, that's why we call it as 1 omega square. Okay, so 1 omega square. So omega, so basically, yes. So basically what I am trying to say is, if x cube minus 1 is equals to 0 has 3 roots, 1 omega square. So first of all, sum of all roots, theory of equations, sum of all roots 1 plus omega square will be coefficient of x square. Coefficient of x square is 0. So this will become 0, right? And yes, product of all 3 roots. So 1 into omega cube will be equal to minus of -1 by 1. So it will become +1, so omega square. So omega cube is what? 1. Right? So we have a cycle for omega as well. And the cyclic order says omega cube is 1. Right? Omega power 4 is what? Omega cube omega. So this will become what? Omega. Right? Omega power 5 is what? Omega cube omega square. So this will omega square. Omega power 6 is what? Oh, omega power cube ka or cube. So this will become 1 only. So omega power 3 follows a cycle. I will show you the cycle omega power 3. Okay, so here you can see omega power 3k would be 1. This would be omega. This would be omega square. So that is also true. Okay. Alright, and z cube minus 1 can be written down as what? So it has 3 roots. So first root, second root, third root. Clear? Cube roots of unity, I guess clear hai? Yes, conics we will do. Conics also we will do. Do not worry about that. Okay. And you know what? There is one more thing actually which can come in my mind, that if z square plus z plus 1 is 0, so this equation alone is having 2 roots. We have already calculated. So roots of z square plus z plus 1 are omega and omega square. But we have a similar quadratic equation, by the way. You never know. This can come, this can appear. This particular term can appear, z square minus z plus 1 out of the blue. Now this has roots minus omega and minus omega square if you calculate it. Just for the remembrance. Okay? Okay? Let's just start what? Let's just start with its sequence and series. Are we ready for sequence and series? Okay? So let's just meet after 1 minute water break. So it's 6:14 now. So 1 minute. I'll be back in a minute. Water break. I'll sip some water and I'll be break. It's not a break, but a 1 minute quick break. Alright, I'm back. Sequence and series, again, I told you already, sequence and series is actually after binomial theorem. If I say in algebra, and of course matrices, binomial and sequence and series, these three topics, matrices, binomial, sequence and series, these three topics are scoring topics of algebra. ठीक है ना? चलो. So in the sequence and series, what we are going to do is arithmetic progression, sum of arithmetic progression, you know, very basic, geometric, sum of geometric progression, yes. So all these things we are going to revise, very basic things we are going to revise. So I won't take much time in explaining you the concept of sequence and series, because there are not very much conceptual, but the questions and tricks related to questions are important. So let's just dive into AP and GP. So AP looks like what? A plus D, A plus 2D, comma, A plus 3D. Okay, and what would be the last nth term? So you can see A plus 0D. We are starting. The first term is A plus 0D. Second term is A plus 1D. Third term is A plus 2D. A plus, third term is A. So fourth term is A plus 3D. And nth term would be A plus n minus 1D. A plus n minus 1D. Okay? Okay, so this is your nth term. What would be the sum of n terms of a arithmetic progression? So Sn would be n by 2, 2a plus n minus 1d. Yes, I will do conics, do not worry about it. So n by 2, 2a plus n minus 1d, this is your sum of n terms, right? Or another formula to it, n by 2 first term plus last term. So all these three formulas, so everybody should remember. If you don't remember this formula now, so I am very, very disappointed. I mean, please don't tell me that you don't know these formulas. Everybody should know this. And what about the GP, the standard notation? AR square, AR cube, and all the way up to AR power n minus 1. This is what? N minus 1th term. Again, can you see the similarity? There is some similarity. N minus 1 is used in both. So general term is AR power n minus 1. Sum of n terms would be what? A times 1 minus r ki power n upon 1 minus r, where r is not equal to 1. Okay? And S infinity, okay, the moment, okay. So now if your common ratio, r is your common ratio, here d is your common difference, you know. The moment you say that your common ratio lies between minus 1 and 1, that means you are telling me that your common ratio is fraction. That means your series is gradually, term by term, it is gradually decreasing and it is converging, and the final term would be, the last term would be 0. So you can calculate the sum of infinite terms. In that case, the moment you plug in r ko fraction, n ko infinity, this r power n will go very, very, very smaller. This smaller that we can neglect it. So sum of infinite terms would be a upon 1 minus r, provided your r is a fractional quantity, whether positive or negative. Okay? Okay? Clear? Alright. There are some important points related to arithmetic progression. So basically this was the theory of AP and GP, right? So basically theory is very easy, sequence and series mein, but there are some important tricks, some important points which you should remember to crack the question, to decode the question, to know the drill of the question, to deal with any question or to tackle with any question, right? Yes, are you getting my point? So understand those tricks and tips related to arithmetic progression, properties you can say. So basically if you have two common terms, this is the first, is very important. If you have two arithmetic progression, for example, right, first one is what? 2, 5, okay, and 8 and 11 and 15. Okay. The second one can be 11, then 13, then 16, okay, then 17, no, 17 no, 13, ओके 11 13, 13 के बाद to 15 होगा ना, हाँ 15, 15 के बाद 17, yes 19, can you see? Yes. So if two arithmetic progressions you can see, and using their common terms, can you see the common term? 11 and 11 are common, then 15 and 15 are common, so 11 comma 15 and so on. I'm not sure. 5 5 और 3 8 8 और 3 11 15 11 12 छोड़ के 13 13 14 छोड़ के 15, हाँ ठीक है. So you can see there are some common terms in the series, ठीक है. So the common series I have taken a bad example actually, but what I'm trying to show you is if you have two series, suppose series number 1 is having 3, 11 and so on, and it is 5, 7, 9, 11 and so on. So if you want to form another new AP which will only contain the common terms, only the common terms related to both the terms, so the following the resultant sequence will also be an AP with common difference will be LCM of common difference of both the series. So if you want to form this D1 and D2, take LCM of these two, you will get common difference of the resultant AP. Yes? Are you getting my point? Are you getting my point? है ना? So this question was asked in JEE Mains 2023, and I have made sure that I have done some popular question in mock tests and the session as well. So we have done these type of questions in our previous sessions already. ठीक है. Second point, if three terms are in AP, then if you multiply any constant in AP, that resultant sequence will also be in AP. If you add or subtract anything, any constant from all the terms of the AP, the resultant thing will also be in AP. ठीक है? So in arithmetic progression, you are allowed to multiply, you are allowed to add something, you are allowed to delete or subtract something. The resulting sequence will still be in AP. ठीक है? Alright. Some of the terms equidistance are okay. So this I already told you, 2, 4, 6, 8, 10, 12, 14, 16, 18. First and last term will be 20. Fourth and 16 will be 20 again. 6 and 14 will be 20. 8 and 12 will be 20. So basically sum of terms equidistance from the beginning and end, first and last ka sum equal to second and second last ka term equal to third and third last ka term, right? Assuming 3 terms, assuming 4 terms. Now this is something which will help you to solve multiple tricky problems. The moment you see 3 terms are in AP or 3 consecutive terms of AP, you should know that all the terms should be taken as like this: A minus D, A plus D, right? And the common difference of these things, this sequence will be D only. When you have to take 5 terms in AP, it would be the similar A plus D and A minus D, like this, right? Like this, and one term ahead of it would be A plus 2D, one term previous to this would be A minus 2D. So this consists of 5 consecutive terms of an AP. Again, the common difference would be D. Right, so 3 and 5 terms are similar, but 4 terms, if you have to take 4 terms in arithmetic progression, it's a bit different. It would be A minus D, A plus D, and then A plus 3D and A minus 3D. Can you see that you have to add 2D to get the next term? That means common difference of this is slightly different. It is double of D. Right, so this is something which is different. Yes. 3 terms, 4 terms, 5 terms. Give me a big thumbs up. Give me a big thumbs up. Yes, are you guys with me? Okay. Again, similar thing for GP. Now I'll be very quick. ठीक है? So अगर if 3 terms are in GP or if n terms are in GP, you can multiply anything, the resulting sequence will still be in a geometric progression. You can raise the similar power to each and every term. Again, the similar thing will be in a GP. Okay? Alright. And if 4 terms are in GP, then what can happen is A plus B, B plus C, C plus D will also be in GP, and the same goes with A minus B, B minus C, C minus D will also be in GP. Right? Okay. So in previous case, in arithmetic progression, I told you that the moment you see that things are in arithmetic progression, sum of first and last, sum of second and second last, sum of third and third last are equal. But in case of geometric progression, there is a slight difference. So if I say 2 and if I say 2.3, 2.3 square, 2.3 cube, 2.3 power 4 and so on, right? So first and last ka product would be what? So 2 2s are 4, 4 into 81. Second and second last ka product, so it would be 4 into 81, again same. Are you getting my point? So this time product is same. So this time product is same. And if you have to assume 3 terms, 5 terms, okay, if you have to assume 3 terms, 4 terms, 5 terms in geometric progression, the drill is similar. It would be A, and then the next would be AR, A by R. Similar, A, AR, A by R, and AR square, A by R square. Okay? So this is 3 terms in GP, 5 terms in GP, common ratio will be R. If you know AP now, then these things are similar, right? So this is A by R, AR and AR cube, A by R cube. The common ratio is what? R square. Do you notice? From here till here you have to multiply by R square. Not by R, but R square. Okay? Alright? Perfect? Alright. Arithmetic mean, geometric mean and relation between AM and GM. Alright. But before that, I have a question for you. Let's solve it. Let's solve a question. Let A1, A2, A3 and all the way up to AN be a geometric progression of increasing positive numbers. Sum of 6th and 8th term be 2 and the product, okay. So A6 and A8 is given as 2. Product of 3rd and 5th term will be 1 by 9. Okay? So you have to solve these 2 things and eventually let me know whether this is achievable or not. Right? We have to figure out what? A2 plus A4, A4 plus A6 ka value. Shall we start? Shall we start? ठीक है, A6 plus A8 is given by 2. Quickly, A6 is what? AR power 5 plus AR power 7 is equal to 2. Take something common. AR power 5 is common. So 1 plus R square is given as 2. What about this? So AR square, AR power 4 is what? 1 by 9. ठीक है? So it will become A square R की power 6 is equals to 1 by 9. Or I can write it as AR cube is equals to either 1 by 3 or minus 1 by 3. But question says increasing positive numbers. So AR cube is 1 by 3. So AR cube can be actually put 1 by 3 over here. So AR cube R square 1 plus R square is equal to 2. So AR cube is what? 1 by 3. R square 1 plus R square is what? 6. Right? So this is your thing. R square into 1 plus R square. From here, how many students will be able to tell me directly what is the correct answer of R square? So R square is 2, 1 plus R square is 3. So R square value, let me just write it as 2 only. R square is given as 2. Right? The moment I put R square as 2 over here, so it will become A 2 root 2 is equals to 1 by 3. So A is coming out as 1 upon 6 root 2. You know the value of R, you know the value of A. What are you waiting for? Just plug in the value over here. So A2 plus A4, AR plus AR cube AR cube plus AR power 5. 6 times. R is common. A is also common. Take AR common, 1 plus R square. And from here take AR cube common, 1 plus R square. You know the value of 1 plus R square? 3. This is also 3. AR cube, 1 by 3. Right? So you are left with what? 6. Right? So just put the value 6. R is what? Root 2. And this is what? 1 by 6 root 2. Okay? Into what? 3 into 1 by 3 into 3. 3 is the right answer. Yes. ठीक है? Perfect. Perfect. Perfectamundo in the chat box. Show some fire. Show me something that, okay ma'am, we are here with you. We are listening to you. Okay? ठीक है? चलो. Now let's just understand this arithmetic mean. So arithmetic mean. Arithmetic mean of two numbers is sum of those two numbers divided by 2. Geometric mean of 2, okay. And arithmetic mean of 3 numbers is what? Sum of all 3 numbers divided by 3. I hope you know this. 2 numbers is sum of all divided by 2. 3 numbers sum of all divided by 3. And sum of n numbers is what? Sorry, mean of n numbers is what? Sum of all the numbers divided by n. You know this arithmetic mean, okay? So if you insert a single geometric mean between two numbers, what does that mean? That means these 3 things are in arithmetic progression. If you insert 2 geometric mean between these numbers, what does that mean? That all 4 numbers are in AP, right? This is what these 2 statements are telling you. This is arithmetic mean. Now what about geometric mean? Geometric mean between 2 numbers will be square root of product of 2 numbers. Geometric mean between 3 numbers would be cube root of product of 3 numbers. What about geometric mean of n numbers? So it would be a1, a2, a3 all the way up to an raised to power 1 by n. This is geometric mean between n numbers. Again same thing. If you insert single geometric mean, that means these 3 quantities are in GP. If you insert 2 geometric mean, that means these 4 quantities are also in GP. ठीक है? Yes. Yes. Now relation between arithmetic mean and geometric mean, this is something which is going to be the rock star of sequence and series. Yes. So relation between arithmetic mean and geometric mean. Okay? So you know how to calculate arithmetic mean between two numbers. This is AM and this is GM. AM is always greater than or equal to GM between two positive quantities. Here, mind it, A1 and A2 both should be greater than 0. Otherwise, though, we can't apply AM greater than or equal to GM. No. We can't do that. So, AM should be greater than or equal to GM is this only. Right? In 3 numbers also you can apply AM between 3 numbers greater than or equal to GM between 3 numbers. Now, can you see that greater than or equal to 0? Can you focus on this greater than or equal to 0? That means AM can be equal to GM. In what cases? Tell me. AM is equal to GM. So when AM is equal to GM and when it is greater than GM, so AM and GM both are equal when both the numbers are same. A1 and A2 both are equal. If you are clearly saying na ki okay, I am applying an equal to sign, I am taking these two quantities as equal, or if I am saying that the equality holds when all the numbers are equal. 2 numbers are involved, both are equal. 3 are involved, all 3 equal. N are involved, N are equal. So if all the terms are equal, then equality holds. If all are not equal, even if one term is not equal, then it is greater. It is always greater. Yes? Yes. Okay, Mahesh ka birthday hai. Happy birthday, Mahesh. But I'm so sorry, you have to study. ठीक है? Okay. Let me just wish you nicely. I hope that you celebrate your next birthday in your dream IIT. Alright? Yes. I hope this wish helps you to study on your birthday. Okay? Chalo. let's move on to the next problem from AMG, from sequence and series only. Okay. So the problem says that for 3 positive integers, this equality holds true. Okay. And it says that R is equals to PQ plus 1. And it says that these 4 numbers, if you are seeing on your screen, are in arithmetic progression with common difference half. Then we need to figure out R minus P minus Q. Basically, there are so many things given in this question. But what they are actually giving is, so this equation, 2 equations are given and 4 terms are in AP with common difference half. So let me just write the 4 terms. Okay. First term is 3. Second term is what? 3 of log x to the base y. Okay. Alright. And 3 log y to the base x. 7 log, ठीक है, z to the base x. ठीक है, 3 log x to the base y. So this is 3 log x to the base log y. Log x to the base log y. You need log x to the base log y. ठीक है, log x to the base log y. So let me just solve it. So take log. All the sides I am taking log. Then only I will be able to create it. So PQ square will become outside log x. QR log y equal to P square R log z. ठीक है? Taking log all the sides, all 3 sides. What I am looking for is log x to the base y. Now log x to the base y is nothing but log x by log y. Right? Now log x by log y. Log x by log y. Who will tell me the value of log x by log y is QR by PQ square. So QR by PQ square. Comma. 3 log y by log x. Log y. Sorry. Log y by log z is z. So log y by log z is P square R by QR. Comma. 7 log z by log x. So log z by log x is what? 7 PQ square by P square R. ठीक है ना? Hi Sadhana, good evening. Welcome to the session, Sadhana. Okay. Now that's it. You are done. Almost 50% is done. Now just the remaining part. So 3 Q cancel. So 3R upon PQ. 3 R cancel. P square by Q. And P cancel. So 7Q square by PR. All these 4 terms are in arithmetic progression with common difference half. Right? Common difference half. What would be the next step? So if this is 3, this would be 3.5. So this value is 3.5. 3R upon PQ is what? 3.5, or 3.5 can be written down as 7 by 2. You know why? Because common difference is half. If first term is 3, second term is what? 3 plus half. Right? Okay, so 3R will be equal to what? 7 by 2 PQ. And one equation is already given in here. R की value can be replaced by PQ plus 1. So in here 3PQ plus 3 is equals to 7 by 2 PQ. Value of PQ will be here only. So value of PQ, so 3 is equals to PQ by 2. So value of PQ is what? 6. PQ ka value is nothing but 6, right? Now what about this value? If this is 3, this is 3 plus half, this is what? 3 plus half, that is 4. This value will be 4. This is 4, right? So 3p square upon q is what? 4. And value of pq is 6. So this 3p square upon, here I can write 6 by p is equals to 4. So 3 2s are, so p cube is equals to 8. The value of p is 2. And since PQ value is, we know that 6, so So that means that Q ka value will be 3. P ka value, Q ka value 2, 3. So this is 2, this is 3. And the value of R is what? 7, right? So you know the value. 7 minus 2 minus 3. So 7 minus 5. 7 minus 5, option D, 2, absolutely right. Who is with me? Who was with me in this question till the very end? Let me just check. Manas. Only Manas. Namrata. Okay. We share the same name. Manas is also saying. Yes. Alright. DDD Sadhana is also with me. Chalo. Okay. So this question is also done. Let's talk about permutations and combinations. Let's talk about permutations and combinations. Okay? So we have completed quadratic, done. Complex numbers, done. Sequence and series, done. Permutations and combinations, here are we. Okay? Okay. Permutations and combinations. So first of all, we'll understand fundamental principle of multiplication. Then we will understand selection, arrangement, that is permutation and combination all together. Then circular arrangement and distribution of objects. Okay? Alright. We will have a break very soon because we started at 5 and it's not even 7. It's not been complete 2 hours. Right? We have to go we have a long way to go. No break abhi to. Fundamental principle of counting. So suppose I am here at Jaipur and I am here and I have to go to the Mumbai. So I started searching. I was in Jaipur. I was working with some institute, coaching institute. This is my real life example, by the way. I was staying in Jaipur. For some work, I had to reach Mumbai. I started opening the IRCTC websites. I started opening the flights. Then I saw that, okay, there is no direct connection between Jaipur and Mumbai at that time. But so when I digged into something, so I realized that, okay, I have to go to the Mumbai via Kota only. Right? Are you getting my point? Okay. So I checked, there were no direct connection flight. Direct flight nahi tha. So via Kota there were many flights. So suppose Jaipur to Kota I was finding 3 flights and Kota to Mumbai I was finding 2 flights. Okay. So Jaipur to Kota 1, 2, 3. Kota to Mumbai A and B. Okay. So the problem statement is, in how many ways I can go from Jaipur to Mumbai via Kota. Right. So in how many ways I can achieve that. So basically from Jaipur to Kota I have 3 different options. And means multiplication. So and from Kota to Mumbai I have 2 options. So overall using 6 different paths altogether I can reach to Mumbai from Jaipur via Kota. Right? Yes? Clear? Okay? So 3 multiplied to 6. So that means what you have done is you have actually applied the fundamental principle of multiplication you have used over here. So in here what happens is when you have 2 compulsory jobs one by one you have to do. So you have to just multiply and write down the final answer. So fundamental principle of multiplication says that first event can be done by m ways. Second event F can be done by n different ways. Third event can be done by p different ways. Then overall all the events can be done by sequence wise compulsorily, can be done by m into n into p ways. Okay? Are you getting my point? When to multiply? Fundamental principle of addition says, for example, okay, yes, I can take my example only, right? So basically I teach from Bangalore and Bangalore has how many studios? 7 studios in this particular office, in my office number 1. Okay? And 2 studios, this is a real situation by the way. 2 studios in office number 2, which is a nearby office. Okay? So here 7 studios, here 2 studios. So basically, in how many ways I can take my class? So it is very obvious that you need to add it, 7 plus 2. So I have 9 different options. So in this case, you are going to add. This is fundamental principle of addition. What is the difference between these two? So basically, the or term is the difference. Always talk with yourself and ask yourself whether it is a or and whether it is an or या फिर an and, है ना? Conflict between or and. ठीक है? So this is what and. That means I have to perform all the 3 events no matter what. I have to perform all the 3 events. In this case, I had to perform, okay, in this case, I had to perform both the events. I had to go from Jaipur to Kota. Was it possible for me to stay at Kota only? No, because I have to reach there compulsorily. That's why this multiply this, right? But in this particular case, I can either take my class from studio number 1 or from studio number 2 or from studio number 3. I have no compulsion that I should be present in each and every studio. So there is no compulsion that after Bangalore, after office number 1, I have to rush towards office number 2. No compulsion. I just want to take one class, right? Either from all these 7 studios or from these 2 studios. That's why we are adding. So fundamental principle of addition and multiplication. ठीक है? Yes. ठीक है? Okay. Permutations. Each of the different arrangements which can be, okay. So permutations we will study. First of all, let me just show you before permutation. Let me just show you everything about the permutation and combination. So basically, if I talk about combination first, combination means selection. Combination means selection. Okay? Combination and selection both are one and same thing. So if I talk about A, B, C, okay? If I talk about A, B, C, D, okay, A, B, C, D. So if I have to pick any 3 quantities, in how many ways I can do that? So A, B, C, second A, B, D, third A, B, D हो गया, A, B, okay, so A, C, D, and fourth is C, D, D. Yes, all this, एक बार D छोड़ा, एक बार C छोड़ा, एक बार B छोड़ा. B is missing here, A is missing. 4 cases I guess, yes, these 4 cases. So what I am doing here is I am selecting 3 things out of 4 things, and this can be done with 4C3. This is the combination. Combination means only selection, right? 4C3. So 4-3C is nothing but what? 4. So the moment I say NCR. What does 10C4 represent? Selection of 4 students out of total 10 students. Only selection. Are you getting my point? Are you getting the meaning of NCR? That means selection of R things out of N, R unique things. Can you see I have not repeated any selection. This is NCR. Okay, combination. Now what about permutation? Let me just talk about permutation. Permutation basically is selection plus arrangement. Selection plus arrangement. So 4C3. So if I talk about 4P3, I'll show you the formula, but I'm just telling you the notation. If I'm saying 4P3, what do I mean? I mean that I have 4 objects, let's say A, B, C, D, and I am taking 3 at a time, suppose A, B, C, and I am shuffling them as well. Matlab A, B, C, second B, C, A, and third it would be what? C, A, B, fourth it would be B, A, C, fifth it would be A, C, B, and sixth it would be C, B, A. All the 6 different arrangements. So this is counted as 6 times. Can you see? A, B, C is counted at 6 times because shuffling also matter. And here A, B, C was counted as only 1 time. So that's the difference between 4P3 and 4C3. So what 4P3 does is it selects 3 things and shuffle it. And then it go on and select another 3 things, shuffle it. It select another 3 things, shuffle it. Right? So basically each ABC can be shuffled as 6 times, 6 times, 6 times, 6 times. So here 4 things are 4C3 is equal to what? 4. 4C3 is equal to 4. But 4P3 is 4 6 are 24. Because permutation is all about selection and arrangement as well. Are you getting my point? Are you getting my point? Selection and arrangement, right? So basically what I'm trying to tell you is NCR is all about selection of R different things from N things. Okay? And NPR is all about selection and arrangement of N different things, of R different things out of N things. Okay? Alright. Yes, are you getting my point? So, you know what? One more thing. So basically, ma'am, what you said, let me just confirm it once. That 4C3 is selecting those 3 things, right, out of 4 things. And if I multiply 3 factorial to it, I'll be arranging those 3 things, right, shuffling. So this is selection, this is arrangement, and you know what, selection and arrangement can be guaranteed by this also. So yes, that is absolutely right. Selection and arrangement done by 4C3 and 3 factorial, and directly 4P3 one shot he can do it. Yes, 4P3 means that this only, right? Yes. Okay. So NPR, the formula for NPR is what? NPR ka formula is what? N factorial upon N minus R ka factorial. Okay. Alright. And what does that mean? Taking R things out of N and arranging it. Okay. Alright. Chalo. Now one more thing which I would like to revise, which is arrangement of alike objects. Suppose Mississippi, right? Mississippi. Who is going to tell me that arrangement of all these 11 letters can be done in how many ways? So Mississippi, 11 letters, 11 factorial upon. Now this M is appearing once, so it's sorted. But what about I? I is actually coming how many times? I1, I2, I3, I4. So basically 4 factorial will be divided. S is also appearing 4 times, so 4 factorial for S. And P is appearing twice, so it is 2 factorial, and we are sorted. This is what you need to do with alike objects. You need to divide it how many times? The frequency. You need to divide it by the frequency of the letter or the object. Okay? Clear? ठीक है. All right. ठीक है. So the permutation under some given condition, or this is something which is actually important. So suppose there is a scenario in which we have 10 people, and out of these 10 people you have to select 2 people, and you have a constraint. You have to form a team of 6. Basically 6 people ka team you have to, 6 ka team. So basically out of 10 people you have to form a team of 6, but it is given that 2 particular people are always included. ठीक है, है ना? So not the team exactly, so basically you have to arrange it as well, है ना? Out of 10 people you are looking for arrangement of 6 people. Arrangement of 6 people where 2 people should be definitely included. So if 2 people should be included, what should I do? Tell me. What should I do? If 2 people are always included. If 2 people are always included, so out of 10, 2 is gone. So 8 people are there. 8 people are there. Okay? 8 people are there, and out of 8 I need 4 people, right? Because 2 are already there. That can be done by 8C4. Right? Now I have how many people? 6 people. Right? Because 4 I already have, 2 I already have. So basically 6 factorial. So that's how we permute. Okay? That's how we permute. Okay? So this, you can ignore this. You can ignore this. Okay? Alright, so it should be what? 8C4 into 6 factorial. समझ में आया क्या किया? Did you understand this? 4 factorial. Yes. So what I did, out of 10 people, I have to form a team of 6 and arrange it as well in a linear fashion. ठीक है? Where 2 people should always be there. So 2 specific people, तो I know कि they are coming. ठीक है? So I need from rest 8 people. I now need only 4 people. 2 I already have. So 8C4, so selection of 4 is done. Now I have 4 mine and 2 those specific people are already like this only. So total 6 people are there. So 6 factorial. 6 factorial. Right? Why you are writing 2 factorial, 4 factorial? Please don't do that. है ना? Overall 6 factorial. So this is how it is. ठीक है? Up in the same fashion, you want those 2 people should not be included. Cancel those people. So if you want to cancel those people, so 10 minus 2 is equals to 8 people are there, and how many people do I want? I want 6 because 2 are gone. 2 are not with me. This time 2 are rejected. So out of 8 people basically 6 I need, right? So 8C6 into 6 factorial, or simply you can write 8P6. This time you can write both. This time you have both the options. So when one particular object is never taken, then what you can do is n minus 1 PR. When 2 particular object is never taken, n minus 2 PR. When 5 is right, you got the point. So here 10 minus 2 P6. ठीक है? Alright. Second point clear है क्या? First point clear है क्या? Let's talk about the third point now. Third point says the number of permutation of n different things taken are at a time where repetition is allowed. ठीक है? Suppose you have, okay, so let me just take one example. Suppose you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 digits are available. I'll explain you the scenario. Total 9 digits are available. ठीक है? 9 digits are available, and you have to form a 3-digit number, or you have to form a 4-digit number where repetition is allowed. ठीक है? So 4-digit number is to be formed. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 digits are there. So first digit can be filled in how many ways? 9 ways. Because you have 9 digits. You can place 1, you can place 2, you can place 3, 4, 5, 6, 7, 8, 9. Second place also can be filled by 9 ways. Third place, fourth place. So this is 9 raised to power 4. Now you know the number of permutation of n different things taken are at a time where repetition is allowed is what? So n raised to power r, that's how we do it. Yes. Okay. Alright, let's talk about the circular permutation. Now this is something which is important. So circular permutation में क्या होता है? So basically circular permutation में there are 2 things. Okay. The first thing is, suppose you are sitting in the round table, right? Are you getting my point? You are sitting on the round table. That is one thing. You cannot flip the round table, right? You cannot Flip the round table as in you cannot make the round table in such a way that it is standing against the gravity. You can't do that. You can just flip it. But one thing which you can flip it is your necklace. Suppose I am giving you a necklace, you can just simply flip that it, right? Suppose if I am giving you a circular garland, flower garland, so what you can do is you can just flip it. Are you getting my point? Right? So in that case, basically both the things are very different. I will show you how. Suppose I am saying that this is a round table. This is a round table. Understand one thing. This is fixed. The round table is fixed. Legs are fixed. Okay? And I am asking you to arrange red, blue and green. So red, then blue and then green. Okay, so you will tell me कि okay ma'am, red, blue and green is done. ठीक है, फिर what next you can do is RBG. So you will tell me okay ma'am, B, R and G. ठीक है, so B, R मतलब RBG and RGB. Okay, RGB, R के बाद G है. And after that, so B के बाद G था, B के बाद R था और RBG, BRG, G. Okay, so G, B, R. RGB हो गया क्या? RGB हो गया. R, so B here and B here. So RBG. Okay, actually only two ways are possible. Yes. In round table, RBG and RGB. RBG, RGB. Only two ways are possible. If you want to arrange three, so red, blue, green, three colors in round table, so RBG and RGB, only two ways are possible. Can you see that? Can you see that? Try, tell me what would be the third setting. What should be the third setting? You won't be able to find the third setting, right? So the formula for the round table is what? N minus 1 factorial. So in the case of three things, if you have to arrange three different colors in a round table, so that can be done by 3 minus 1 factorial. That is 2 factorial. Only two ways are possible, right? But what if I flip it? What if I flip this? Then only one way is possible. These two are same thing. These two are same thing. If I flip this, then what will happen? It will become red, then blue, then green. That is RGB. This is RGB only. If I flip it, it will become this only. Okay. So if you want to do this experiment, what you can do is you can take a thread. You can actually put three different pearls in it, and you can just check for yourself. If you're flipping it, okay, it is showing the same thing. Okay, right? So yes, what I was telling you about the concept, what you need to remember is circular permutation of n distinct object is n minus 1 factorial. If you are not able to flip it, just like round table, but if you are able to flip it anti-clockwise and clockwise, arrangement will be exactly same. So you have to divide it by 2, right? So for example, I already told you beads in a necklace या फिर arrangement of flower in a garland. ठीक है? Let's just solve a problem related to this and then talk about yes, see this we have already covered. Yes, let's talk about this dictionary problem. Okay, so I have already pretty much covered everything, the theory, and let's talk about the dictionary problem. Let's find out the rank of the word Monday. Let's find out the rank of the word Monday. Okay, let's find out the rank of the word. Who is with me? Who is going to tell me the rank of the word Monday? So the moment you need to figure out rank of the word Monday, you have a set algorithm. First thing is you have to set the thing in alphabetical order. So A will be the first. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R. Okay. So M, O, N, D, A, Y. Done, done, done. So can you see my M is here and two different letters are here. So first, let words starting with A will be what? So how many 6 are there? So 5 more. So that is 5 factorial. Words starting with letter D would be 5 factorial. Right? So 120, 120. Now here come my M, because Monday is starting with this. Now let me fix this M and think about naturally, organically, dictionary wise, who will be the next letter. So whoever comes first in the alphabet series will come here, and it is nothing but your A. So MA. My Monday does not start with MA, right? So I need to just count it, all the words starting with MA, and move forward and talk about in my priority list, M ke baad who is going to come next? D is going to come next, and again my Monday is not starting with this D as well. So I need to move ahead. M ke baad who is in the next list? So N is in the next list. So again 4 factorial is equals to 24. And you know what? Mn. After N, who is next? O, finally. MO. So MO. Now my word is going to get formed. But after MO, who is going to be here? Who is going to be here? Again, the priority is A, right? So MOA. But my Monday doesn't start like this, right? So MOA, just count it. So it would be what? 3 factorial and move forward. MOA. And then MOD. Count, move forward. Okay. MO is fixed, right? MOD. Now MON. Finally MON. MON is here. Now MON is here. What should be the next letter? So next letter would be A, and you can count it. And MON is fixed. What should be the next letter? A is done. Now D. What should be the next letter to it? A, automatically AY. So this is 1. Just add these things and you will get. So 240 plus 24 into 24 into 24. So 72. 6 plus 6, 12. 3. Right? 5, 6, 7. And 7, 8 to 12. And 327. Option D. Yes, D. D. Yes, my dear students, D is the correct answer. Absolutely lovely, amazing job. Okay, and you know what? Kya batao? This was asked in 2023. What do you think? This is very easy question. It does not even have 2 alike letters. No twist at all. Straightforward. Are you understanding it? And you know what? On the top of it, you are not liking my session. I can see so many students or live watching, but they are not liking it. I don't understand why. Is there any problem with YouTube button or your laptop? I don't know. Okay? Chalo. Let's talk about the round table thing, because we have studied the circular permutation. I want to talk about the round table permutation. Okay, so round table permutation says the number of ways in which 5 girls and 7 boys can be seated in a round table so that no 2 girls sit together. You know what? The moment I read this type of question, I find it really funny that why everything is against girls. Why people don't want 4-5 girls to sit together. What they are not harming anyone, but in the question also no 2 girls are sit together. No 2 girls can sit together. Every time I have seen very few questions where they talk about no 2 boys should sit together. It should be no 2 boys sit together. Girls should always be sitting together. But anyway, we have given a problem, we have to solve it, we have to accept it. Okay, they don't want girls to sit together. So the number of ways in which 5 girls and 7 boys, so no 2 girls are sit together. The concept behind such question, whether linear or whether circular, is, you know what? So suppose you don't want girls to sit together. So for a few seconds, forget about the girls. Only focus on boys. how to make 7 boys sit in round table? Who is going to tell me? So 7 boys are there. You have to make them sit in a round table. B1, B2, B3, B4, B5, B6, B7. 7 boys in circular table can be arranged in 6 factorial ways. Okay? Now what you need to do is you need to make 5 girls sit in the gaps. How many gaps are there? Gap number 1, gap number 2, gap number 3, gap number 4, gap number 5, gap number 6, gap number 7. So basically in round table, if there are 7 people sitting, how many gaps are generated? 7 gaps are generated. But I have only 5 girls. Okay, I want my girls to sit in these gaps. 7 gaps are available, but I have only 5 girls. So first of all, what I'll be doing is I'll be selecting gaps. 7C5. I want only 5 gaps. 2 gaps will be left out. Right? 7C5, and I want my 5 girls to sit together. And after that 5 factorial will be there. In here you don't need to apply what? That circular thing. You have already applied once. So rule of circular permutation is only apply the circular permutation once only. In one circle, n minus 1 factorial is done. Now no need to do n. 4 factorial won't be there. Now you have to solve it. 6 factorial. 7C5 is what? 7 into 6 by 2 and 5 factorial. Okay? Or what you can do is here 5 factorial. So here it would be what? 5 factorial, take out a 6 common. So 7 into 6 into 6 by 2, and yes, so 2 3s are 21 into what? 6. So 126 into 5 factorial, option D, done. Done. Yes, give me a big thumbs up. Another question, by the way. Another question, yes. AIM IIT Bombay, welcome to the session. Okay. So then let the number of elements in set A and B be 5. Now this is अच्छा question, nice question. क्या बोला है? Let the number of elements in set A and B be 5 and 2 respectively. That means number of elements in set A is 5. Number of elements in set B is 2. The number of subsets of A cross B each having at least 3 and at most 6 elements. Achha, very easy question. Try to understand this. सबसे पहले they are talking about subsets of A cross B. Do you know how many elements would be there in A cross B? That should be 5 into 2. That is equals to 10 elements would be there in A cross B. Right? But what about subsets of A cross B? Subsets of A cross B should be equal to 2 की power 10. So these are the subsets of A cross B. All the subsets of A cross B. I'm just trying to remind you. That's it. Nothing else. Okay? But what you are looking for, you are not looking for all the subsets. You are looking for actually the subsets having at least 3 and at most 6. So let's just forget about this. And A cross B is having 10 elements. So 10 elements may you want at least 3. At least 3 means you want case number 1 3 elements exactly. Case number 2 4 elements. Case number 3 5 elements. Case number 4 6 elements. That's it. That's it. So out of 10 elements you want 3 elements in your bucket. That can be done by 10C 3 ways. Or what you can do is you can keep 4 elements, so that can be done by 10C4. Or what you can do is 10C5, then 10C6. That's it. This is your answer. Right? This should be your answer. Now solve it. Now solve it. To solve it, I want to show you one very important property related to coefficients. Do you know about this property? And this property. Let me just show you 2 properties. What are those 2 properties? So 2 properties are, if you know that NC5 is there. Sorry. 9C5 is there. So 9C5 will be equal to 9C9 minus 5. That means 9C4. Right? So what I'm trying to say is, if you have this 9C0, 9C1, 9C2 and all the way up to 9C9. So 9C0 and 9C1 are 9C9 are same. 9C1 and 9C8 are same. 9C2 will share same value as 9C7. Can you see the pairing? In here 7 and 2 are making 9. In here 1 and 8 are making 9, 0 and 9. So basically what I am trying to say is 7C4 will make a pair with 7C3 because 4 plus 3 is what? 7 only. 7C2 will make pair with 7C5. Why? Because 5 and 2 are making 7 only. So this is what it is. NCR is equals to NCN minus our first thing, right? And the second thing is, okay, if you see 9C4 plus 9C5, what you can do is you can simply write, okay, 9 and 9 are same and 4 and 5 are having difference of 1. You can simply write it as 10C5. 10C5, right? So I'll be using this property in this given equation, right? This equation which we were solving. So the question was what? Question was having at least 3 and at most 6 elements, right? Out of 10, you have solved 10C3, then achieving a 4 element subset, 10C4, achieving 5 element subset, 10C5, 10C6. Can you tell me 10C4 plus 10C3 will be what? 11C4. Can you tell me 10C5, 10C6 would be 11C6. Now you know how to apply it. Do you know how to apply it? Okay. So 10C, now 11C4, 11C6. Oops, I can't solve it. 11C6 now can be written down as 11C5. You know how? Because again 6 and 5 are making 11. So 11C4 plus 11C5 now can be written down as 12C5. So 12C5 is your answer. Now 12C5 you can solve 12C5. 12C5 will give you 792 as your correct answer. ठीक है? Yes? Perfect? D. Chikoti? Yes? Okay. Binomial theorem. Binomial theorem. So binomial theorem is the last thing and then we will start calculus after that. Okay? So let me just tell you binomial theorem. And after binomial theorem we have matrices and determinants. Yes. So binomial, matrices and determinant, these two topics. After doing these two topics we will tap calculus part, and after the huge calculus we will tap the geometry part, conic section, and after that we'll solve vector, 3D, statistics, probability, 4 topics in the end. Okay? Alright. Okay. Shall we take 5-minute break before binomial theorem? है ना? 5-minute break. So 5-minute break. Let me just see you at 7:20. Okay? 7:20 p.m. Shall we meet? Session PDF will be shared on the Telegram. Okay? Okay. Drink some water, get some fresh air and then come back. 7:20 is already happening. 7:25. Okay. 7:25 पे मिलते हैं. ठीक है? Go out, walk a little. ठीक है? Walk a little. Okay, I'll be telling you at 7:25. I'll be actually telling you a 1-minute story and then we'll begin. ठीक है? Regarding an Einstein's walk. So there's a famous Einstein's walk which I want to talk about. I'm back. आ जाओ, come soon. है ना? Yeah, so I was talking about this Einstein's work. Now it will take 30 seconds, not more than that. We don't have time. So Einstein's was studying in some university, right? And in his university at that time, his work was very famous. So he used to solve very difficult problems, complex real world problems, right? And you know what, the moment he used to think in a certain way and then he was also not able to solve the problem, what he used to do was, he used to he used to close everything, shut everything down, like close the books, and he used to get up and he used to take a long walk around the university, and he used to come back, and you know what, the same question, but he used to think, he was able to think with a different approach. So whenever, it's just a tip, whenever you feel saturated, because this is going to happen, whenever you feel saturated, whenever you feel ki, okay, nothing is going into my mind, so remember that Einstein's walk, it was helping Einstein, so that means it will help you also, it helps everyone. Come back with a fresh mind, 1 or 2 minute walk, come back with a fresh mind, you will see, okay, now I'm ready again, I'm fresh, I'm not at all saturated, I am very open to receive things, to receive study. Okay, yes, so this is what I wanted to tell you about the Einstein's work, and here we are. Perfect. So notations and factorial, NCR. So we will talk about first of all NCR, which we have, by the way, have little bit touched in permutations and combinations. We have already done that. Along with that, what is important is general term of binomial expansion is important. We will solve problems on based on that as well. And then binomial for any index is also very important. And binomial coefficient problems we will solve. Okay? Okay? So let's first discuss about this, which is, so very first result, which I already told you, by the way, and which is NCR plus NCR minus 1 is n plus 1 CR. Can you see this? Can you see this? NCR plus NCR minus 1 is equals to n plus 1 CR. Okay, what does that mean? That means if you have both n same, if you have difference of 1 in these two quantities, what you can do is, you can just add 1 and write whatever is bigger, r or r minus 1. Who is bigger? R is bigger. So write R. So this is the first thing, first formula which I want you to remember. The next formula which will be helpful is NCR upon NCR minus 1. Right? So can you see both n are same, but r and r minus 1 difference is there. So what you can do is, in the denominator you write this r, and in the numerator n minus r plus 1. So n minus this quantity, n minus this is n minus r plus 1, bracket will get open, and r will be here, the cross connection. Yeah, it is the cross connection. So if I ask you, okay, 9c5 upon 9c4. So, okay, so you can see 9 same, 5 and 4. So 4 will be here upon 9 minus this, 9 minus 4. So this would be what? 4 by 5 simply. Can you see that the problem NC5 by NC4 will have gotten a lot. So r minus 1, n minus r plus 1. So this is what? Sorry, this is NCR. So 5 is here. Okay, NCR. Okay, maybe I have made a mistake. क्या कर रही हूँ मैं? Yeah. So NCR upon NCR minus 1 in the denominator, you have to write 5. Yes, 5. Okay, and here 9 minus 4. So this is gonna be 1. This 5 should be here. 9 minus 4 should be here. That's it. 5 by 5, 1. Okay? Alright, perfect. Yes, that's how we do it. And one more thing. NCX is equals to NCY. If these two quantities are equal, then x plus y should be equal to what? N. X plus y should be equal to n. Yeah, first thing would be x and y should be equal. Okay, so these are the results related to binomial theorem. Okay, binomial coefficient basically. Now let me just talk about, so I have taught you already binomial theorem in this session as well. Let me just show you about this x plus y raised to power 4, how to expand it. How to expand it. So can you see x plus y raised to power 4? So first of all, this will contain 4 plus 1, 5 terms. This will contain 5 terms. Let me just write down all the 5 terms in front of you. So it will become 4c0, it will start with 4c0 and raise highest power of x but lowest power of y plus 4c1 x का cube y की power 1 plus 4c2 x की power 2 y की power 2 plus 4c3 x का cube y की power 1 plus 4c4 y की power 4. ठीक है? नो 3/5 नहीं, 1 ही आएगा. ठीक है? Can you see this x plus y की power 4 का expansion? What all observation do you fetch from this? है ना? These so you can, this is homework for you. Try writing it. What are the observations you get from the binomial expansion from any positive integer? So x plus y की power n start with nc0, x की power n, y की power 0. Then nc1. Can you see y की power 1 and nc1? This index and this index both are matching. nc2 y square. Can you see ncn minus 1 y की power n minus 1? ncn y की power n. So can you see this? That this is matching with power of y. ncr. R is matching with any time. R is matching with power of y. So if I want to write the general term, so general term would be NCR x की power n minus r, y की power r. And by the way, which term is this? Which term is this? So if I see first term is having 0, second term is having 1, third term is having 2, right? So which term will be having r? So basically r plus 1th term will be having this. So this is the general term which I was talking about. So general term tk plus 1, or you can write tr plus 1, ncr x की power n minus r, y की power r. ठीक है? So this is your general term. And now how many terms are involved? I already told you n plus 1 terms are involved in binomial theorem. Right? Yes? Are you getting my point? Let's just straight get into the question part. Let's just start solving it. ठीक है? Let's just start solving the question part. So here the coefficient of x raised to power 5 we need to figure out in the expansion of this. And you know what? The moment I see these type of questions now, it makes me wonder that, okay, so the straightforward question, this is a straightforward question which involves general term. So you have to identify this. So t, so basically tr plus 1, you just need to write general term, right? 5cr 2x cube की power 5 minus r minus 1 by 3x square की power r. Right? Yes. So it will become 5cr, and you know what? Now you are looking for coefficient of x की power 5. Collect the power of x. So x की power 3 5s are 15 minus 3r, and this x square, it will go in the numerator, it will become x की power minus 2r. So it will become minus 2r, and this you want x की power 5. So 15 minus 5r is 5. R is coming out as 2. The moment you plug in r की value 2, it will become 5c2, 2 की power 3 minus 1 by 3 की power 2. So it will become 5c2 is what? 10 into 2 का cube is 8 and 3 का square is 9. So 80 by 9, option B. Who is with me? Who is with me? Nobody is solving with me. I am super duper disappointed. क्यों? Nobody gave me answer before me. Why? Are you not solving it, or am I solving it faster than you? I don't want it. I want you to give me answer faster than me. Yes, Pramod is saying BBB. Yes, Pramod, I remember you. You were asking me. Okay, Sridhar is saying, can you explain once again? So yes, we need to figure out coefficient of x raised to power 5 in the expansion of this, right? So can you write the general term? I just told you the general term. General term looks like this: NCR, a ki power n minus r, b ki power r, right? Put the value of a 2x cube, value of b minus 1 by 3x square. Now collect the coefficient, the power of x. Power of x, from here I will be getting 15 minus 3r, from here I will be getting minus 2r. 15 minus 3r minus 2r should be equal to 5. The value of r is coming out as 2. That means what? The moment you put r is equals to 2, you will automatically get x ki power 5. But you are looking for the coefficient, right? You need to, so x ki power 5 will be there, right? But you are looking for coefficient only. So you don't focus on x ki power 5, you are looking for coefficient. Coefficient is this, which is 80 by 9. This is the algorithm. Yes, alpha question. Yes, 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 Sadhana, be absolutely right. Shall I give you another question? Okay. Shall I give you another question? Okay. So before actually another question, I have something very important to tell you. And yeah, that is 1 plus x ki power n and 1 minus x ki power n. These two are very popular. Can you see this? These are used very frequently, quite frequently. What is that? So 1 plus x ki power n can be expanded like this. NC0, that's it. NC1 x ki power 1. Can you see this? NC2 x ki power 2. Are you getting my point? NC3 x ka cube plus NC4 x ki power 4. Now you are getting my point, right? So here 2 and 2 will get matched. N and N will get matched. Okay? Okay? Perfect. Are you getting my point? Similarly, 1 minus x ki power n, if you want to look for NC0 minus NC1x minus plus NC2x square. So alternate plus minus sign will be there. Okay? And one very important thing actually. So if I tell you that, okay, 8 ki power n minus 1. So 8 ki power n minus 1 is always divisible by what? Always divisible by 7. Yes, 8 ki power n minus 1 is always divisible by 7. What does that mean? Understand the statement. Can I write 7 plus 1 or 1 plus 7 raised to power n minus 1? 1 plus 7 raised to power n minus 1. So if I expand 1 plus 7 raised to power n minus 1 like this, using this formula, so I realize that, okay, I will be getting NC0, that means I will be getting 1. And then after that, can you imagine, after that, each and every term till the last term, I have x. So if I take x common, I will be having x ka multiple. So the next term, 1 plus, or except this term, all the terms are divisible by x. So in this case, all the terms are divisible by 7. So I can write all the next term as 7k. Minus 1 is there. So that means this whole expression is always divisible by what? This whole expression is divisible by 7. है ना? So if I tell you that, okay, 10 ki power n minus 1 should always be divisible by what? Tell me, divisible by 9. ठीक है? Are you getting my point? Are you understanding this? Divisibility theorem only I am explaining, G1 art. Please understand so that we will be able to solve the problems. ठीक है? Alright. So this is what I wanted to tell you. This is what I wanted to let you know. कि 10 की power n is always divisible by 9. Or you can say 11 की power n minus 1 is always divisible by 10. So if it is divisible by 10, then it is divisible by 5 also. Right? So this is a trick. Now this is a trick. And if it is divisible by 10, it is divisible by 2 also. Right? So these things you should remember. Okay? Okay? Let's just talk about this divisibility problems because that's what you were waiting for. Okay? Let's understand this problem now. So 22 raised to power 2022 and 2022 raised to power 22. ठीक है. So we need to figure out when this whole thing 22. By the way, can you see this? This was asked in 2023. Understand this problem nicely. So 22 raised to power 2022 plus 2022 raised to power 22. ठीक है. अब question is asking you कि find the remainder when it is divided by 3 and find the remainder when it is divided by 7. So first thing, let's find out the remainder when it is divided by 3. So divided by 3, so 22. Can you think about any number which is close to 22 and divisible by 3? So yes, we know that 21 plus 1, because 21 is divisible by 3, 2022, right? And this, my dear students, can be written down as I already told you. In this, if you expand this, na, I already told you. Let me just show you. Let me just go back. The moment you see 1 plus 7 की power n, what did you write? 1 plus 7k. ठीक है? So here also you will do the same thing. The moment you see 1 plus 21 raised to power 2022k, can you write it as 1 plus 21k? This is 1 plus 21k, right? So this thing is saying that if you divide this thing by 3, you will get 1 as the remainder, right? Because this is multiple of 3. So you will get 1 as the remainder. ठीक है? Are you getting my point? Let's talk about this now. Now what about this? Oh my goodness. Did somebody notice? This 2022 is already automatically by default divisible by 3. It will give me 0 as the remainder. Right? This is 0 plus 3k already. Right? 3k1. So this is divisible by 3k only. So that means overall remainder, when you divide this whole thing by 3, will be 1, that is alpha is coming out as 1. Major breakthrough. ठीक है? Now let's talk about the beta. Beta when divided by 7. Let's talk about 7. So again, 22 raised to power 2022 plus 2022 raised to power 22. Let's talk about a number which is divisible by 7, which is closer to 22. It's already 21, right? So it is what? 21k plus 1. So when divided by 7 also, this term to giving me remainder 1. This is not an issue. This is giving me 1 as a remainder. What about this? Is this divided by 7? Is this divisible by 7? Automatically no. This time this is not divisible by 7. But we can still think of a number which is close to 2022, but that is divisible by 7, that is 2023 minus 1 की power 22. If you apply binomial theorem, you will have what? Minus 1 की power 2022 and plus all the rest of the terms will be having 2023k. So 1 remainder over here and 1 remainder over here, 1 plus 1 plus 7k1. So that is 7k1 plus 2. So 2 is the remainder. Beta is coming out as 2. Alpha 1, beta 2. So 4 plus 1 is equals to 5 is the answer. And here comes the very nice problem. Very beautiful problem. You know what? This type of question will come in JEE Mains 2024. And few students will be able to solve it correctly. Many students have solved it, but very few students will be able to solve it correctly. What you need to do is grab 5 to 7 problems, different variety, solve it right away, plus 4 marks straight in your pocket. Yes, and I have also taken these type of different variety of problem in mock test as well. So go back, check it out. 2023 also have variety of these variety of problems. So I am just already telling you. Here comes matrices and determinant. Here comes matrices and determinant. ठीक है? चलो matrices and determinant. Let's start. Let's begin. Matrices and determinant में matrices is most important. Determinants still have some important topics left, but since the properties of determinants has been deleted from the syllabus, so that simply means out of the whole chapter matrices and determinant, matrices became more important now. Okay, so we'll focus on matrices more. Types of matrices, algebra of matrices, transpose and its properties, some special type of matrix, adjoint of matrix and inverse of matrix, and system of linear equations. These three are hot topics. Can you see last three topics? Very, very important. How it is second 7K. ठीक है, चलो, I guess I'm getting request from the previous problem. Let me just explain you one time and then we'll move towards the matrices and determinant. 22 की power 2022, 22 की power 2022 and 2022 की power 22. ठीक है? So we need to tackle these two quantities one by one. This is individual thing, this is individual thing, right? So we need to know what should be the remainder when this quantity is divided by 3. So 22 की power 2022. Always think about this 22. What is that number which is close to 22 but divisible by 3? So 22 के very closer number is what? 21. 21 is divisible by 3 and it is divisible by 7 as well. But we are looking for 3. Focus on 3 this time. So it can be written down as 21 plus 1 की power 2022. Now I already told you, the moment you expand this by binomial theorem, learn it, understand it. The moment you expand 1 plus 21 की power 2022 by binomial theorem, tell me. The first term is NC0, that means 2022C0. This is 1. The second term will have X. X is what? So 21. There is something related to 21. Plus 21 something. Plus 21 something. Last term is 21 raised to power n. Can you see all the terms are having 21? That means I can simply write it as 1 plus 21k. That's what I was telling you. Right? So 1 plus 21 raised to power 2022 can be written down as 1 plus 21k, and that's what I wrote. Right? So 1 plus 21 raised to power 2022 can be written down 1 plus 21k. What does that mean? If this is divided by 3, so it will remain, it will make sure that remainder is 1 and this will be completely divisible. So remainder from here is 1 and this 2022 is automatically divided by 3, divisible by 3, right? 2022 as a number, add the digits, it is divisible by 3. So remainder is what? 0 automatically. So overall remainder is coming out as 1. Again from here, again same thing. A number which is divisible by 7 but close to 22 is 21. So 21 plus 1 की power this. Same thing, 21k plus 1. So this 1 will be remainder when divided by 7. What about this? So now 2022 is not divisible by 7. But 2023 is divisible by 7, right? So 2023 minus 1 की power 22. So again this can be written down as 2023 minus 1 power 2022. So this is again 1 only. So 1 to thai, this one, and this is 2023k is automatically divisible by 7. We are looking for 7 only. If a number is divisible by 6, it is automatically divisible by 2 or not. That's what I was saying. If this 2023k, 2023 is divisible by 7, so this is multiple of 7 only. I don't care about 2023. I am worried about my 7. Okay, so 7. So this is 7k plus 2. So 1 remainder from this part, 1 remainder from this part. Overall 2 is the remainder. Okay? Chalo, matrices and determinants, let's begin. So I already told you these three topics are very important topics, and matrices. So some of you were saying, ma'am, matrices, please teach me in detail. Matrices, please, basic from very basic. So now understand, realize what we are doing. Matrices, high weighted chapter, high weighted topic. Okay? So you know what, the basic difference between matrices and determinant. So matrices is a decoration. Matrices is an arrangement. Okay? But what about determinant? Determinant is a value. Matrices is just an arrangement, right? The arrangement, the decoration, right? You cannot calculate the whole value out of it. So if I talk about matrices, so there are multiple matrices. Suppose I take 3 cross 2 matrix. 3 cross 2 matrix, that means it will have row 1, row 2 and row 3. But it will have what? Column 1 and column 2. Row 3, then column 1 and column 2. 1, 2, 3, 5, 7, 9. So 3 rows you can clearly see, 2 columns you can clearly see. So we will call it a 3 cross 2 matrix, where 3 represent number of rows, 2 represent number of columns. Moreover, if I want to write it in a standard form, right, suppose I write 3 cross 3 matrix. So how will I write in a standard form? So A11, A12, A13, A22, A21, 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 A22, A23, A31, A32, A33. Close. ठीक है? So this is how a matrix is written. We can name it as A, B capitals में we can name it. ठीक है? अभी one thing. This is a standard format. So do you realize this is A21? A21 means what? 2 means what? Second row. 1 means what? Column 1. So this element is present in row 2 and column 1. So suppose out of the blue I tell you that A41 is the element of a matrix. What will you understand from this? Okay ma'am, this is present in 4th row but first column. So by looking at the digits, you will be able to tell me the position. So generalizing it, so 4th row, first column, 1, 2, 3, 4th. 4th row and first column. So this is the position basically, right? So 1, 2, 3, 4th row and column 1. So this is the position. ठीक है? So generalizing it, if I talk about Aij represent a element which is sitting in ith row, and jth column. Interesting? Yes. ठीक है? So this is the definition of matrix. Number 1 definition, representation of elements, representation of matrix and order of a matrix. In one go I have explained you. Order, representation, elements, everything. ठीक है? Let's talk about row matrix. What is row matrix? Row matrix which has only one row, it looks like this. I don't care about the number of columns. I don't know how many numbers of column it can have. I have no restriction on that. But one row. ठीक है? So one row, so 1, 2, 3. So this is 1 cross 3. Can you see that this should be 1? I don't care about this. ठीक है? Column matrix. So you know what? So 1, 2, 3, 4. Can you see that 4 number of rows are there, but single column is there? ठीक है? Row matrix, column matrix. Now 0 or null matrix. So 0 or null matrix, that means order of, okay, all the entries related to that matrix is 0. You are aware about this matrix, right? Horizontal and vertical matrix. So horizontal means what? That number of rows should be lesser than number of columns. So number of rows, let's say 3 rows are there. So 1, 2, 3, but 4 columns are there. 5, 6, 7, 8, 9, 10, 11, 12, 13. Can you see horizontal matrix? Then number of rows is what? Less than number of columns. And what about vertical matrix? It should look like this. 1, 2, 3, 4, 5, 6. Can you see this? 3 rows but 2 columns. So this case, number of rows should be greater than number of columns. And what will happen when number of rows and number of columns are equal? We will create a square matrix in which many problems are involved. Square matrix is the highlight of the matrices, right? In many cases, actually in most of the cases, pick up JEE Mains 2023 paper square matrix. The problems are always on 3 cross 3 or 2 cross 2 matrix. by the way, the favoritism is towards 3 cross 3 matrix. Okay, all right, yes. And now there are some terminologies which I wanted to tell you, important terminologies that in the question itself they will use those terminologies. Okay, so you know what, matrices chapter might be a little theoretical for you. You might feel ki ma'am theory ma'am, please question only. And you might feel like ki ma'am, don't teach so much theory, it's so boring, it's nothing is going in my mind. But don't feel like that. Matrices have some theory involved, some basic theory involved, and that theory is not that difficult, but it will actually help you in the problems. They will use trace of a matrix in the problem itself. They will not tell you what is the trace of matrix. You know what? Then you must know the terminologies. For terminologies, you have to spend some time in understanding the theory. That's what we are doing it. Okay? So in a square matrix, diagonal elements. What are the diagonal elements? So basically, can you see over here? This is the principal diagonal. I will call it as a principal diagonal. And in here, what happens is both the indexes are same. That means all the elements which are present in the same row and same column, that means first row first column, second row second column, third row third column, that will be what form a diagonal of matrix, and that will call diagonal matrix AII. So basically this would be the diagonal, this cannot be the diagonal. Okay, this could be the diagonal A11, A22, A33. Okay, so if I write A11, A12, A13, A22, A21, A22, A23, A31, A32, A33. This is your principal diagonal, and these three elements are diagonal elements. And what are the conjugate elements? Now understand this conjugate elements. So in question itself they can give you that, okay, ki conjugate element, acha, they are saying conjugate element of A32 is 8. What does that mean? Somebody tell me the meaning of this. Somebody tell me the meaning of this masterpiece. Conjugate element of A32 is 8. That means they are telling you that A23 is given as 8. That means the element which is present in second row and third column is given as 8. Now you know what is conjugate. Yes, so conjugate basically Aij and Aji. So conjugate of A12 is A21. Conjugate of A13 is A31. Conjugate of A23 is what? A32. So these are called conjugate elements. I hope you know the definition. And my favorite, trace. Yes. So trace, what is trace of any square matrix? So trace is nothing but sum of all the diagonal elements. Yes. So in this case, if I ask you what is the trace of this matrix, you will say, ma'am, okay, A11 plus A22 plus A33. This is the trace of a matrix. Okay? Clear? I hope this is clear. Let's now proceed and talk about what? Types of matrices. Types of matrices, we have square matrix. You already know where number of rows and number of columns are equal. Now, I would like to take this moment and let you know that take all the definitions very seriously. Okay? Listen very carefully what I am trying to say. Okay? You will understand that there are so many things which you were getting it wrong in the matrices. I'll show you. So basically square matrix. In square matrix we talk about triangular matrix. Okay? And there are two types of triangular matrix. Upper triangular and lower triangular. Okay? Upper triangular matrix says that the elements which are below the diagonal are 0. Elements which are below the diagonal should be 0. Okay? So let me just, now you know the definition. Square matrix, triangular matrix, upper triangular matrix. Upper triangular says that elements which are below the diagonal, below the principal diagonal basically, should be 0. Let me just ask you. Okay, so 0, 0, 0 and 0. Okay, let me just know whether it is an upper triangular matrix or not. Let me just look at in the comment section. Yes, Yojana, I am asking you a question whether this null matrix is an upper triangular matrix or not. Yes or no in the chat box. Just one question, I will be able to understand that whether you are getting my point or not. Okay. Yes, Yojana. And what about rest of the people? How to solve a skew symmetric matrix? Yes, we will do that after this. After this, we are doing that only. Okay. Yes, you are telling me null matrix. I know this is a null matrix, but is it an upper triangular matrix? Do you consider this as an upper triangular matrix? Yes or no? No, you didn't understand my question. Whether it is an upper triangular matrix or not. Okay, I can see Pramod is saying SS. What is SS? Okay. So there are few people who are saying yes ma'am upper, but few people who are saying ma'am no. No, yes, mixed answer. Now is the time. I am going to reveal this. Okay. What did I tell you about the definition? Calm down, cool down. Let me just repeat myself because I knew that you would be getting this very wrong. So if you have a diagonal element, so what I am saying is in upper triangular matrix, elements which are below the principal diagonal should be equal to 0. I didn't mention what should be the value of diagonal elements, what should be the value of anything else. So this is my principal diagonal. Yes ma'am. All the elements which you can see below this should be 0. So only this should be 0. Basically this should be 0. This is my checkpoint. Rest I don't care. I don't care. I am only concerned about this. In the definition also, if you see that they are saying if I is greater than or equal to j, that means only these three elements, they are talking about these three elements are 0. They don't care about the diagonal elements. They don't care about this. If this is 0, this is upper triangular. Are you getting my point now? So yes, this is an upper triangular matrix, right? And what about lower triangular? So lower triangular says that elements which are above this principal diagonal should be 0. They don't care about this principal diagonal and rest of the terms. So this represents a lower triangular matrix as well. So Pramod was only one, he was saying yes, upper and lower. So this is upper and lower. Okay, now let's talk about the diagonal matrix. So diagonal matrix looks like this. Looks like this, but the correct definition is what? Basically, the non-diagonal elements should be 0. In a diagonal matrix, non-diagonal elements should be 0. So I just want to ask you one thing. 1, 0, 0, 0, 0, 0, 0, 0, 0. What about this? Is this a diagonal matrix? Is this a diagonal matrix? Yes. This is a diagonal matrix. Why? Because the definition says non-diagonal elements should be 0. So you will only check the non-diagonal. Leave the diagonal one. Rest everything is 0. Yes ma'am. You don't care. Even if it is this na. This is also a diagonal matrix. Because we will only check. We will leave the diagonal. All the elements except the diagonal. Check 0. I don't care about the diagonal. Yes, Kirti, you also said yes. So so that means null matrix is also a diagonal matrix. Now you know that what I was saying, that pay attention to the exact definition. Okay? Alright. Equality of the matrix. So two matrices are equal when they have same order and their elements are also equal. So basically the photocopy, if you see the photocopy order wise, then you will say yes ma'am. Basically both the matrices are equal. Okay? Now multiplication of a matrix by a constant. So here is a difference. The moment you see any determinant now, suppose this is a determinant 3, 2, 6, 5, 7, 9, 10, 11, 12. Okay? And if you want to multiply with a constant, let's say a. So in determinant, what will you do? Small a you will be multiplying in any row or any column, right? So you just pick any row or pick any column, just in one row and in one column you will be multiplying, that's it. But this is not the case with the matrices. In matrices, what will happen is you have to pick each and every element and you have to multiply it with each and every element. Can you see this? Every element will be attached to k. So there's a difference between determinant multiplication and matrix multiplication. I hope you remember this, okay? And you know what? You must be remembering this thing that if two matrices are to be multiplied, then there must be a condition. You can't multiply any two matrices out of the blue. There should be a condition. I will show you the condition. Suppose if you have this a 3 cross 2 matrix, okay? 2, 3, 4, 3 rows are there, okay, and 2 columns. Sorry, 2 cross 3. 2 cross 3 matrix, suppose you have, and 5, 6, 0. Okay, this is your matrix B. Now, and a 3 cross 3. 1, 2, 0, 0, 1, 1, 3, 9, 1. Right? So I have a 2 cross 3 and a 3 cross 3 matrix, and I am asking you a question that whether this multiplication is possible or not. So you just have to talk about one thing. Number of columns of the first matrix should be equal to number of rows of the second matrix. Number of column of the first matrix should be equal to number of rows of the second matrix. Yes, this is matching. So number of columns of the first matrix should be equal to number of rows of the second matrix. Then the matrix multiplication is possible, and the answer AB ka order, the order of AB would be what? 2 cross 3. So the order would be 2 cross 3, right? So order would be what? Number of rows of the first matrix into number of rows of the second matrix. Okay? So order would be what? 2 cross 3 would be the order. So 2 cross 3 matrix will get formed. And you know how to do it? So basically row of this A matrix will get multiplied with column 1 of the first matrix. Row number 1, column number 2. Row number 1, column number 3. That's how you do it. That's how you go about it. Yes, first matrix column and second matrix row should be equal. Pramod is saying, to matlab he said, to matlab it is fine. It is correct. Okay? Alright. Hai na? But one more thing which I told you was, the final order should be what? Number of rows of first and into number of column of second. The remaining part would be the thing. Okay? So this I already told you, two matrices can be multiplied only if number of column of first should be equal to number of row of second. Okay? And how we multiply? So row by column, row 1 by column, row 1 by column. Then row 2 by column, row 2 by column, row 2 by column, row 3 by column, row 3 by column, row 3 by column. There are some properties associated to matrix multiplication. In general, AB is not equal to BA. And you know what? In the previous problem, AB was possible but BA was not at all possible. So it can also happen that AB is existing. You are able to find AB. But BA you cannot find it. BA does not even exist in this planet. Right? So sometimes this also happen, and in general AB is not equal to BA, and it is associative. So suppose if you have to multiply ABC, so you can multiply AB first and then multiply it with C, or what you can do is you can multiply BC first and then pre-multiply it with A. So that means it is associative. You can do this and you can do this as well, right? So this is associative. This is the associative property. It follows distributive property. That means A multiply B plus A multiply C will be here, or yeah, same thing, B A or C A. Okay? And multiplicative identity, very important. The moment you multiply A by I, identity matrix of same order, it will give you A, or same I A will also give you A. Okay? But if you multiply any matrix with null matrix, it will give you a 0. Okay? So this is the properties, basic things about matrices. This this basic things you must know. Some of us already know it. Okay, and yeah, let's hit the property of matrices. Properties of transpose are very important. Okay, property of transpose is important. So what is a transpose? Suppose we have a matrix 2, 3, 5, 7, 8, 9, and somebody is asking me to calculate the transpose. So transpose means what? That whatever was the row will become the column now. So if this is what? 3 cross 2 matrix. So for transpose I will get 2 cross 3. So 2, 3 is horizontal. So 2, 3 I will be writing it as vertical. 5, 7 here. So 5, 7 here. Can you see row column interchange? Then 8, 9. Or you can simply do this as well. 2, 5, 8. So 2, 5, 8. 3, 7, 9. 3, 7, 9. This is the transpose. And the moment you take transpose of this again, what you will get is the same A matrix. So that's the first property. A transpose ka transpose will be equal to A. A plus B whole transpose will be equal to A transpose plus B transpose. We are going to use this property in upcoming JEE Mains 2023 question. And this is what we call as this is what I call as a kidnapper's property. So in transpose case, suppose you have actually trapped a person named K, right? And KA is kept inside a tunnel, maybe because he is kidnapped. So he has to give some money, right? Because he wants to get free. He has to give some money, but then the kidnapper realized that they have kidnapped the wrong person. So that's why they actually left it anyway. So basically free mein they had to leave this K. So K is absolutely free. It has got no power. It has got nothing to do with this transpose. Okay, so in transpose basically the guy K which was kidnapped is free absolutely. And the fourth property which is holding a reverse law. So AB whole transpose. So the things will get reversed. B transpose, A transpose, and you know what? If you have multiple values ABC transpose, this will become C transpose, B transpose, A transpose. Okay? So this is how reversal law will get hold. I already told you about the reversal law. And also this A raised to power n ka transpose hai. So you first take transpose and then take power n. मैम आपने थोड़ी गलती कर दी. कौन सी गलती बता दो. Students were asking me about the symmetric and skew symmetric matrix. Now listen to me carefully. Why? Because skew and symmetric and skew symmetric, these two things are coming, like I won't say ki बहुत high with a high frequency, but each and every year single question I am able to see. So in 2024 one question will be there, one or two questions also may be there. So in any shift symmetric matrix se I am assuming one question will be there. ठीक है. What is meant by A dash? A dash is same as A transpose. Yes, Kirti has given the answers. Yes. So yes, after this we will solve PYQ. Please understand the symmetric matrix. Have some patience. We will solve PYQs. Right. So symmetric matrix. Symmetric matrix are those matrix wherein that A matrix will be equal to A transpose. So basically those kind of matrix who are equal to their transpose. So suppose we have this. This is, let's say, A matrix. Can I just figure out simply A transpose or A dash? A dash is also A transpose. Can I just figure out? Okay, so 3 cross 3 is there. 3 cross 3 will be here. 2, 1, 3. 2, 1, 3. 1, 0 minus 2. 1, 0 minus 2. 3 minus 2, 5. 3 minus 2, 5. As simple as that. Now notice, observe carefully that all right, ma'am. 213, 213 matching. Matching. That means A and A transpose are equal. That means this form what? This forms symmetric matrix. So, right? So the moment you feel this word, the moment you understand this word symmetric matrix, so the moment you have to assume any 3 cross 3 symmetric matrix, what does that mean? That simply means that we don't care about the diagonal elements. Diagonal elements could be anything random, but the conjugate elements would be equal. So ABC, if you are writing D over here, you should be writing D over here. These two elements should be same. Then only it will become a symmetric matrix. If you are writing E over here, you should be writing E over here. And if you are writing F over here, you should be writing the same F over here. This is a classic example of considering a symmetric matrix. So the moment you need some, so suppose it is given in the question ki matrix A is a symmetric matrix and you have to assume it. You have to assume it like this. You can't be just A, B, C, D, E, F, G, H, I, J, K. No need to introduce so many multiple variables. So diagonal could be anything, but these two conjugate elements should be equal. That's what I'm trying to say. I hope you got this symmetric matrix ka meaning. Now skew symmetric matrix, and then we have got a question from JEE Mains 2023. So skew symmetric matrix की condition would be A transpose should be equal to minus A. A transpose should be equal to minus A, right? A transpose should be equal to minus A. So clearly, if I see this as A matrix, tell me about A transpose. Who is going to calculate A transpose with me? So 0 to 4, observe, watch. 0 to 4, 0 to 4. Minus 2, 0. Minus 3 and minus 4, 3, 0. And now compare it. How should I compare? So you can see this is 0, this is 0. Okay, no issue. This is minus 2, but this is plus 2. Okay, that means only sign reversal is what I can see. Minus 4 ka plus 4, again the sign reversal. 2 ka minus 2. Okay, each and every element 0, 0. Minus 3, 3. I can clearly see that the whole things are negative, right? So how to assume any symmetric matrix in symmetric matrix? Skew symmetric matrix. So skew symmetric matrix may all the diagonal elements must be equal to 0. Number one thing, right? In symmetric, there is no such condition on diagonal, but in skew symmetric, diagonal should be 0. If this is A, you should assume this as minus A. That means conjugate elements are equal but in opposite sign. If this is B, this should be minus B. This is C, this should be minus C. That's how you assume a skew symmetric matrix. I hope this is clear. Okay. Chalo. As I promised that we will solve a question related to symmetric and skew symmetric from 2023 JEE Mains. Yes, break needed, I know. Avinash, break needed, but I guess there is nothing much left in matrices. Theory is done. 2-3 problems and we are done about it. And then we will start fresh calculus. We will take a break for sure. Okay? Okay. Chalo. So, question is telling me कि A, B, C be 3 cross 3 matrices such that A is symmetric and B and C are skew symmetric. Okay. A is symmetric, what does that mean? Ki A is equals to A transpose, B is equals to minus B transpose, right? Or ऐसे भी लिख सकते हैं B transpose is equals to minus B and C transpose is equals to minus C. That's what it is given to me, right? This is the given condition. Perfect. And S1 statement is telling me that this is matrix is symmetric. This matrix is symmetric. So let us assume this as, okay, another matrix. Let us assume this as P matrix. So P matrix is given to us A की power 13, 2 की power, B की power. b की पावर 26 माइनस b की पावर 26 a की पावर 30. ठीक है. So basically this type of question was there in this type. Similar type was also there in 2021 JEE Main. And we go by same method. What do we do? So we need to prove or we need to check whether this matrix is symmetric or not. So first thing is you should assume this as a matrix. Suppose let P be the matrix which is equal to this matrix. ठीक है. Now if this is a symmetric matrix, what does this mean? कि P should be equal to P transpose. If we are able to prove this, then we are done, good to go. Statement 1 will be true. If we are not able to prove that, then cancel. Statement 1 is wrong. That's how we go. That's how we are going to go about it. Yes. So let's take P transpose. So P transpose, that means overall transpose A13, B26 minus B26, A13. Now you know the properties, right? Property of transpose. Shall I tell you? A minus B ka transpose will be equal to A transpose minus B transpose. This is the property which we are going to use. Use it. So transpose will come over here. So P transpose is coming out as A13 B26 transpose minus B26 A13 transpose. ठीक है? Now that reversal law, do you remember this? Let me just show you. AB का whole transpose is equals to reverse B transpose A transpose. Apply it over here. So this will become what? Reverse हो जाएगा. So this will become B की power 26 का transpose and A की power 13 का transpose minus, this will get reverse. A will come first, A13 का transpose, B26 का transpose. ठीक है. Now 26 and transpose again. One more property. Property says that if you have A की power n का transpose, you can write A transpose की power n. That means you can interchange power n transpose position. So this will become B transpose की power 26. B transpose की power 26 will be minus B की power 26. So B की power 26, A की power, now A transpose is A only, right? Minus B की power 26, 26 is an even number, that's why minus sign is rejected. And A की power 13 minus here A की power 13, B की power 26. That's it. So this is your P transpose. Now look at it. This is your P transpose. This is your P and this is your P transpose. P and P transpose. So I can clearly see that the moment I take minus sign, the moment I take minus sign common, what do I get? I get A13 B26 minus I get B26 A13. ठीक है. So this is what? This is your P A13. Can you see this is your P? So P transpose is coming out as minus P, right? But it is not coming as P only. It is coming out as minus P. That means statement 1 is false, right? This P matrix is a skew symmetric matrix. So statement 1 तो absolutely false है. Statement 1 absolutely false है. B and D both are rejected. Now the competition is between A and C, right? So this statement number 2 we need to check. Let us assume as a Q matrix. So again Q transpose would be equal to what? A26 C13 का whole transpose minus C13 A26 का whole transpose. ठीक है. Now apply the reversal law. C13 का transpose A26 का transpose minus A26 का transpose and C13 का transpose, right? Now C transpose is minus C, right? C transpose is minus C. Minus C की power 13 will become what? Minus C की power 13. This A will be A की power 26 and this would be plus A की power 26, but C will give minus sign, that's why plus. So C की power 13. So this will become A26 C13 minus C13 A26. Can you see that this is exactly same as Q? So Q transpose and Q are equal. That means statement number 2 is absolutely true. So statement 2 is true. Yes. Yes. Are we going great? Are we absolutely going great? How are we feeling about this question, about the whole concept about skew, symmetric and symmetric? Ask yourself. Is it scaring you? Is it giving you confidence? Tell me. Okay. Similar question from 2021 JEE Mains. Similar question was asked. ठीक है? Alright. चलो. Let's now talk about the adjoint of matrix. After matrices, I'll give you a break. Even I will need a break after matrices. ठीक है? So do not worry about this. Break will be given. ठीक है? So adjoint of a matrix. What is adjoint of a matrix? Who can tell me? Who can recall it? So first of all, let me just tell you that. Okay. Okay, let me just tell you that we have a 2 cross 2 matrix. Suppose A, B, C, D. Right? This is a matrix A. Can you write a matrix which is a cofactor matrix? Can we write a cofactor matrix? Can we do that? So you must be, know about minor. So what is the minor of A? So minor of A is your D. Right? D is your minor. Right? What would be the minor of B? So minor of B would be your C, right? And what would be the minor of C? Minor of C would be B, and last it would be A. But if we are looking for cofactor, na? So cofactor, so this is positive, this is negative, this is again positive. Okay, 1 1 1 2. Sorry, this is negative, 2 1 negative, and this is positive. That's how we go about it. 1 1. The position is 1 1. That means even number. 1 2, odd number negative. Again odd number negative, positive. So this is cofactor matrix. This is your cofactor matrix. What about cofactor ka transpose? So cofactor, the moment you take transpose of this, you will get D, and then you will get minus C, then you will get minus B, and then you will get A. This transpose of cofactor matrix, transpose of its cofactor matrix is nothing but adjoint, right? So this is nothing but adjoint of a matrix, adjoint A, right? So there is actually a shortcut to find adjoint of a matrix in 2 cross 2. So what you need to do is, listen to me carefully, that if you are given, so suppose A matrix is given to you 3 2 6 9, right? And you need to figure out what adjoint of any matrix A, and that would be, so just interchange these three values 9 and 3 and apply negative sign. Okay, change the sign of these two remaining values. So just interchange the diagonal wale elements, and the non-diagonal elements will have to go through a sign change. So can you just see now, A and D, the positions are being interchanged. It is D and A, and B and C are at the same position, but they have changed their sign, so minus B minus C. So this is adjoint A. That's how you calculate adjoint of any 2 cross 2 matrix by shortcut, right? Just interchange these two and change the sign of remaining two elements. Okay? This is what is adjoint of any matrix. Now you know what? There is one interesting thing about adjoint of any matrix. If you have got A matrix and if you have got adjoint of matrix, the moment you multiply A and adjoint of A, what will you get is the determinant A into identity matrix. Yes. So the moment you multiply it, A into adjoint A, what will you get? So determinant A, what is it? 9 3s are 27, minus 6 2s are 12. So 27 minus 12, 15, and you will get an identity matrix of 2 cross 2. This is your multiplication. This is what your multiplication. So this will become 15, 0, 0, 15. Multiply it. You will get the answer. So 3 into 2, 9 into minus 6. 9 3s are 27, and minus 12. Can you see 15 is coming? Then 0 will be here. So this is the property. Multiply A matrix with its adjoint. It will give you determinant A into identity matrix. Or what you can do is you can multiply adjoint A with A. Then also you will get the same thing. Is this property clear? Is this term clear? This is very important, by the way. Very important. For any square matrix, if you multiply A with its adjoint, what will you get? Determinant A into identity matrix, right? So this is the basic thing of all the properties which we are going to cover for the adjoint of any matrix, right? So the very first property, determinant of adjoint of A. Determinant of adjoint of A is what? Determinant A ki power n minus 1. From where does this property come? So the moment you see A, adjoint A, this thing everybody should know. This is the basic of everything, right? So what I'll be doing is I'll be actually taking what? I'll be taking a determinant both the sides. The moment I take determinant, it will become determinant A. Determinant adjoint of A is equals to whole determinant A in. And this determinant A is a constant which, if I have to take out of this determinant, it will be having power raised of n. And this is 1. Determinant I is 1. So adjoint A determinant is nothing but this, right? So this is the property. I have given you the proof as well. Adjoint A ka determinant is what? Determinant A ki power n minus 1. ठीक है? Right? And the property which would be next to it is adjoint of A. If you are writing it twice, adjoint of A, it will become what? Determinant A ki power n minus 1 square. If you are writing it thrice, adjoint of, very important, very important. And we will apply this. Adjoint of adjoint, 3 times adjoint. You are seeing 3 adjoint. So this will become determinant A n minus 1 ki power 3. So now you know that if 4 times adjoint is there, so it will become n minus 1 ki power 4. So you know these two properties already. So these two properties are important, right? Single adjoint determinant, double adjoint determinant and triple adjoint determinant, right? Okay. And the fourth property related to transpose. Adjoint of A transpose is equal to adjoint of A ka whole transpose. And the kidnappers property, right? So in transpose, let me just recall. So K A transpose. This time we've got the wrong person. We have kidnapped the wrong person. So we have to leave this K as it is. But adjoint of K A. This time we've got the right person in adjoint, right? So this K will come out, but it will be order minus 1 adjoint A. This n is nothing but what? N denotes order of the square matrix, right? And this again, adjoint of A ki power m is equals to adjoint of A power m. Okay? And then reverse law. That, like I told you, AB ka whole transpose will be equal to B transpose A transpose. So adjoint AB will be equal to adjoint B adjoint A. Yes, I can see some of students are saying that just joined. How many chapters are done till now? So in algebra we have started with quadratic, then complex numbers, then sequence and series, binomial theorem, and permutation and combination, and now we are doing matrices and determinants, and after that we will start the calculus, magic of calculus. Yes, okay. So this is the reversal law. So basically most of the time reversal law holds. I will show you most of the time reversal law holds, but before that let me just give you this question. And you know what, this time I want to give you 1 minute to solve this question. 1 minute, okay? Because I want you to understand that we have just studied some property, and the same property you can apply in JEE Mains 2023. So yes, how many times? 1, 2, 3. 3 adjoint means determinant of 2a as it is, right, raised to power n minus 1 ka cube is given as 16 ki power n. N is what? N is the order of a, so n is nothing but 3. So 2a का determinant की power 2 का cube. So 2a का determinant की power 8 is equals to 16 की power n is what we are getting. ठीक है? All right. अब now the whole question is how to calculate determinant of 2a. Please do not make any mistake and do not write like this, okay, 2 times determinant of a. How many of you are doing it? This is the common mistake. How many of you are doing it? That's not the way. So the property says whenever you see any constant inside the determinant, again the kidnapper's property. So you have to take the k out, you have to apply power n on the k and then determinant a. So that means 2 times a ka determinant will be what? 2 ka cube, y cube, y3 because order is 3, determinant a. So this is 8 times determinant a, and the moment you find determinant a ka value, it would be what? 2, 4 minus 1, so 6 minus 1, 2. So this is 4. So 8 4s are 32. 32. So basically 2a, the value of 2a is coming out as 32. So 32 ki power 8 is coming out as 16 ki power n, or rather 32 is what? 2 ki power 5. So 2 ki power 40 is equals to, this is what? 2 ki power 4n. So can you see 4n and 40 should match? That means n should be equal to 10, and option C absolutely right. All right. Yes. Nice question. Nice property. Actually not a single property, but we have actually tapped two very important property. We have refrained ourselves from doing this mistake because I mean, if someone tell me na ki what will you tell someone, any student a day before or a week before your examination, so these kind of mistakes only. I just wanted to tell you, I just wanted to warn you about some common mistakes which many students are going to do in their JEE Main 2024. So I have 10 years of experience, and I have so many experiences that okay, this is the point where student can go wrong. So I just wanted to like open that Pandora box of common mistakes in before your JEE Main. Okay. All right, let's talk about the inverse of a matrix now. So inverse of a matrix exists only if your matrix is non-singular matrix. So A inverse only exists when your determinant A is not equal to 0, right? If your determinant A is 0, then sorry, your inverse will not exist. You don't need to find any inverse of a matrix, right? Yes, this is the condition. So the moment you see any matrix A and you are to calculate inverse of that matrix, all you have to do is check for the determinant A. If it is non-zero, then proceed, otherwise do not proceed. Okay? And I will tell you the shortcut to find inverse of a 2 cross 2 matrix as well. Okay? So the formula is A inverse adjoint A upon determinant A. You know how to calculate adjoint A. I will show you the shortcut for 2 cross 2 matrix to calculate the inverse of a matrix, right? Suppose A is given as 3, 4, 3 minus 2. This is your A, and you are here to calculate A inverse. So A inverse is what? Adjoint of A upon determinant A. So what would be the adjoint of A? So I already told you, interchange the diagonal elements. So that would be what? Minus 2 and 3. And you know what? Change the sign of the rest of the elements. So this will become minus 4 with same position, minus 4, minus 3. And now you have to divide the whole matrix by what? By determinant of this inverse matrix. So 3 2s are minus 6 and minus 12. So minus 6 and minus 12 will become minus 18. So this is your shortcut for A inverse of a 2 cross 2 matrix. Okay. This is how you calculate inverse. So adjoint upon determinant A. Okay. Alright, clearly A inverse. Now you know that adjoint A how to calculate upon determinant A. Okay, this is all about inverse. So the property of inverse are same as properties of transpose. A transpose, car transpose was also giving me A. This is the different property. A inverse ka determinant. This is mind-boggling property. A inverse ka determinant is 1 by determinant of A. A transpose ki ka inverse. A transpose ka inverse. So this transpose and inverse are automatically interchangeable. First you calculate inverse, then transpose. Or if you wish to calculate transpose, then inverse. Nobody is going to question you. Nobody is going to scold you. Okay? Your wish, your will, free to do anything. Again, reversal law. AB inverse will be B inverse, A inverse. Again, ABC inverse will be what? C inverse, B inverse, A inverse. I already told you, most of the time, inverse law will get hold. Okay? And now, the last and the final thing, which is quite popular, है ना? So system of linear equation using matrix method, है ना? That is one thing, but I would like to teach you system of linear equation using Cramer's law as well. Now you will tell me, ma'am, Cramer's law has been removed from matrices and determinants chapter. But who is going to come and check whether you have solved the problem from matrix method or Cramer's law? And Cramer's law is much easier than matrix method for many of the students. So let me just teach you Cramer's law. Please do not say that, ma'am, please don't teach it. Why? Because this has been deleted. Nobody is going to question you, right? So we'll study both. Do not worry. It will hardly take 2 minutes more. Okay? Suppose you are given with 3 equations and 3 unknowns. System of equations where D1, D2, D3 is here. So we call it as a non-homogeneous. So this is nothing but non-homogeneous equations. System of equations, right? So I have actually formed 3 matrix. The matrix A is formed by coefficient of these unknowns A1, B1, C1, A2, B2, C2, A3, B3, C3. This is your A matrix, right? And there is an unknown matrix called X matrix, X, Y, Z. The moment you multiply A and X, what do you get is the left hand side of the all 3 equations. Multiply A1, B1, C1, multiply X, Y, Z. A1X, B1Y, C1Z. Right? You will get what? First equation. Then row number 2 multiplied by this. Row number 3 multiplied by this. And what about B? B is the matrix formed by the last, the constant of the equation. So A, B, A, X, B, and what do you write? You write AX is equals to B. Or you can write X is equals to A inverse B. Or you can write X is equals to adjoint A into B by determinant A. Right? So this is what it is. Right? And this is capital X. You are looking for what? What you want to know? What is the agenda? You want to know X, Y, Z value. How to solve system of equations. You want to know X, Y, Z values. Capital X is what? X, Y, Z. So you are looking for this matrix X in this. Okay? So you don't have to actually solve it because we have already solved it. You have to just apply the algorithm over here. So basically, this determinant of A will tell you a lot of things about the solution of these 3 equations, right? So the moment you see the system of equation, the first thing which you are going to do is calculate determinant of A. What is determinant A? This matrix, the determinant of it. So determinant A will have 2 choices. If it is non-zero, that means it is having a unique solution. How are you going to calculate that unique solution? Unique solution can be calculated by this. So you have to figure out adjoint of 3 cross 3 matrix, right? So cofactor ka transpose, that will give you adjoint of A. You have to multiply it with B matrix, which is this very small matrix. The multiplication is very easy, not that difficult. And you need to divide by A determinant. So what you will get is this capital X will be what? Suppose you had 1, 2, 3. So what does that mean? And capital X you have assumed is x, y, z. That means you've got the value of x, y, z as 1, 2, 3. If it is non-zero and if it is having a unique solution. Okay. But if it is coming as 0, then there are two possibilities. Number 1, it has no solution. Number 2, it has infinite many solution. In that case also, you have to calculate adjoint of A into B. So basically adjoint of A into B, so you have to calculate. Adjoint A you need to calculate, you have to multiply it with B, and then only you will be able to know whether, so if it is 0, so basically both are 0. If everything is 0, then infinitely many solution. If this is 0 and this is non-zero, then no solution. Yes? Yes? Are you getting my point? Okay. Let me just teach you a Cramer's law as well. So in here I want to tell you Cramer's law. Small thing, Cramer's law. For non-homogeneous. Okay? For those people who are not able to leave the Cramer's law just like me, please let me just give you the insight. So again, 3 equations are here, right? You have to form delta. Delta is what? Determinant of A, right? So if delta is non-zero, that means you will have unique solution. Okay, how are you going to calculate this unique solution? X will be equal to delta X by delta. Y is equals to delta Y by delta. Z is equals to delta Z by delta. What is delta? Delta is nothing but this determinant only, right? Delta is what? This. A1, B1, C1, A2, B2, C2, A3, B3, C3. What is delta X, ma'am? So this value you can calculate. What is delta X? So delta X, let me just show you the value of delta X. So delta X will be equal to what? So delta X may, you have to actually delete A1, A2, A3 and replace it with D1, D2, D3. So the very first column would be D1, D2, D3 and rest B1, B2, B3, C1, C2, C3. So now you know delta X, delta. So you will be able to calculate the value of X. Similarly, for delta Y, you have to delete B1, B2, B3 and place D1, D2, D3 in place of this. Right? So this is for unique solution. If your delta is equal to 0, then you need to check for delta X, delta Y, delta Z. If all are 0, that means infinite solution. If one of them is non-zero, at least one of them is non-zero, then it will be no solution. Okay? This is your Cramer's law. So Cramer's law क्या बोलता है? What does Cramer's law say? If your delta is 0, then unique solution you will calculate by these values. If delta is 0, then infinite many solution or no solution. If all are 0, then infinite. If one is pending, then it is what? Yes. So basically what I need to do over here, matrices only we are studying, Vivesh, this is matrices and determinant. We are almost towards the end of matrices and determinant. I don't know whether you have joined it right now. क्या? ठीक है, चलो, it is a system of equations. ठीक है, so these are the system of equations. ठीक है, has infinitely many solutions. So I have told you the condition. Delta is equals to delta X is equals to delta Y is equals to delta Z. All should be equal to 0. So let me just calculate delta and make it 0. So 2, 1, minus 1, 2 minus 5 lambda, 1, 2 minus 5 is equals to 0. Right? Okay. This is 0. And what about your okay, so if this is 0, you can calculate it, you can make it 0, right? Let me just show you the solution. Delta is 0, so just expand this, get the value of lambda. Lambda is coming out as 17. The moment for infinite solution, everything should be 0. So this determinant you have done. It will give you the value of lambda is equals to 17. Okay, I am pretty sure that you will be able to solve the calculation. Okay, and you need to get the value of mu as well. To get the value of mu, no, actually you have to make either delta 1, 2 or 3, 0. Let's make delta 3, 0. How to form delta 3? Who is going to tell me? So delta 3 is what? 2, 2, 1. Same. 2, 2, 1. 1 minus 5, 2. And you know what? Except this, the last thing, you just need to write 5, mu and 7. Just replace the column number 3 by the constant value 5, mu and 7. This is your delta 3, which should be equal to 0. So I have kept it over here. Delta 3 is what? 0. Okay, same thing. This and this are same thing basically. These two are same determinants. Do not worry about this. Okay, so delta 3 is 0. 1 minus 5, 2. So delta 3 you can see clearly is 0. The moment you keep delta 3 0, you will realize mu is coming out as minus 13. Right? So any two delta you can make it 0. Delta 3. So 17 and minus 13. So 17 and minus 13 ka square plus 17 plus 13 ka square. And that's all. This is 4 ka square 16. This is 30 ka square 900. 916. Option A is absolutely right. Yes. Vibesh is saying, ma'am, please teach matrices fully for 11th moving to 12th moving. Okay, Vibesh, I have noted this thing and thank you for recommending. Actually, I was thinking about it only that we should do something for 11th to 12th moving. So yes, this is noted. I will work on it. I will let you know. Yes. Okay. Alright. So this is done and dusted. Matrices is done and dusted. And we will actually fatafat say we will revise all the formulas from trigonometry. Once we are done with that, then we will step into our den, which is calculus. So just one vote. Shall I give you a break now or after trigonometric revision? It will hardly take 10 to 15 minutes. The whole trigonometry formula revision or after the break. Yes, we will revise everything by today. I don't know what. So basically we are studying from 5 to 9. We have it took us 1, 2, 3, 4 hours for algebra, so 4 more hours for calculus maybe, and 3 hours for calculus and 2 hours for coordinate geometry. After trigonometry, no break, 5-minute break. Okay, after trigonometry, I guess after trigonometry many students are saying maybe, so you will have a nice dinner and then come back. So we'll take a good 10-minute break, है ना? Tell your mom or whatever your cook who is making food for you that you will be having dinner after 10 minutes, 10 to 15 minutes. Okay, chalo, trigonometry, let's start. So let's just understand the trigonometry. There are few observations which I would like to make. So cos 2n pi, that means cos even multiple of pi is always 1. Cos even multiple of pi, that means cos 100 pi, cos 200 pi, cos 500 pi, cos 20 pi, all the even numbers, cos 22 pi, all the even numbers are 1. Cos odd pi, that means cos pi, cos 3 pi, cos 101 pi, cos 203 pi, minus 1. Sin n pi is 0, right? Sin 3 pi, sin 4 pi, sin 5 pi, sin 100 pi, sub 0. Cos of minus theta now and sin of minus theta. So cos of minus theta is cos theta only. So basically what happens is minus sign inside the cos doesn't make any difference. Cos 1 degree, cos minus 1 degree, same to same. Copy paste. Cos minus 30 degree, cos 30 degree, same to same. But it is not the case with sin theta, because sin minus theta is minus sin theta. So what do we say? That cos absorbs the minus sign, Sine, throw away the minus sign outside, right? So this is the basic related to what? Sine and cosine. So yes, sine of supplementary angles are same. What does that mean? Now this is very important. So basically the moment I see sine 79 degree upon sine 101 degree, what does that mean? Sine 79 degree, sine 101 degree. So you can clearly see 79 and 101 degree. These are supplementary angles. Pair of supplementary angles are always equal. That means sine theta is equals to sine pi minus theta. Sine of supplementary angles are equal. Theta and pi minus theta, right? Cosine of supplementary angles are not equal, but actually value are equal but negative of each other. That means cos 79 degree is equals to minus cos 101 degree. That's how it is. Yes. Okay. And you know what? Sine minus theta is minus theta. I already told you. Okay. There are some formulas which I want you to revise. Sine A plus B. Sine A cos B plus cos A sin B. Sine A plus B is sine A cos B plus cos A sin B. Sine A minus B, repeat after me, repeat after me. There should be noise in your area. That what are you doing? Repeat after me. Sine A minus B, sine A cos B minus cos A sin B. Sine A minus B is sine A cos B minus cos A sin B. Cos A plus B, cos A cos B minus sin A sin B. Cos A plus B is cos A cos B minus sin A sin B. Okay? Cos A minus B, cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B. Okay? So all these four formulas, have a look, understand this, fresh mind, so that you remember this. Now the moment you multiply, you divide 1 and 3, you will get this. Tan A plus B is tan A plus tan B whole upon 1 minus tan A tan B. Tan A plus B is tan A plus tan B upon 1 minus tan A tan B. Tan A minus B is what? Tan A minus tan B whole upon 1 plus tan A tan B. So when there is a plus sign, there is a plus sign. Niche there is minus. Minus ka minus, denominator mein there is a plus sign. Okay? Then cot A plus B, cot A minus B. Cot A plus B, cot A minus B. Understand this. Understand this. So cot A plus B is nothing but cot A cot B minus 1 whole upon cot B plus cot A. Very special mention. So cot A plus B. Now the sign are reversed. Cot A cot B minus 1 upon cot B plus cot A. Yes, cot B plus cot A. And cot A minus B is what? Cot A cot B plus 1 upon cot B minus cot A. Now you know why I am telling you cot B plus cot A. Because in here you have to remember cot B minus cot A. Yes. 7 and 8. So all those 8 formula, paste, basically take a screenshot and paste in your brain. Can you do this? Some more formula. The moment you put A is equals to pi by 4, what will happen? Tan pi by 4 plus B is theta. Tan pi by 4 plus theta. So is tan pi by 4, that is 1. Tan pi by 4 plus theta is 1 plus tan theta upon 1 minus tan theta. Tan pi by 4 minus theta is 1 minus tan theta upon 1 plus tan theta. Right? So these two special cases are very important to remember. We will use it. We will use all the trigonometric formulas, do not worry. Then we have multiple angles and submultiple angles. Right? Multiple and submultiple. Sin 2 theta is 2 sin theta cos theta. Cos 2 theta is cos square theta minus sin square theta. Right? Okay? Alright. And you know what? 2 more formulas related to this. Array, 2 more formulas related to this. Yes. So basically, let me just write it. Sin 2 theta is equals to 2 sin theta cos theta is equals to 2 tan theta whole upon 1 plus tan square theta. This you should remember. Okay. 2 sin theta cos theta would be what? 2 tan theta upon 1 plus tan square theta. Very important. Cos 2 theta, tell me. So this is cos square theta minus sin square theta. Okay. And you know what? You can write this as 1 minus sin square. So it will become 1 minus 2 sin square theta. Or in here you can write it as 1 minus cos square. So it will become what? 2 cos square theta minus 1. Okay? Alright, so cos 2 theta is what? Cos square theta minus sin square theta. And yes. Now in tan we have a formula 1 minus tan square theta upon 1 plus tan square theta. Again, very important formula. This is the formula. These are the two formulas. Sin 2 theta in terms of tan, that is valuable in your indefinite integration as well. And cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta. Right? Now one more thing, the third formula. So these are the two formulas. The third formula, tan 2 theta is 2 tan theta upon 1 minus tan square theta. Now one thing which I want to show you, that sin 2 theta is what? 2 tan theta upon 1 plus. But tan 2 theta is same but with a negative sign. Do remember this. Because sin and cos both are having positive sign in the denominator. Do keep this in mind. But tan is having minus sign in the denominator. Right? Okay. So in here, from here also you can actually make 1 plus cos 2 theta is 2 cos square theta. 1 minus cos 2 theta is 2 sin square theta. And the moment you divide these two, you get something, by the way. Divide these two, it will become tan square theta. And this upon this is equals to 1 minus cos 2 theta. Very important. Whole upon 1 plus cos 2 theta. This is also very important. Divide these two. Sin square by cos square. 1 minus upon 1 plus. Okay? Then we have 3 angle formula. Sin 3 alpha is what? 3 sin alpha minus 4 sin cube alpha. So sin 3 alpha will start with 3 sin alpha. Okay? Cos 3 alpha will end with 3 cos alpha. So this is 4 cos cube alpha minus 3 cos alpha. That's how you remember it. Tan 3 alpha. Now there are many students who will ask me, ma'am, that ma'am, tan 3 alpha, who is going to remember this? How are we going to remember this? So basically I have a technique for you. Tan 3 alpha ka formula. So can you see 3, 3? So 3 is in the diagonal. Diagonal as in, I know matrices is over, but still diagonal, that means first term is 3 and here second term is 3. That is the first observation. Okay, in the numerator you can see the odd powers, that is 1 and 3. So 3 tan alpha minus tan cube theta, both are having negative sign. That's very good. So 3 tan alpha minus tan cube theta, right? The coefficient 3, 1, 1, 3. And 1 minus 3 tan square alpha, that means even power in the denominator, odd power in the numerator. Here the power is 0 and 2, 1 and 3. So now tell me, tan 3 alpha is 3 tan alpha minus tan cube alpha upon 1 minus 3 tan square alpha. This is what it is. Okay? Alright? Yes. So this I already told you. Sin 2 theta and cos 2 theta ke two formulas I already told you. 2 tan theta upon 1 plus tan square theta. I already mentioned, plus in the denominator. 1 minus tan square theta upon 1 plus tan square theta. Right? Okay. And there are two more formula, which is sin A plus B into sin A minus B. So sin A plus B, sin A minus B is sin square A minus sin square B. You can convert this completely into cos square as well. So this will become cos square B minus cos square A. And what about this? This you know, don't need to remember. I am just telling you at any given point you can do that. Okay? Only remember one formula. It will create a confusion. Sin A plus B, sin A minus B, sin square A minus sin square B. And you know what? Cos A plus B, cos A minus B would be cos square A minus sin square B. So now, I will tell you the technique to remember. Sin A plus B, sin A minus B. So the first term will be sin square A. The second term is fixed, sin square B. Cos A plus B, cos A minus B, the first term will be cos square A. Second term in both the formula is fixed. Only first term will vary. Only remember this. No need to remember this, because you can eventually convert this. right? Do that. So 1 minus sine square minus 1 plus cos square. So it will become cos square b. It will take hardly 10 seconds to convert. But do not mug two formulas because it will create confusion. Only remember this. So I have learnt it this way. I am telling you my way. Sin a plus b, sin a minus b is okay. Sin square a minus sin square b because sin square b is fixed. Now cos a plus b, cos a minus b is cos square a minus sin square b is fixed. ठीक है? I hope I helped you in remembering this. ठीक है? Alright. Now there are some commonly used formulas which I would like to tell you, and this is helpful in your integration as well. That's why before calculus I have secretly kept all the trigonometric formulas together. ठीक है? So cos theta plus sin theta whole square. Now this is very important. The moment you expanded cos square plus sin square, 1 plus 2 sin theta cos theta is sin 2 theta. Right? 1 minus cos 2 theta upon 2 sin theta. So 1 minus cos 2 theta is what? 2 sin square theta. And sin 2 theta is 2 sin theta cos theta. So sin and sin cancel, cos 2 cancel, sin by cos tan theta. So this is very easy. You can solve it as well. 1 minus cos upon 1 plus cos. So it will give me 2 sin square, 2 cos square. So this will become tan square theta. This formula I already told you previously. This is very important formula, by the way. फिर tan x plus y upon tan x minus y. So you just can simply convert this everything into sin and cos. Eventually you will get this formula. This though I already told you, number 5th formula. ठीक है? And number 5th में you can just easily replace plus sign by minus. You will get the answer. Cos theta plus sin theta, cos theta minus sin theta. Just convert this in tan. So divide everything by cos, and by cos you will get 1 plus tan theta, 1 minus tan theta, and you know what, 1 plus tan theta, 1 minus tan theta is this only. So these two are same thing, right? Then cos 2 theta upon 1 plus sin 2 theta. Again what you can do is cos 2 theta can be written down as cos square theta minus sin square theta. 1 plus sin 2 theta can be written down as cos theta plus sin theta ka whole square. So it will become this only. It will become cos minus sin upon cos plus sin, which will be the negative of this, reversal of this. Yes. So this will be tan 45 minus theta. And then cot theta minus tan theta. No need to remember, just the basic result, 2 cot 2 theta. ठीक है? sin 2 theta, I already taught you these two formulas already. है ना? Thrice. We are doing this thrice. Okay? ठीक है? तो all these formulas we have already learned. So these two formulas, okay. Yes. Now this is something which is important in your functions chapter, in your application of derivatives as well, multiple calculus chapters. So the moment you see a sin theta plus b cos theta, so minimum value of this expression is what? Minus square root a square plus b square. Maximum value of this expression is a square plus b square. And you know what, I've got a question for you as well. So the question says that 3 sin 2 theta plus 4 cos 2 theta की maximum and minimum value बतानी है. So you know what, maximum and minimum value. So minimum value is minus of 3 square plus 4 square, and maximum is plus 3 square plus 4 square का root. So this will become minus 5, this will become plus 5. So minus 5 plus 2 and minus 5, sorry, plus 5 plus 2. So this is minimum value, minus 3 is minimum, and maximum is what? 7 is your maximum value. Yes? Minus 3 is minimum, 7 is your maximum. Alright. Okay. Right, so we do have some more formulas. Okay? So you know what? It's been more than 4 hours we are studying, and if you have still not liked the session, what should I do? I can't do anything, है ना? So yes, transformation of a product into sum. Yes. So actually क्या करना है इसके अंदर? What we have to do is sin a plus b, sin a minus b. Sin a plus b is what? Tell me. Sin a cos b plus cos a sin b. Sin a cos b plus cos A sin B. What about sin A minus B? Same thing with a negative sign over here. Right? So sin A cos B plus cos A sin B होगा. Sin A cos B minus cos sin B. So this term will get cancelled out with this only, and this term will be twice 2 sin A cos B. Can you see 2 sin A cos B? That's how we do it. And if you subtract these two values, so this 2 cos A sin B will be left out over here. Right? If the negative sign is here. So these two are same thing. Same thing we will do with cos A plus B, cos A minus B. So this is cos A cos B minus sin A sin B. Plus cos A minus B is cos A cos B plus sin A sin B. Can you see these two terms are getting cancelled out? So 2 cos A cos B. And if you subtract these two value, 2 sin A sin B. But here is a catch in this. In this formula, there is a catch. So this is 2 sin A sin B. So this is reverse actually. Cos A minus B minus cos A plus B. So this particular formula should be remembered carefully. Okay, minus only the reverse thing you have to do, cos A minus B minus cos A plus B. In case of any doubts, just expand this. These two, it will hardly take 10 seconds because वो कहते हैं ना, but दुर्घटना से, we have a saying in Hindi, दुर्घटना से देर भली. It's better to get late than met with an accident. So it's better to reach to the correct answer rather than getting a slap of -1. ठीक है, right? And then sum and difference, yes. So in these formulas only, in these 4 formulas, what I'll be doing is, I'll be shifting A plus B will be C, A minus B will be D, right? And C plus D by 2 will be your A, and C minus D by 2 will be your B. ठीक है? So A is what? C plus D by 2. B is what? C minus D by 2. This is C, this is D. So now tell me, sin C plus sin D is 2 sin C plus D by 2 cos C minus D by 2. Sin C minus sin D is 2 cos C plus D by 2 sin C minus D by 2. Now cos C plus cos D is 2 cos C plus D by 2 cos C by C minus D by 2. And in here, can you see cos D minus cos C, right? Cos D, this is again important. Cos D minus cos C is 2 sin C plus D by 2 sin C minus D by 2. So here are the 4 formulas. Can you see? Sin C plus sin D, so sin and cos. Sin C minus D, cos and sin. Cos C plus cos D, now both will be same, cos and cos. Cos C minus cos D, now here is a catch. It will either be minus of 2 sin C plus D by 2 sin C minus D by 2, or if you want to absorb this minus sign, it will become D minus C by 2. Yeah, either remember this minus sign, or remember that cos C minus cos D is having sign D minus C by 2. Yes. Alright. Then we have a product series. So cos theta, cos 2 theta, cos 2 square, cos 2 की power n minus 1. Right? How to remember this, I will tell you. Suppose you have cos of 2 degree, cos of 4 degree, cos of 8 degree, and all the way up to cos of 128 degree. ठीक है? I am taking an example. How to solve it? So this is what? Can you see the angles are in GP? The angles are in GP, है ना? So can I write it as cos 2 degree, cos 2 square degree, cos 2 cube, 2 cube, and cos in here what I can write it as 64. So 32 is 2 की power 5. Then 2 की power 6 is 64, 2 की power 7 till 2 की power 7 degree, right? So angles are in geometric progression. I will show you how to remember the formula, and you know what? Trust me, you will remember this formula. This is so difficult to remember this khichdi, right? This chaos. I will clear this chaos now. Okay, how to just solve it? So सबसे पहले understand that कि you are going to write the sign of smallest angle. Sign of smallest angle. What is the smallest angle? 2. So sine 2 degree. Here 2 is what? The smallest angle. And 2 raised to power number of terms. How many terms are involved? Starting from 1 to 7. How many terms you can see? 7 terms. So 7, what is this? Number of terms. ठीक है? Okay. And यहाँ पे sine of 2 into the largest angle. Sine of 2 into the largest angle. So sine of 2 into what is the largest angle? 2 की power 7. So what is the answer? Sine 2 की power 8 upon 2 की power 7 sine 2 degree. Yes, that's how we solve it. ठीक है? So this is what? This is sine of 2 into larger angle. This is smaller angle. And this is number of terms. Number of terms. ठीक है? That's how you solve it. That's how you remember. So how will you remember? So numerator is sine 2 times the largest angle. Sine 2 times largest angle is 2 की power 7. That is one thing. ठीक है? Upon में 2 की power number of terms and sine of smallest angle. ठीक है? This is how your product series of cosine will look like. And now before actually getting into the calculus part, 2 last topics. The moment you see the arithmetic progression in sine, inside the sine, that is sine 2 degree, sine 4 degree, sine 6 degree, the angles of the sinusoidal are in AP and a summation series is getting formed. You have a formula which is, so it would be sine n times half the common difference upon sine half the difference and sine first angle plus last angle. So A plus last angle by 2. That's how you solve it. Same for cos. So cos, cosine, arithmetic angles are in arithmetic progression. So sine n times half the difference upon sine half the difference cos of first angle plus last angle by 2. Right? So cosine with this will be cos, sine with this will be sine. Right? This part is same, sine n times half the angle. This part is, both the formulas are same. And this question we have done in the mock test as well. So 2 trigonometric series where the angles are in AP. Summation series where angles are in AP. Very easy to solve. Very easy to solve. ठीक है? Alright. Okay. Let me just, maybe it is not visible, right? So for conditional identities, if your A plus B plus C is equal to pi, that is 180 degree. That means you are talking about angles of a triangle. If ABC are angles of a triangle, then there are some things which you need to remember. Sine 2A plus sine 2B plus sine 2C is equals to 4 times sine A, sine B, sine C. ठीक है? Similarly, for cos also we have a formula. So cos 2A plus cos 2B plus cos 2C is equals to minus 1 minus 4 cos A, cos B, cos C. Then if we have sin A plus sin B plus sin C, then we have what? Simply, directly 4 cos A by 2, cos B by 2, cos C by 2, the third formula. And you know what? The very important formula of all, the boss of all the formulas of part D, please do remember this. So the formula is tan A plus tan B plus tan C, that is sigma tan A. Sigma tan A. This is sigma tan A. Very important. Is equals to tan A, tan B, tan C, that means pi tan A. So sigma tan A is equals to pi tan A. Pi matlab multiplication. So sigma tan A is equals to pi tan A, very important. And last but not the least, this formula is also important. tan a by 2 tan b by 2 plus tan b by 2, that means what is written? Tan a by 2 tan b by 2 is equals to 1. Right? Sigma tan a by 2 tan b by 2 is given as 1. Right? Okay? Okay. Now say only two things related to trigonometric equations. So the moment you see sin theta is equals to 0, that means your theta is n pi. The moment you see cos theta 0, that means your theta is odd pi by 2. Right? Sin theta कब 0 होता है? n pi पे. Cos theta कब 0 होता है? Odd pi by 2 पे. Both the conditions. Right? Now cos theta 1, cos theta minus 1. I already told you by the way. Cos theta 1 होता है even pi पे, that is 2n pi. Cos theta minus 1 होता है odd pi पे. So cos theta minus 1, that means angle is odd pi. Cos theta 1, that means angle is even pi. Cos theta 0 odd pi by 2. Sin theta 0 integral multiple of pi. Alright. Okay. Alright. Now some important results related to your trigonometric equation. So the moment you see sin theta is equals to some known angle sin alpha. Suppose you see sin theta is equals to sin pi by 3. है ना? That is root 3 by 2. So what can you write? You can write theta is equals to n pi plus minus 1 की power n alpha. ठीक है? The moment you see cos theta is equals to cos alpha, so you write theta is equals to 2n pi plus minus alpha. ठीक है? The moment you see tan theta is equals to tan alpha, you write theta is equals to n pi plus alpha. And if there is a square involved, so sin square theta is equals to sin square alpha, suppose, or cos square theta, cos square alpha, or tan square theta. It is having the same formula for all three squares, n pi plus minus alpha. Right? So these are the results related to what? Yeah, that's why I have written it is not visible, I guess, to you, but to me it is visible. When you get the PDF, it will be visible. So that's why I wrote it. Right? Same things I have wrote it. So A, 1, then 2, then 3. Right? Cos square theta, cos square alpha, tan square theta, tan square alpha. ठीक है? All right. So that was all about trigonometry. Okay, I know there are so many formulas, but I have actually mentioned which formulas are important. I cannot skip those unimportant formulas, but I have highlighted that okay, these are formulas which are more important. So you can pick your formulas which are like do or die formulas. Okay, and you know what, we will start calculus. Okay, and you can see that 52 questions were asked from functions, relation functions, and integration 47, LCD 30 question, differential equation 25, and then 22. This is all about it. है ना? तो we will start this after a break. And tell me how many minutes break you need. How many minute break you need? Do you need 10 minutes break or more than 10? It's 9:25 already. Yes, have dinner. Inverse trigonometry we will do towards the end. Inverse trigonometry has a very little weightage, no? That's why I kept it towards the end only. Okay, the last thing I will do it is inverse trigonometry, but without trigonometry I cannot proceed with the calculus portion, right? So that's why. 10 minutes. Okay, 10 minutes. Okay, I'll be also 30 minutes. Kya? 10 minutes. Okay. So come back at, so 9:25 already there. 9:35. Okay, let's meet at 9:37 PM. Okay. 10 minutes. Yeah. 9:37. You can eat it in this time. Okay. 9:37. 9:25. 9:37. 12-minute का break ले लेते हैं. Let's take a 12-minute short break. I will also have something. Drink water, walk around, and just refresh and come back. I am back. I thought people must be writing late, OP. I am 3 minutes late. All set? All done? Done. Come back. Come back. I am back. Okay? Chalo. Let's just start the calculus portion. And I know that you are waiting for calculus, and more than that, you are waiting for coordinate geometry as well. Suppose that we'll be doing coordinate geometry. Do not worry about that. So we'll start in this sequence. Sets, relation, functions quickly. Then integration. So it might take some time because indefinite plus definite integration. After that we have differentiation as well. MOD, method of differentiation. I won't spend much time on method of differentiation. And post that we have application of derivative and differential equation, right? And let's not forget area under curve is also there. Okay, let's just quickly start diving in and discuss the equivalence relation quickly. Let me know in the chat box. So yes, equivalence relation. So a relation is called as an equivalence relation if it is reflexive, symmetric and transitive. All three check boxes should be ticked. It should be reflexive, it should be transitive, it should be symmetric. What is reflective, ma'am? Right? What is reflective? Suppose we have a set A which is 1, 2, 3 and I am defining a relation on set R. Defining a relation on set R. That means what? On set A. Defining a relation on set A. That means your relation R will have ordered pairs from A cross A. Right? So both the sets. Right? Set A is also set. The second set is also A cross A. So if I talk about the reflexive relation means that reflexive relation means that in this relation R there must be all the ordered pairs which will be like A comma A. That means 1 is the element of A na, so 1 comma 1 should sit inside this relation. 2 comma 2 also should sit inside the relation, and 3 comma 3 should also sit inside the relation. That means A comma A should be sitting inside the relation for all the values of A belongs to A. All the elements which are present in set A, you can see 1, 2, 3. So related to 1 we should have 1 comma 1 as the ordered pair. Related to 2 also we have ordered pair. Related to 3 also. So this is what we call a reflexive relation. Reflex. So we are reflecting. We are seeing ourselves. It is a mirror. Okay. So reflexive. And what about symmetric? So symmetric relation says that if 1 comma 2 is present in my relation, then 2 comma 1 should also be present in my relation. That's all. So if A comma B is there, then B comma A should also be there. What is transitive? So transitive is again very easy. If we have 1 comma 2 in our relation and 2 comma 5 in our relation, suppose. Now can you see this 2 and 2 are same? 1 comma 2, 2 comma 5. Then what do we say? That 1 comma 5 is in this relation. 1 comma 5 is in the relation. 1 comma 5 is lying in the relation. Okay, okay. Chalo, let's understand with the help of a question. So we have this question which says, JEE Mains 2023 by the way, which says that a relation R is given by this. That means relation R, inside this relation R na, we have x comma y as an ordered pair. Okay, and it will sit inside my relation if this equation holds true, then only. Okay, so what is this equation? If I see this equation, I can clearly see that this can be factorized as x minus 2y and x minus y is equals to 0, isn't it? The moment you multiply, you will get this relation. That means x is equals to 2y or x is equals to y. So the question is saying all the ordered pairs which will satisfy either this or this relation will sit inside my relation. That's what the question is trying to say. What we need to figure out is whether this relation is an equivalence relation, symmetric, transitive, and everything, right? So basically x is equals to y. So each and every ordered pair which will satisfy this relation will sit over here. So x is equals to y. This is the condition of reflexive. Reflexive relation holds this condition only, that both the elements of ordered pair should be equal, right? So that means this is clearly a reflexive relation for sure. So that means a reflexive relation to aayega hi. What about the symmetric? Whether my relation is symmetric or not. So how to actually conclude whether my relation is symmetric or not? You just give me one wrong scenario. That will prove that okay, this relation is not symmetric. Just give me one wrong, incorrect ordered pair and you just tell me that, ma'am, that see, this is not happening over here. Okay. So let me just tell you that if I put y is equals to 1, x will be what? 2. That means 2 comma 1 belongs to my relation. Okay. If 2 comma 1 belongs to my relation, this implies 1 comma 2 should also belong to my relation. Then only I can call it as a symmetric relation. If this is not happening, then my relation is not symmetric. So 2 comma 1, so I can clearly see I can satisfy 2 comma 1 over here. The moment I plug in y is equals to 1, x is coming out as 2. But if 2 comma 1 is here, then 1 comma 2 should either satisfy this or this. So 1 comma 2. The moment I plug in 1 over here and 2 in place of y, I can clearly see this relation fails to exist. That means 1 comma 2 does not belong to my relation. This is not a symmetric. So basically reflexive but not symmetric is absolutely right. So it is reflexive but not symmetric, and hence it is not transitive as well. So this is wrong. That's all about equivalence relation. Now let's move on and talk about, yes, some functional equation. Functions. Let's talk about functions. Let's revise functions a bit. So functions may, if I talk about functions is a whole huge chapter. If we get into the detail, it will take hours and hours of study. I'll give you some gist about the composite function, which is important by the way. So suppose we have two functions, f of x and g of x, right? And composition of f and g. Composition of f and g is denoted by fog x or gof x. Now what is fog x? What is gof x? We will see. Fog x is nothing but f of g of x. Gof x is g of f of x. Let's understand this with the help of an example. Fx is given as sin x, gx is given as x square, and if we are looking for fog x, that means we are looking for f of g of x, right? F of g of x. That means on this whole scenario, just replace x by g of x. The moment I replace f by g of x, it will become what? It will become f of g of x is equals to sine of g of x. Now what is g of x? It is x square, so this is becoming sine x square. That's how we calculate fog x. Now if someone asks me, okay, calculate gof x. So gof x is g of f of x. G of f of x. What shall I do? So in here, just replace x by f of x. You will automatically get g of f of x is equals to fx square. So g of f of x is equals to fx whole square. What is fx? Fx is sin x. So sin x ka whole square. Sin x ka whole square. So this is all about composite function. I wanted you to revise it. Okay? Now. As per my analysis, I am seeing that in 2023 and in 2022 as well, the functional equations was something which was like, so NTA has showed extra favoritism towards the functional equations. So I want you to remember all the functional equations, because not even single question, basically multiple questions from this topic were there in the whole 2023 paper. So this is very, very important. Okay, I'll show you how to revise it. Yes, Devi Shri Prasad, I can see you answering all right, perfect. Okay? So these two are together, these two make a team. F of xy is equals to f of x plus f of y. F of xy is equals to f of x into f of y. When you see a positive sign, just write k log x, k ln x, natural log. When you see a multiplication sign, it is x ki power n. Right? So repeat after me. F of xy is equals to f of x plus f of y is nothing but k ln x, and f of xy is equals to f of x into f of y, x की power n. याद हो गया अभी immediately right now. Okay, now next two, we will use it, by the way, we will use it right away. So f of x plus y is equals to f of x into f of y. If this is given, your function is what? A की power x. F of x plus y is equals to f of x plus f of y. So your function is k of x. Right? Repeat after me. So this is again pairwise. You can remember. What about this? F of x, f of 1 by x. Okay, this is very important. F of x into f of 1 by x is equals to fx plus f of 1 by x. So there are actually two polynomials in the whole planet which will satisfy this equation, which is 1 plus minus x की power n. 1 plus minus x की power n. ठीक है? Alright. Let's just start solving a question. Let's just start solving this question. JEE Mains 2023. Fx be a function such that f of x plus y is equals to f of x into f of y. Right? The moment I see this, I know that my function is what? A raised to power x. And in the question it is given that f of 1 is equals to 3. So f of 1, the moment I put 1, so this will become 3 is equals to a की power 1. So a is coming out as 3. That means your function has become what? 3 की power x. Khalas, game over. Game over, guys. Done. Done with this question, right? So now they are asking me ki calculate f of 1 plus f of 2 and all the way up to f of n, and this value is 3279. So this is what? 3 की power 1 plus 3 की power 2 and all the way up to 3 की power n is 3279. What is this? We have already studied sequence and series. Sum of a geometric progression is what? A की power r की power n minus 1. R minus 1 is equals to 3279. Apply the formula. Apply the brains. So you will get this. And this is 3279. 3 के table से काटो. 3 1s are 30. 3 9s are 27. 1093. Multiply it with 2. So 2186. So 3 की power n is what? 2187. So n is coming out as 7 because this is what? 3 की power 7. Yes, n is 7. Option B. Done. I can see so many good answers. Okay, Pramod, Yojana, GT's Art. No, GT's Art has not given the correct answer. Pramod has given. Okay, Yojana has given. All right, nice, very nice, cool, perfect. Thumbs up, a big thumbs up. So functional equations, as I told you, are important. That's what I was telling you. Let's now talk about limits. Okay, so limits. So to solve limits, there are a few things, few methods which we need to figure out. First is L'Hopital rule, your favorite rule, right? Every time I solve any question related to limit, the whole chat box is asking me, ma'am, apply L'Hopital, apply L'Hopital. So this is your favorite rule that we will study. Factorization method, rationalization method, limit when x tend to infinity, right? What happens? Trigonometric limits, logarithmic and exponential limit, that means some standard limits, and 1 raised to power infinity form. Along with that, 0 raised to power 0, infinity raised to power 0, all these forms we will be tackling. Okay, and yes, 0 raised to power 0, infinity raised to power 0. Okay, these three forms together we will discuss. Okay, alright. So these are the 7 indeterminate forms. So we majorly focus on these two forms. and then 1 raised to by infinity is also very important. Then these three are taken care together, because some little tweaking is required. Rest it will become the same as 0 by 0, or it can become infinity by infinity. Okay. First rule is L'Hopital rule. I'll give you a question. So question says that okay, limit x tend to 0. Who is going to tell me? Actually take it like this, 3x plus 1. Yes. What would be the answer of this question? Who is going to tell me? Three by 4. Yes. Limit x tend to 0, 3x plus 1 upon 1 plus 4x. Answer, answer, answer. Okay, so basically without even looking at it, many students might apply L'Hopital rule, which will actually give what? So this is 3 by 4, right? The moment you apply L'Hopital, you will get 3 by 4, but this is incorrect. As I always tell you, that L'Hopital rule is only applicable for 0 by 0 or infinity by infinity form. Okay? So are there any students who are giving me 3 by 4? Kirti is again saying 3 by 4. Why? Yes, so L'Hopital is not applicable, because always check. The moment you see any problem from limits, always check form of that limit. The moment you put x is equals to 0, you will get 1 by 1. So 1 is the answer. No need to apply L'Hopital, right? No need to apply L'Hopital. Okay? So when to apply L'Hopital? When your fx by gx, limit x tend to a, is becoming either 0 by 0 or infinity by infinity, then what you can do is you can apply L'Hopital. So it will become f dash x upon g dash x, right? Limit x tend to a is equals to double dash, triple dash. How many times you can apply? But there is no point if you are applying multiple times and still you are getting stuck. Then use a different method. Don't just chase L'Hopital blindly. Okay? Because there are students who just go blindly with this. Okay, limits ka question aayega, we will apply L'Hopital. Don't do that. Okay, L'Hopital is the last thing which you should do. Infinity limits, let me just show you what is infinity limit. So basically one question I want to give you, 2x square plus 3x plus 2 upon 3x square plus x plus 4, limit x tend to infinity. Okay. दूसरा क्वेश्चन, so limit x tend to infinity 3x square plus 2x plus 1 upon x plus 3. तीसरा क्वेश्चन, okay, so this is bigger, this is smaller, 3x plus 2 upon x square plus x plus 1, again limit x tend to infinity. Can you see there are three different cases over here? In the very first case, degree of numerator and degree of denominator are same. Degree of numerator and degree of denominator are same. When degree of numerator and degree of denominator are same, what you can do is you can just simply write coefficient of highest power 2 upon coefficient of highest power 3. Okay, this is the shortcut whenever you see it, right? And in this case you can see degree of numerator is greater than degree of denominator. What does that mean? Degree of numerator, so numerator is having infinity and denominator is also infinity. So basically infinity by infinity form is getting created. But this time when degree of numerator is greater, your answer will be infinity only. Matlab does not exist. Your answer will be does not exist, right? And when your degree of numerator is smaller than degree of denominator, then the answer will be 0, right? Only three cases. Whenever you see infinity by infinity, either degree are same, so you will get highest power coefficient upon highest power coefficient. The moment you see infinity by infinity form, degree of numerator is greater, that means infinity on numerator is greater, it will throw towards infinity. And if infinity of denominator is dominating, that means you will get a 0. And you know what, do not just understand the shortcut, I will teach you ki how are we coming to this particular situation. So what you need to do in all the three situations, the basic trick is take out highest power common and you will be done. Take highest power or out. So in this question, x square, let's take it out. So 2 plus 3 by x plus 2 by x square whole upon 3 plus 1 by x plus 4 by x square. Now I have taken x square common, cancelled it. Limit x tend to infinity. The moment you plug in infinity, this will become 0, this will also become 0, 0, 0, 0, 0. So only 2 by 3 will be left, right? And same over here. So 2 by 3 is the answer. That's why I was saying highest power. Highest power ka coefficient. Now again x square, take x square common, and you know what, from denominator you can't take x square common. So if you take x square common, it will become what? 1 upon x plus 3 by x square. And what about 3 plus 2 by x plus 1 by x square? Now the moment you plug in, this is cancelled. The moment you plug in x equal to infinity, this is 0, this is 0. And denominator both are 0, so 3 by 0 will make infinity. And same, take x square common. So 3 by x plus 2 by x square and 1 plus 1 by x plus 1 by x square. Taking out x square common every time. So can you see, numerator is 0, denominator is 1, 0 by 1 is nothing but 0. So that's why it is 0. Yes, absolutely, absolutely, Joyce Mary, absolutely we should take x square common. That's what I was agreeing. Yes, that's what I was saying. Okay. Alright, so now we have a question with us, JEE Mains 2023, and the question says that limit of this huge scary looking expression. These are those kind of questions, you know what, by first moment, by first glance you find it, okay, what is this? This is looking super duper scary, right? But when you solve it, when you understand it, you will realize, okay, this can be solved in a jiffy. I will tell you the shortcut. So first of all, what you need to do is you need to understand. The moment you plug in x is equals to infinity, this is becoming infinity plus infinity power 6. So infinity, and this is again infinity power 6, infinity power 6. So infinity by infinity is the form who all will agree. Infinite, the moment you see infinity by infinity form, check, always check whether the degree of numerator and denominator are equal or greater or less. Which category is it? Okay? So degree of, I can clearly see that degree of numerator is what? Root x ki power 6, x cube and one more x cube. So overall numerator degree is what? X ki power 6. What about denominator degree? X ki power 6. Denominator highest degree is x ki power 6. That means degree of numerator, degree of denominator both are 6. Yes, both are 6. Now what to do? We need to just actually take out highest power coefficient from numerator and denominator. Okay, let's do that. So highest power, what is the highest power in the numerator? X ki power 6. So here x cube is already there. So let me just look for, so basically coefficient of x ki power 6 upon coefficient of x ki power 6 will be the value of limit. Do you agree or not? This is the value of limit. Right? How to find coefficient of x ki power 6? Because x ki power 3 is already there. So coefficient of x ki power 3 in this bracket, if I find now, in this whole bracket, this bracket, green bracket. So that also that will also be fine because x cube is already there. So that will make it coefficient of x ki power 6 upon coefficient of x ki power 6. Okay? In which? In this green bracket. Okay? In this green bracket. So now let's find out coefficient of x ki power 3 in this green bracket. So I can clearly see that root 3 plus root 3 की power 6. Yes, because this root x will become x cube. So root 3 plus root 3. So this will be root 3 plus root 3 की power 6 plus sign. We have more x की power 6 by the way. All the coefficients we need to collect carefully. So root 3 minus root 3, that will give me a 0 whole upon. Now in the denominator, x की power 6 का coefficient. So this is x की power 6. So this is 1. Right, and x square ka root, this is x only, x की power 6, so also 1. 1 plus 1 2, 1 minus 1 0, so 1 plus 1 raised to power 6 and then 0 again. So 2 root 3 upon 2 की power 6 will give you root 3 की power 6, 3 की power 3, that is 27, and you know what, option D is absolutely right. Saicharan, what happened? This is the shortcut, by the way. Okay, is equal to 27. Give me a big thumbs up quickly. Okay. Now there are some trigonometric limits which I want you to remember, which are sin x by x when x tends to 0 is 1. That means sine of the 0 upon same 0. If I tell you that sin x square by x square, yes. So sin x square by x square is equal to 1 when x tends to 0. So basically sin की अंदर वाली quantity should be same as the denominator. These two quantities should match and both should be tending towards what? 0. Again same, tan x by x is 1. ठीक है, तो these two trigonometric limits, but one trigonometric limit which is my favorite, I always tell you that you should remember cos x, 1 minus cos x upon x square, limit x tend to 0 is half. How many of you remember this limit? Because if you remember this limit, you are going to kill the limits wala questions. In many questions from 2021, 2022, 2023, directly this limit has been used. ठीक है, directly. So ये हो जाएगा 1 minus, so basically what I'm trying to say is 1 minus cos something upon something का square is nothing but half, limit x tend to, this box should tend to 0. Right, so 1 minus cos upon that something का square is equal to what? Half. This is what our limit is. Again log 1 plus x by x is 1. Again log 1 plus 0 by same 0 should be equal to 1. ठीक है, and if there is a log base a, so it's simply 1 by log a, because you apply base changing theorem, so it will become log a only. Exponential limit, so e की power x minus 1 upon x is given as 1. Same thing, e की power 0 minus 1 upon same 0 is equal to 1. Right, and if in place of e you will see a, then it will become log a. Right, so basically these two are same thing. This is actually coming as log e. Log e is 1. This is coming as log a. Right, yes, so you can remember this generalized limit, and a could be anything. If a is e, it will become log e is 1. So basically this is a special case. This is a special case of, this is generalized, this is specialized, because generalized a could be anything 1 2 3 4 5, not 1 but 2 3 4 5 6 and so on. A could be e also, so it will become log e, a will be replaced by e, then this special case will get generated. Right, now let's solve this question, JEE Main 2023. I'll give you actually 30 seconds to think about this question. So fx, let's read the question from the beginning. X is equals to 2 be the root of this equation, and your fx is given by this, right? So what we need to figure out of limit of fx, x tend to 2p, where this bracket is nothing but greatest integer function. So you all know that how to calculate limit, है ना? So limit of fx where x tending towards a exists when limit fx, when left hand limit is equals to right hand limit. This is the basic definition. is equals to finite thing is equals to finite. Then your limit exists. You know this is left hand limit. That means you are calculating the approximate value when your x is slightly less than a. Here your x is slightly greater than a. है ना? So here what you need is, you need x should be slightly greater than 2p, right? So the moment I see this now, this thing, this part is actually troubling me. Can you see? This part is troubling me. Okay, this part is troubling me because this is a little bit messy and chaotic, or a bigger expression. But the question is telling me x is equals to 2 be the root of this particular quadratic equation. So why not I plug in the x equal to 2 over here. So 4 plus 2p plus q is equals to 0. At this part, q square plus 8q plus 16, if you carefully observe, this is nothing but q plus 4 ka whole square. So why not I take q plus 4 on my one side and square it, and minus 2p on other side and then square it. So 2p shifted to right side and then I am squaring it to just get rid of this the final circled value. So q square plus 16 plus 8q is coming out as 4p square. So this is 4p square. So now your fx is modified and it is written down as 1 minus cos of x square minus 4px plus 4p square upon x minus 2p की power 4. And ये 0. ये कब है? जब your x is not equal to 2p and this is x is equals to 2p. And you know what? 1 minus cos, this particular thing is what? X minus 2p ka whole square. So you know what? Now your fx is coming out as 1 minus cos x minus 2p ka square upon x minus 2p ki power 4 when your x is not equal to 2p, and when your x is equal to 2p it is becoming 0, right? What you are looking for is limit of 2p plus. That means you don't go for this, you go for this. X is slightly greater than 2p. The moment you plug in 2p, this will become 0, this will become what? 0. But then you know what? I told you about that limit 1 minus cos of something upon that square of something, both should be 0. Don't you think that is getting formed the moment I apply this limit? The moment I plug in 2p over here, this will become 1 minus cos 0 and this will become 0 ka square. So this whole limit clearly is what? Becoming half. So limit of half greatest integer function extend to 2p plus will be nothing but what? 0. So 0, because the value is coming out as half, but because of the greatest integer function of half is nothing but 0. So yes, option C, absolutely right. Yes, C. Let me see in the chat box. Okay, Harshi is saying half. But Pramod is saying 0. Okay, Harshi is now saying 0. Perfect. Pramod, very nice. Okay. Yes. So now let me just show you some expansion wale thing. Let's just remember the expansions. So sin x is an odd function. I'm telling you the trick to remember the expansion. So sin x is an odd function. So basically all the powers would be odd. X ki power 1, x cube, x ki power 5. All the signs are always alternate and factorial notation will be followed. So sin x ka expansion, how to remember? X by factorial 1 minus x cube by factorial 3 plus x bar 5 by factorial 5 and so on. This is your sin x. Now once you remember sin x ka, now cos x is an even function. All powers should be evens. It will start with 1 minus x square by factorial 2 plus x ki power 4 by factorial 4. This is cos x. Now tan x, what you can do is, if you don't want to remember it, you can simply write sin by cos. You can just mix and match and apply this, or you just remember these three terms: x plus x cube by 3 plus 2x power 5 by 15. That's it. It will work. Then you have e की power x, that every JEE aspirant should know this, otherwise my blood will boil. 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Okay, it will go up to the infinity, and then log 1 plus x. Now log 1 plus x. Now one catch. Can you see every expansion is having factorial notation except, okay, this is also having some kind of, but tan x if I don't consider, sin cos e की power x. Okay, this is not having factorial. Log 1 plus x is having alternate sign. First of all, it is starting with x minus x square by 2 plus x cube by 3 minus x की power, no factorial, no factorial. ठीक है? Okay. All right. What am I doing? Yes. So we have this question with us, which says we need to figure out limit of this particular expression. It is given that 17. We need to figure out 5a square plus b square. So this question smoothly, clearly can be done using the help of the expansion. Now e की power ax, right? This is ax. So e की power x का expansion 1 plus x will be replaced by ax. Then ax का square by factorial, right? And so on. Minus cos bx. Now cos का क्या था? Cos is an even function. It will start with 1, right? So it will become 1. Alternate sign always. Minus bx का whole square by 2 factorial plus bx का power 4 by 4 factorial. ठीक है? 4 by 4 factorial and so on. Minus cx by 2 is outside. E की power minus cx. So e की power minus cx. So this time expansion of e की power x, but 1 minus cx plus cx का square by factorial 2 and so on. Whole upon what do we have? 1 minus cos 2x, right? Now I already warned you about my favorite limit. The moment I see 1 minus cos 2x, I clearly know that I need a 2x की power 2 in the numerator, right? And because of that 2x की power 2 in the denominator. So that this quantity will become 1 by 2, and 1 by 2 is what? 1 by 2 matlab that means a 2. It will give you a 2. So let me just write it 2 upon, this is what, 2x square. So 2x ka square and limit x tend to 0 is here. Let's just now solve this part. Let's just now collect the coefficients. So 1 and 1 are getting cancelled. Okay? So basically I don't have any constant term involved. I just have coefficient of x. So ax, here I can't find coefficient of x, and then minus cx by 2. Ax minus cx by 2. So ax minus cx by 2. So a minus c by 2 x plus. Now collect the coefficient of x square this time. So it will become a square by 2, right? A square by 2. So a square by 2 is the coefficient of what? X square. What else? What else? Other coefficient related to x square. So minus plus b square by 2 factorial. So b square by 2 factorial. So b square by 2. What about the third coefficient here? So cx by 2 cx. Minus plus c square x by 2. So it will become plus c square by 2. And there will be other term related to x cube and x की power 4. But we are not interested in, because you can clearly see that x की power 2 is in the denominator, right? And this limit is what coming out as 17. Now listen to me carefully. You want this limit to exist? Yes. You want this expression to have a finite value? Agree? So if you want this, then what would be the first expression? So it would be a minus c by 2a minus c by 2 x upon x square. So that would be 1 by x. The moment you put x equals to 0, this will shoot towards infinity, that you don't want. So that means this expression is creating trouble for us. To pacify this trouble, we need to make this disappear. We need to shoot this. We need to make it 0. So that means 2a is equals to c, that is the thing. This is the first thing, right? What about the second thing? So this is x square upon x square. X square upon x square is 1. That means this is giving me a finite quantity, and this finite quantity should be equal to 17. Quickly do that. So this 2 and 2 square are cancelled, so 1 by 2. So basically a square plus b square plus c square upon this 2 into 2, 4 is coming out as 17. So a square plus b square plus c square is what? 68. And you know what? C key value you can count put as 2a ka whole square. So 4a square plus 5a square plus b square value is coming out as 68. 68 is the final answer. Yes, I can see Pramod is saying 68. Very nice. Very good. Okay. Yes. Nice answer. Great answer. So yes, just look at the expansion. So this was the question given to us. E की power ax cos bx and this, right? So we have applied each and every expansion, plug in the value over here, right? And we have used this 1 minus cos 2x. 4x square is left. So we are actually left with what? So this a minus c by 2. So this is the 1 by 2, right? What about this? X upon x square. So this term is shooting towards infinity. We have to make it 0. And this a square plus b square plus c square by 2 by 2. So this is what is equals to 68. And yes, that's about it. 68 is the correct answer of this question. Okay? Now 1 raised to power infinity form. Instead of expansion, can't we do L'Hopital rule? You can apply L'Hopital rule, but you know what? It won't be sustainable. Why? Because you can apply. Acha, you L'Hopital rule though you can apply, but you will get stuck in the L'Hopital rule. You will get stuck. That's what it is. That's why we are not applying it. Okay? That's answer to your question. Now 1 raised to power infinity. There is actually a very different way to solve 1 raised to power infinity form. I'll show you what is the correct way. So the moment you see that, okay, x plus 1, so basically 1 plus x raised to power 1 by x, where limit x tend to infinity, sorry, x tend to 0. Okay? I am giving you an example. So this, first of all, you need to check the form. So 1 plus 0 raised to power 1 by 0. So 1 plus 0 raised to power 1 by 1 raised to power infinity form is this. So how to tackle it? How to solve it? So first of all, you have to write e over here. Write down e over here. E raised to power, what you're gonna do is take this power down. So 1 by x. Multiply. Now what you need to do is you need to subtract 1 from here. So 1 plus x minus 1. So what we are doing is we are taking this infinity thing down. This is your power, and subtracting 1 from the base. 1 cancel, x cancel. This will become e की power 1. Can you see this? What did I do? So 1 plus fx raised to power gx. How to write? So this is 1 raised to power e raised to power g of x. E raised to power this power. Multiply. Now subtract 1 from this. It will become what? F of x. E की power gx into f of x, limit x tend to a. Okay? So we have a question. Let's understand the question. Again, if you see this question in the JEE Main, you will be telling me that, ma'am, this is a little bit scary, but this is not that scary. The moment you reach here, you realize, okay, x is 0. The moment x is 0, cos 0 is 1, and 1 by sine 0 is what? Infinity. Okay? Okay? है ना? तो 1 raised to power infinity anyway is getting formed, right? 1 raised to power infinity. So why not I solve this 1 raised to power infinity form, right? Let's do that. So to solve 1 raised to power infinity form, we need to write e raised to power 1 upon sin x ka square, and what we need to do is we need to subtract 1 from the base, so it will become cos of x upon 3 ki power r minus 1, where limit x tend to infinity is there, x tend to 0 is there, right? I am just focusing on this portion, only this portion, ठीक है? 1 raised to power infinity portion, ठीक है? So I can clearly see that this is something is getting formed. I know 1 minus cos something upon something ka square is half when this something is 0, ठीक है? So what I need is, so this is a, let's take minus sign common, so minus 1 upon sin x square, and this is 1 minus cos of x by 3 ki power r upon x square by 3 ki power r ka square, and again x square by 3 ki power r ka square. So this will become half, right? And this sin x square or x square, these two things will become 1, because this is also sin x square by x square will become 1. So e ki power minus 1, and this will become what? By 2, and this is the remaining thing, which is 3 ki power 2r. So this is what is pending. We can plug in the value over here. R will be 1 to n. ठीक है? This limit is gone. So L is what? Limit n tend to infinity, because I have removed the x. So this is no need of x tend to 0 now. N tend to infinity, then pi r is equals to 1 से लेके n. We have e की power minus 1 upon 2, 3 की power 2r. Now what you can do is you can open this pi, which is product. So L will be what? Limit n tend to infinity. Oh, expand this product. So r is equals to 1. So e की power minus half. r1 है तो क्या आएगा? 1 upon 3 square. Then e की power minus half. r2 है तो 1 upon 3 की power 4. e की power minus half. 1 upon 3 की power 6, and so on. You know what? Can you see that up to infinity? Can you see that the bases are same, the powers will get added. So e की power minus half, add each and every power. 1 by 3 square plus 1 by 3 की power 4 plus 1 by 3 की power 6. Up to when? Up to infinity. Infinite geometric progression, guys. Trust the process. Trust the process. Infinite geometric progression. So a upon 1 minus r. What is the value of a? 1 by 9. What is the value of common ratio? 1 by 9 again. So it is becoming 1 by 9 upon 8 by 9. 9 9 gone, 1 by 8. So it is becoming 1 by 8. So we are actually getting e की power minus 1 by 16 as the right answer. E की power minus 1 by 16. So the limit is e की power minus 1 by 16. So lambda is coming out as minus 1 by 16, option B. Yes? Yes? How many of you are there with me? Yes, the 1 raised to power infinity form. ठीक है? So we have done pretty much for this session. 0 by 0, infinity by infinity, 1 raised to power infinity. Now is the time to tackle these 3 remaining forms. So 0 multiply infinity. So suppose you have x into sine 1 by x, where limit x tend to infinity. This is what? 0 multiply infinity form. The moment you see this is 0 multiply infinity form. But you know what? I will do one single manipulation and the whole question will be all about 0 by 0 or infinity by infinity. This x, if I take down sine 1 by x upon 1 by x, can you now see? Sine 1 by infinity is 0 upon 0. Sine 0 by 0, 1, gone. That's how you do it. I am not telling you the questions, how to solve the question. That's not my agenda. I am just telling you how to simplify the 0 by 0 multiply infinity. So this was infinity into 0. Can you see that? Now this has become infinity by infinity. How smoothly I have changed the form, and now once it is infinity by infinity, you can solve it. Once it is 0 by 0, you can solve it, right? And the next is x raised to power x, limit x tend to 0. That is 0 by 0 form, right? One of these two, let us take. So whenever you see something raised to power something, na, take log both the sides. So log L is equals to limit x tend to 0 x log x. ठीक है ना? So log L is equal to, this is what? Now x log x. Can you see that? 0 multiply infinity form again. So now we know log x upon 1 by x, limit x tend to 0. Can you now see? So this is what? 0 multiply infinity form, and now this time infinity by infinity form. So now you can apply L'Hopital. Now you can apply L'Hopital. So log L is equals to 1 by x upon minus 1 by x square. So this will become minus x. The moment you plug in x is equals to this will become 0. So log L is coming out as 0. That means L will be equal to 1. The value of L will be equal to 1. Cool, clear, perfect, solve, done, dusted. Tell me. So limits we have finished, done. ठीक है? Now we will step into continuity and differentiability. Let's have a 2-minute water break. So let's meet at 10:33 p.m. Okay, 2-minute break only. Limits done. Yes, Ninja Ma'am is back. Ninja Ma'am is back. And let me just answer some of your questions before getting into continuity and differentiability again. Alright. So I can see chat box is something else is going on in chat box. What's going on in the chat box? I can't see any relevant messages in the chat box. Alright, let's just begin. Alright. So continuity. Continuity, you all know that for a function to be continuous at a point, a single point, so f of a is equals to f of a plus. That means value of function at that point, value of function at a point which is slightly greater than that point, and at a point which is slightly left at that point. All three values should be equal. So basically the right hand limit and the left hand limit should be equal to the value of the function. Right? Yes. So this is what the basics, fundamental of continuity is. Now let's so there is not much theory related to continuity. So we should be focusing on problems in continuity. Okay? So fx is given as this. Right, and we need to figure out whether my function f is continuous or not, f dash is differentiable or not, and so on all the way. Okay? Okay, so f of 0 clearly is 0. What about f of 0 plus? If I have to put a value which is slightly greater than 0, I have to put it over here. So this will become f of 0 plus will become h square sine 1 by h. H square sine 1 by h. So this is 0 multiply a finite value, because sine 1 by h lies between minus 1 and 1. So this will become 0 only, and same goes with 0 minus, because this will become h square and sine minus 1 by h. Again this is 0 multiply finite value, this will give me 0. That means my f so definitely is a continuous function. F is continuous. So basically option elimination is not working for me, because no option is getting eliminated. Every option is supporting only ki f is continuous. What about f dash? To check for f dash, you need to differentiate it. So f dash x function, let's calculate. So it will be 0 when your x is equal to 0. It will become, so x square sine 1 by x, so 2x sine 1 by x. Plus, I am applying the product rule of differentiation. So x square is differentiated, sine 1 by x kept as it is, and this time x square, and then this is cos 1 by x is here, and 1 by x is further differentiated, and it will become minus 1 by x square gone. So now this is when your function x is not equal to 0, right? Now tell me, what is your f dash 0? F dash 0 to 0 hai. What about your f dash 0 plus? So for 0 plus I have to check here. So the moment I put 0 plus, this will become 0 plus. What about this? This will become cos 1 by 0, which is an oscillatory value. Right? It is not a finite, it is a finite value lying between minus 1 to 1, but it is oscillating at 0 only. So f dash 0 plus is oscillating. Basically, what was happening, so you will ask me, okay ma'am, this was also oscillating. The moment you were plugging in 0, this was also oscillating. Yes. But what was happening, this x square is making the whole oscillating thing towards 0. That's why the whole thing became 0. But in this portion, what is happening, x square got cancelled. So only thing cos 1 by x is left. This has become oscillating, and there is no 0 multiplied by this oscillating value which can make this f dash x 0. That's why my differentiable function is, so f dash is definitely not continuous. So option A is right, because my f dash is not continuous, right? Because f dash 0 is not equal to, so basically the limit is not existing. If limit does not exist, then the function f dash is not discontinuous. Yes, all right. So this was all about continuity of this function. Very nice question actually. One more question from JEE Mains 2022 regarding the continuity. So if you know the limits very well now, then continuity would be a cakewalk for you. So the question says fx is this, ठीक है, fx is this and this function is continuous at x equal to 0. That simply means that your f of 0 should be equal to f dash 0 plus. Simple as that. My f of 0 is k and f dash 0 plus is nothing but your right hand limit or your left hand limit. So that means you need to calculate limit of your function at x tending to 0. This is your function log of 1 minus x plus x square plus log of 1 plus x square, right, whole upon sec x minus cos x can be written down as 1 by cos x minus cos x. Now you know that log a plus log b is log a into log b, log a into log b. These two, if we get multiply, if these two functions, if we get multiplied, so it will become what? X की power 4 plus x square plus 1 का log. Yes. So the numerator is this. What about the denominator? 1 minus cos square x and cos x limit x. So this is x tend to 0. Right. So 1 minus cos square x. 1 minus cos square x can be written down as 1 minus cos x 1 plus cos x, right? And this 1 log of 1 plus 0, we need the same 0 over here in the denominator. Use the standard limits. So it will become x square plus x की power 4. So log 1 plus 0 by same 0 is 1. So this whole circle is 1, but we need to multiply it over here, same thing over here as well. So this is becoming 0. 1 minus cos x will need an x square over here and an x square over here, so that this will become what? 1 by 2. So now I can write 1 by 2, that means 2 by 1, and this will become 1, and this x square is left out, so it will become x square plus x की power 4 by x square, right? And 1 plus cos x is what? 2 only. 2 cancel, so this is becoming what? 1 plus 0. So 1 is the answer of K. K is coming out as 1, option A. Yes, Pramod, absolutely right. What is an isolated point? Isolated point is so isolate. Maybe you are asking about the isolated point discontinuity. In that case, what happens is, so this is irrelevant from this, but still the topic of continuity. So suppose we have this and this. So basically only a single point is isolated. Isolated means separated. This is the case. Isolated point discontinuity. The point has been isolated from this curve and it is available somewhere else. ठीक है? ठीक है? Okay, alright, let's just move on to, so this was continuity. Let's talk about the differentiability. Differentiability. So this is not differentiation, differentiability. ठीक है? Okay. No, actually this is differentiation only. है ना? Differentiation. So differentiation, in method of differentiation, I already told you in the beginning, I won't spend much time in this, but then a few basic things. Chain rule, differentiation of implicit function, parametric differentiation, differentiation of function with respect to another function, logarithmic differentiation, higher order problem, and Newton-Leibniz formula. We will solve both nice previous year question from 2023 as well. ठीक है? Alright, so these are the standard derivatives which you need to remember. X की power n का derivative, e की power x का derivative, a की power x का derivative, you know, log of mod x का derivative, log of mod x to the base a का derivative, sin x का derivative. All these derivatives you must be aware about, right? So whenever you see co, you will see a negative sign. Whenever you see co, you will see a negative sign. ठीक है? So all these derivatives, I am assuming that lecture time maths का क्या है? Rudra is saying we started at 5 and we will continue up to 12, I guess. or more than 12:30. It will go up to 1 actually. So it will go up to 1 a.m. Yes. Okay. Yes, so these are the derivatives. Okay. Now chain rule. What is the chain rule? D by dx of f of g of x. So f dash of g of x. First of all, start differentiating from the outside. So f dash will be differentiated first, rest as it is, and then go towards the inside. Then g of x will be differentiated, g dash x. Then x will be differentiated, it will become 1. Right? So this is how what it is. Now what about this? Who will tell me the derivative of f of y? So now f is outside, so f dash y. Y is again differentiated, it will become dy by dx. Right? So always be careful with respect to what function are you differentiating. That was the whole point. Okay? Now derivative of sin y with respect to x would be what? Cos y dy by dx. Derivative of cos y square with respect to x is what? So cos ka derivative is minus sin y square. Y square ka derivative is 2y. And then y ka derivative is dy by dx. What about y cube? 3y square dy by dx. The whole point is always be careful. Always be careful that you differentiate with respect to the given variable. Keep that in mind. Okay, so this was all about it. And yes, so in method of differentiation, if I was a question paper creator, if I was told that ma'am you have to create a JEE Main 2024 question paper, so what I'll be choosing in method of differentiation, I'll be choosing 2 topics. The first one is this one, that is derivative of a function where one function is inverse of the other. That is one important topic. The second topic would be derivative of inverse trigonometric function. Okay? And you know what, I am not saying ki I have some favoritism towards this. Basically these 2 topics are the topmost topics of methods of differentiation. Okay? Let me just ask you a question. So a question, so I have a question, that question in my mobile phone. Okay, let me just write it. It is from JEE Main 2014. The question is from JEE Main 2014. Question says that if G is inverse of a function f and f dash x is 1 upon 1 plus x की power 5, you have to figure out the value of g dash x in terms of gx. It was an MCQ in your 2014, and you know what? This was an MCQ in 2014, and the same type came in JEE Advanced as well in 2016. So multiple times this concept has been touched by JEE, either mains or advanced. Okay? So let me just first give you a gist about, this is the question, but let me just give you the gist about the concept. Whenever we have to find derivative of g of x, where gx is the inverse of f of x, use this, always use this. Okay? So the question is asking me that g is inverse of a function f. That means g is equals to f inverse. Right? That means f of g of x is equals to x. Make use of it. F of g of x is equals to x. We will make use of it, right? And then differentiate. That's how we do it. That's how we approach a. So whenever a question is asking you, okay, one function is inverse of another and we need to find derivative of something. So always start from here, not from here. One step ahead and then differentiate. Now we will be differentiating it. So my f of g of x is what? X. Now differentiate. So f dash of g of x, g dash x is equals to 1. right? Okay, so f dash of g of x is 1 upon g dash x. What you are looking for is g dash x, right? Or rather, you can shift g dash x and you can write 1 upon f dash g of x. So this will give you the answer. Now what is your f dash x? Okay, f dash x is by the way given to you. F dash x is given to you. So what you can do is you can plug in g of x over here. So it will become 1 upon 1 plus g ki power 5. Yes, so now you can use the value. So 1 upon 1 plus g ki power 5 will give you 1 plus g ki power 5 as the final answer. So 1 plus g ki power 5. G dash x is coming out as what? Finally, 1 plus g of x ki power 5. Yes, yes, getting it, right? So only these things. Okay, I am just deleting this. This is unnecessary. Why? Because you are looking for g dash x. So this was given to you, right? It is given that g is inverse of f. So g is f inverse. So f of g of x is equals to x. Now differentiate both the sides. You will get f dash g of x into g dash x is equals to 1. You were looking for what? G dash x, right? You were looking for g dash x. So this is g dash x. It will stay here and remove f dash x. F dash g of x, where to get? It is given in the question. F dash x is given. Remove this g of x. Remove this g of x. So f dash g of x is 1 upon g 1 plus g ki power 5. So 1 upon g ki power 5 will give you 1 upon g ki power 5. So g dash x is coming out as 1 plus g ki power 5. ठीक है? All right. Perfect. ठीक है. Now differentiation of implicit function. Suppose you are given with x square minus 3xy plus y square is equal to 0 and you are looking for dy by dx. So one method of doing it is you just differentiate it. Simply differentiate. So 2x minus, now you have to apply the product rule. So 3x will remain as it is. This will become y dash minus 3y will remain as it is. X ka derivative will be 1 and then y square. So 2y y dash. Can you see these two quantities? So y dash is what? Y dash is what? So y dash will be 2x minus 3y upon 3x plus 2y with a negative sign. This is one way of doing it. Method 1. Directly differentiate, right, and collect the terms containing dy by dx, find the value of dy by dx. That's how we do it. But we have a shortcut to it. So the shortcut is very simple. Dy by dx, first of all, in the numerator, you will differentiate partially with respect to x with a negative sign. So minus of, very easy. Just differentiate keeping y constant. So 2x minus 3. Now y is constant. So x ka derivative would be 1. So minus 3y is constant. X ka derivative 1 upon. In the denominator, what you need to do is differentiate with respect to y. Keeping x constant. So x square ka derivative 0. This will be minus 3x. Why? Because x is constant. 3x. Y ka derivative 1. And plus y square. So you are differentiating with respect to y partially. So plus 2y. Right? Yeah, so that's it. So minus of 2x minus 3y. So here I have made a mistake. Minus 3. Minus 3x plus y. That's how you differentiate. This is the easier method. And you know what? I will be... so a student is asking parametric differentiation. Yes, we have got parametric differentiation over here. So suppose you have y is equals to sin t and x is equals to cos t and you are looking for dy by dx. So what you need to do is, so again, so f dash t upon g dash t. That's it. What is f dash t? So derivative, this is your ft. So cos t, simply, or cos ka derivative minus sin t. So this will become minus cot t. Simple parametric differentiation. Yes. Parametric differentiation, we differentiate it like this. Right? But if you want to double differentiate the parametric differentiation, if you're looking for d2y by dx square, then what you need to do is, so d2y by dx. What you need to do is, so you need to differentiate this again with respect to x. That's it. So differentiate. So d by dt with respect to, so first of all, so you have to differentiate with respect to t. And now this t will be differentiated with respect to x, and this dx by dt, you have already actually this dx by dt is nothing but what? Cos t ka derivative. So this you have already done. So dx, so minus 1 upon sin t. Right? Be careful about it. So if you wish to calculate d2y by dx square, that would be what? So dy by dx will be there. ठीक है? इसका double derivative with respect to dt and dt by dx will be there. Right? So dy by dx is what? Minus cot t. So this minus cot t will be differentiated with respect to t, and then t will be differentiated with respect to x, because last thing which you have to do is differentiate with respect to. ठीक है? Now differentiation of one function with respect to another function, very easy. If I ask you to differentiate sin x with respect to cos x, है ना? Differentiate sin x with respect to cos x. So what will you do? To differentiate sin x with respect to cos x, that's it. So this will become minus cot x. So what you need to do is, you just need to differentiate that, the next function, the other function in the denominator, and you are all set. That's how you do it. ठीक है ना? 62 marks, very close. It can be close to 99 percentile, but it will again depend upon what? Your shift as well. If your shift is extremely easy, then the cutoff can go a little higher. If your shift is really difficult, then 62 can give you 99 in maths. ठीक है? अब Newton-Leibniz formula. So you know what? I know कि it's already 11 o'clock and we don't have time for the stories, but to make you feel refreshed, I have a 30-second story. So basically, you must know that Newton is called as father of calculus. But you know what? In the beginning, when calculus was being written down by both the scientists Newton and Leibniz, both have done very nice work in calculus, in finding the calculus. So Newton was also writing a calculus, Leibniz was also writing the calculus. They were actually in touch in the letters. They were writing letters to each other. They were showing their work to each other. But then when the things got serious, they started publishing their work, they started showing their work. Then Newton and Leibniz got into a fight. So Newton claimed that this is my calculus. Leibniz says, no, I have written the whole calculus. So that they had some fight, and they have some serious issue in their university. And yeah, but then they have worked on the similar thing, which is Newton-Leibniz. So this formula basically is a very epic, legendary formula in the world of calculus, where these two are fighting for calculus is mine, and they both have worked towards calculus, and both scientists are like hats off to them. Okay, they have written the whole calculus which we are studying in the night. We are actually only studying in the night. They have written it. Okay. Chalo, so let's start with Newton's Leibniz formula. So Newton-Leibniz formula is very easy. I will actually write my own formula. So suppose we have a function f of t dt, integration of this function where upper limit is, so lower limit is gx, upper limit is hx, right? So if this is your function, and if you wish to differentiate this whole function with respect to x, right? If you wish to differentiate this whole function with respect to x, then what will you expect? What will you expect? So basically derivative and integration are anti of each other. The differentiation and integration are anti of each other. So you don't need to integrate it, you don't need to differentiate it, because both will cancel each other. All you have to follow is some steps. So f of t dt, so t will be replaced by the upper limit, it will become f of h of x, and this upper limit we will differentiate it minus. Now minus ke baad you have to put in the lower limit, so f of g of x, and this lower limit will get differentiated g of x, that's it. So now you know how to expand it, how to differentiate this particular integral. So f ke andar t will be replaced by t, wherever there is t, replaced by upper limit multiplied derivative of upper limit minus. Now t will be replaced by lower limit multiply derivative of the lower limit. Yes, Rudra Gamer is saying he understands this very well, very nice, very good. Okay, chalo. है ना? So the lecture is for you only to understand this. If you don't understand this, then nothing is like, everything is waste. But if you're able to understand it, everything is worth it. ठीक है? चलो. Phi x. Now this question from JEE Mains 2023 had Newton-Leibniz theorem का thing. So very easy question. If you know the Newton-Leibniz, you're going to kill it. So phi x is given as 1 by root x integral of this, and we need to figure out phi dash pi by 4. ठीक है? Phi dash pi by 4. So what we will do is we will apply Newton-Leibniz theorem, but this root x is not the part of this whole integration. So what we can do is we can shift this root x towards here. So root x phi x will be pi by 4 and x 4 root 2 sin t minus 3 phi dash t dt. Okay, now differentiate. You will understand, you will realize how good Newton-Leibniz theorem is and how easy it is to apply. Right? Root x phi x. Differentiate. Root x is constant. Derivative of phi is phi dash plus sign. Right? Now phi is as it is. I am applying the product rule. Right? Product rule. Root x constant, and this time phi constant. Root x ka derivative would be 1 by 2 root x is equal to, now I will be applying Newton-Leibniz theorem over here. How to do it? I am differentiating both the sides, right? So you just need to plug in x in place of t. So 4 root 2 sin x minus 3 phi dash x. So I have put x upper limit in place of t and differentiate x over here. I will get 1. Apply minus sign. Put pi by 4 over here and differentiate pi by 4. The moment you differentiate, you will get a 0. That's why I am not calculating this. Anyway, it will get multiplied with 0. Now what you need? What you need is, you need phi dash pi by 4. Put x equals to pi by 4. You will get everything. So this will root pi by 4. So root pi by 2. Phi dash pi by 4 plus. Now phi of pi by 4. Who is going to tell me the value of pi by 4? Who is going to tell me the value of phi pi by 4? So in here, if I plug in x is equals to pi by 4, the lower limit is pi by 4, the upper limit will also be pi by 4. So x, if I put x equals to pi by 4, phi of pi by 4 will become 0. Why? Because upper and lower limit both are pi by 4. It will vanish it. So this is becoming 0. This is equals to, now put x equal to what? Pi by 4. So 4 root 2 sin pi by 4 is 1 by root 2 minus 3 phi dash pi by 4. This will give you your answer. Now the question has become extremely easy, right? So just keep this over here. So root pi by 2 plus 3 phi dash pi by 4 is equals to 4. So 4 upon root pi. So 4 2s are 8. 8 upon 6 plus root pi is matching with option C. Who is with me? Who is with me? Who is with me? ठीक है. So this is a homework question again from Leibniz theorem. This is a homework question, right? Again, very easy question. You just have to differentiate at both the sides and one step, put the value of t and you will get your answer. Yes, yes Harsh. Yes Harsh, we will do the conic section as well. Do not worry about that. So we are done with this. Yes. Now we are at application of derivatives. Let's just tap application of derivative. So continuity and differentiability done nicely along with Newton-Leibniz theorem. So we'll start application of derivatives. So the two topics which are very important, very critical in application of derivatives is increasing and decreasing function and maxima and minima. ठीक है? Increasing, decreasing and maxima and minima. ठीक है? Now basically there are two terms involved in increasing and decreasing function. First is strictly increasing and the second is only increasing, or you can call it as a non-decreasing as well. So how does a strictly increasing function look like? Strictly increasing function look like this. ठीक है? What about increasing function? So increasing function can look like this. Right? This is a non-decreasing function. So basically for increasing function, what do we say? We say that each and every moment when my x is increasing, my function will also get increased. So where x2 is greater than x1, f of x2 should always be greater than f of x1, right? That means if my x is increasing, my function is also increasing. This is strictly increasing. But what about only increasing, or you can say non-decreasing? In this case, my f1, my values can become a little bit equal. So basically the function is increasing. So this part is strictly increasing, but this portion you can see that it has become constant. The value is not increasing, but at least it is not decreasing. Can you see the values are not decreasing? The value has become constant and then it start increasing. So if you get this particular situation as well, so we will call it as a non-decreasing function. Okay? So this is what is the definition of increasing and decreasing. So this is the definition of increasing and decreasing. But if you really want to apply the concept of increasing and decreasing in your examination, so this is a test which you have to perform, or you can call it as a condition which you have to perform. Okay? So if your f dash is greater than or equal to 0, then your function is strictly increasing. Okay? So now you will ask me, ma'am, greater than or equal to 0. So basically equal to 0 should only be exactly where when your function is at some point. So suppose you have this. So can you see that at this point the function has become horizontal? The tangent over here will be horizontal and f dash x is equal to 0 at this point, only at a single point. So this function is still counted as a strictly increasing. But if your function is going like this, right, can you see that in this whole region my f dash x is becoming 0 for an interval? If it is becoming 0 for an interval, if it is becoming 0 for an interval, what does that mean? Basically if it is forming an interval, then it is not strictly increasing. So the point is, the point where which f dash x is equals to 0 should not form an interval. So it is forming an interval, that means it is not strictly increasing. This is becoming 0 at a point, this is increasing, right? So increasing and decreasing, and same goes the different thing as decreasing. So for decreasing the sign will get reversed, right? So this will become less than sign, this will become less than sign, and here derivative also becomes less than. Okay? Alright, let's talk about the critical points. So critical points are those points basically. Let's talk about maxima and minima. Increasing, decreasing we will apply in the question. We will solve a question for that. But what about maxima and minima? For maxima and minima, for maxima and minima, so you have to understand the critical points, because maxima and minima occurs at some point. So suppose this, so this is your local minima and this is your local maxima, right? X is equals to A, X is equals to B, let's say. Okay? So you are looking for the doubtful points of maxima and minima. To look for doubtful points of maxima and minima, you need to figure out f dash x. Whenever your f dash x is becoming 0 or your f dash x is failing to exist or fails to exist. So basically either it is 0 or it is giving me some random value, maybe it is giving me infinity. So 0 or not defined or infinity. So basically all those points are critical points, and you know what, once you get those critical points are those doubtful points where it can become maxima and minima. So basically critical points are contenders, they are competing. Okay, I am maxima, I am minima, I can be the maxima. So the moment you figure out all the critical points, out of these critical points you can check for the maxima and minimum values. Okay, alright. So you all know that maxima or minima kaise hota hai. Suppose we have this situation. So in this case this case, at this point my f dash x is becoming 0, right? F dash x is becoming 0. I am able to draw the horizontal tangent. So at this point my x is equals to A is become contender of either maxima or minima. How to check now? How to confirm whether it is a maxima or minima? So first derivative test, if your f dash x is negative and then it is becoming 0 and then f dash x is becoming positive, that means your f dash x is becoming 0 here and then positive here and negative here, then clearly it is a case of minima. Okay? But if your f dash x is becoming positive first and then negative, that means increasing and then decreasing, can you see this is a maxima? So if it is changing sign from positive to negative, then you can expect a maxima. From negative to positive, it expects a minima. But there are some times that basically my f dash x does not change its sign. My f dash x is not changing the sign. Right? What does that mean? It is 0, here it is plus, here this is plus. So basically at that point function cannot have maxima or minima. Right? Because this is again increasing, it is becoming 0, it is increasing. So if it is not changing its sign, so no maxima, no minima, rejected. Okay? What about double derivative test? Right? So this was my single derivative test, but वैसे तो there is no need of double derivative test, but in case if you are getting stuck, so you should know the second option as well, double derivative test. So if f dash as x is becoming 0, then what you can do is you can double differentiate, and if it is becoming positive, it has minima. Positive means minima, and it is becoming negative, it means it is maxima. But if your double derivative also becomes 0, that means your test has been failed. That means this test has been failed. Doesn't mean that you don't have a minima or maxima. This test is having some limitation. It happens now when we go to the doctor. He says, okay, I need to check you for some flu or from viral. For viral I need to check, but I don't have the enough equipments. So the system is fucked up. The system is not great basically. Okay. So so the system is not that great. That's why they are not able to test it. Doesn't mean that you have flu or you don't have flu. They cannot determine about your flu. Okay? So basically if double derivative test the double derivative becomes also 0 now. The test is failing. Test fails, right? You are not failing. Test is failing. It still can become maxima or minima. Okay? Okay? Let's solve a question. Let's solve a question now. Okay? So the question says the absolute maximum value of this function in the interval. Acha. So this function is given to us and we need to figure out absolute maximum value. Let me just tell you about the absolute maximum. Absolute maximum means overall maximum value. Okay? So overall maximum value, when can we get? So overall maximum value we can get at the value of local maximum. So what can happen is a local maxima in such case. So this is local maxima. And in this situation, this is becoming absolute maximum as well. That means overall maximum value is this only. But what about this? In this case, what are the contenders? So, okay, let me just ऐसे कर दो. हाँ. What is the absolute maximum value? So this is the absolute maximum value. ठीक है? I can see it. This is the absolute maximum value. What are the contenders? Like what are points you can check? So this also could be maximum, but it is not. I can see it. So basically what you need to do is, for absolute maximum or absolute minimum, you need to check for the critical points, right? And the end points. For absolute maximum, you need to check the end points. Okay? Clear? Chalo. So this is the question, absolute maximum. So for absolute maximum, I will check for the critical points and the end points as well. First of all, let me just determine the nature of this function. So if I have this fx is equals to this, okay? So let me just write it as f1x. Let us mark this as f1x. This is f2x. So f1x, f dash, so this is 2x minus 2 and f2x ka dash. This is what? 4 3 is 12x square minus 24x minus 180. Okay? So basically f1 dash x is 2x minus 2, which is a straight line by the way. And you know what? Minus 3 to 0 in this particular interval, the moment I plug in minus 3, it will become negative. The moment I plug in 0, it will become negative. So this is less than 0 for the given interval. For the given interval, it is less than 0. What about this? If you plug in minus 3 and 0 also now, so this is also less than 0 for this given interval. That means your both f1 and f2 both are decreasing function. What does that mean? That means your f dash x is a decreasing function. Decreasing function. So decreasing function, how does a decreasing function behave? Tell me. Decreasing function, that means decreasing continuously. Continuously decreasing. So the absolute maximum value of decreasing function will be having at the first point, the very first point, and the very first point is minus 3. So at minus 3 you will be getting the absolute maximum. So alpha, the value of alpha is what? Minus 3, option B. Yes or no? So this is your application of derivatives. ठीक है? Then there is one more question from application of derivatives. ठीक है? And the question is that your gx is fx plus f of 1 minus x, and your f double dash x is greater than 0. G is a decreasing function in this interval and increasing function in this interval. We need to figure out this value. Okay? Now gx is given as fx plus f of 1 minus x. Okay? So let's just differentiate it. G dash x will be nothing but what? F dash x plus f dash 1 minus x, so minus f dash 1 minus x. Right? Okay. Or rather what we can do is, before differentiating, let's tackle this in this way. Let's just replace x by 1 minus x. The moment you do that, you will get g of 1 minus x is equals to f of 1 minus x plus f of x. Can you see g of x and g of 1 minus x both are having same right hand side? That means g of x is equals to g of 1 minus x. The moment I see this statement, I can generalize this statement for any function. So let me just not write it x. Let me just write it for h. For any function h, if you see h of x is equals to h of 2a minus x. If you see the statement now, what does that mean? That this implies that my function hx is symmetric about what? X equal to 2a. My function is symmetric about x is equals to, a. ठीक है, x is equals to a. My function is symmetric about x is equals to a. Right? So the moment I see that my function is symmetric about x is equals to 1 by 2. So this function is symmetric about x is equals to half. Right? The moment you put the values, you will realize. You put half, you will get half. So g of half is equals to g of half. You put 0.1, you realize that you will get what? 0.9. So 0.1 and 0.9 are equal. That means it is becoming symmetric about half. G of 0 is g of 1. Right? So if you start plotting the graph, you will realize that half is equals to half. X is equals to half, so half is equals to half is the center point. Now if you put 0.4, you will get what? 0.6. So 0.4 and 0.6 value are equal. 0.3, 0.7 are equal, right? Then 0 value and 1 value are equal. So this is half, this is... So basically it is symmetric about x is equals to half. That's what we are getting. So now the question is, gx is decreasing in 0 to a. That means it is decreasing in 0 to 1 by 2 and increasing in half to 1. That's how it is. So basically this alpha, or you can call it as a, yes, this alpha is nothing but half. If alpha is coming out as half, what does that mean? So this is becoming tan inverse 2 into half 1 plus tan inverse 1 upon 1 by 2 tan inverse 2 plus tan inverse. So half plus 1 by half 3. 1 plus 2 plus 3, this will becoming pi. This is becoming pi. Option B is absolutely right. Yes, application of derivatives. This was the last question. Okay. Let's move on to the integration now. Okay, let's just move on to the integration. And you know what? We'll take 5 minutes break. Indefinite integration, it will take some time to finish it off. Right? Indefinite integration, definite integration, and application of integration. 3 topics. It will take another half an hour for me to solve this. And then we will move towards conic section finally. So we'll start conic section around 12 o'clock. And now we'll try to finish it off around 1 or 1:30. Okay. So let's just meet at 11:30. Let's just have a 5-minute break. Okay. Okay, I am back, come back. Come back. Okay, ठीक है. So integration will be starting. Standard integrals, integration by substitution, ठीक है. Integration of various algebraic forms, integration by partial fraction, by parts trigonometric format. So basically everything we will study, everything, like, so basically integration is all about remembering the format. If you see this, do this. If you see this, go with this method, right? So it's so much. Integration is a huge chapter, but again it is a bit difficult because it is a huge chapter and it has so many formats. But if you know that, okay, this is the format, I have to put this as t, this is the format, I have to do the partial fraction and then plug in as t. So that's how we do it. Okay, ठीक है, चले. Let's just start with some standard integrals. X raised to power n. So x raised to power n, you know the integration x raised to power n plus 1 upon n plus 1. So I am not getting into these details. 1 by x का integration log x. E raised to power x का integration e की power x. A raised to power x का integration a की power x by log a. Sin x का integration minus cos x का integration sin x. Sec square का tan x, cos x square का, whenever you see cos there is minus sign. ठीक है. So tan x का integration minus log of cos x, cot x का integration log of sin x, sec x का integration log of sec x plus tan x, or it can be written down as minus of log of sec x minus tan x. Okay, because these two form a reciprocal relationship. Same goes with this. This will be minus log of cosec x plus cot x, right? And this is sec x tan x का integration would be sec x. All these integration you should remember. ठीक है, right? So 1 upon square root a square minus a square is what? Sin inverse x by a. Then we have this 1 upon a square plus x square, it 1 by a tan inverse x by a. Then we have 1 upon x upon square root x square minus a square. So this integration is this only. ठीक है. And you know what this? So dx upon, so this integration you should remember. This integration, if you don't want to, don't remember, because the moment you take minus sign, this will become this only. So this is very important. Dx upon a square minus x square is 1 by 2a log a plus x, a minus x. Such a one thing. Students usually make this mistake. So whenever you see 1 upon square root a square minus x square, now there is no 1 by a over here. Can you see? There is no 1 by a. But in tan inverse we have 1 by a. Everything we have 1 by a. But in here we don't have 1 by a. Please do remember, there is no 1 by a in sin inverse formula. ठीक है? There is no 1 by a in sin inverse formula. ठीक है? Same goes with this. So these are the formulas. 1 upon square root x square plus a square is log of x plus square root x square plus a square. And whenever it is minus, then same log of x plus, same thing, copy paste. This is copy paste. Can you see this again? So this is now these three are different formula. You should remember all these formulas. ठीक है? All right. I am not giving the time of explaining this. ठीक है? All right. Now integration by substitution. If you have this fx, integral of fx dx is capital F of x, then integral of f of ax plus b dx is nothing but f of ax plus b plus constant c upon a. This is integration by substitution. ठीक है? Have a look. ठीक है? So this is integration by substitution. There are few very classic cases of substitution, some special cases of substitution. So basically, if you see f dash upon fx, now put fx is equals to t. The moment you take fx is equals to t, differentiated both the sides, you will get f dash x dx is equals to dt. Now you have to integrate 1 by t with respect to t. It will become log of t. T is here is f of x. So this is how it is. In here take f dash x is equals to t, so that, so this is power n. F dash x is equals to t, so that now differentiating both the sides, so f double dash x dx will become dt. So these two things will become dt, right? So t ki power n dt is what? T ki power n plus 1 upon n plus 1. T is what? F dash. So f dash basically upon this. Okay. And again same fx, take fx is equals to t. So f dash x dx will become dt. So integral of 1 by root t dt, you can easily, so this is 2t plus c, and t is nothing but your f of x. Yes. So these are the few integrals which you need to remember. Clear? Perfect. Now, the moment you see, quickly, one by one, take 5 seconds, one by one, we will quickly just go through it. Whenever you see quadratic in denominator or square root of quadratic, just complete the perfect square. So either 1 by quadratic or 1 by root quadratic, just complete the perfect square. Okay. Whenever you see linear by quadratic or linear by root quadratic, express derivative of this quadratic in the numerator. I'll show you how. So if you have 2x plus 2 upon x square plus x plus 1, okay. So what you need to do is take x square plus x plus 1 as t. So it will become 2x plus 1 dx is equals to dt. So you just need to express it like this. So 2x plus 1 and plus 1. Alag alag kar lo. This is x square plus x plus 1. This you have already taken as t. This will become with dx as dt. You will solve it and this will become 1 upon quadratic. Now 1 upon quadratic can be solved by form number 1 by completing the perfect square, applying the formula. Right? Yes, so that's how you do it. Format number 1, format number 2. And now at this time, if the degree of numerator is greater than degree of denominator, just simply divide by long division method. And after you divide by long division algorithm, then you will either fall into format number 1 or format number 2. Okay? Alright? Yes, so whenever degree of numerator is greater, we always use the division algorithm. Just properly divide, which we have studied in our polynomial division. Okay? And then this. Okay. So now if you see this x square plus 1 or x square minus 1 upon x to the power 4 plus x square plus 1 integral dx. Okay? Alright. So the moment you see positive sign, for positive sign, what you need to do is put x minus 1 by x is equals to t. If you see x square plus 1, no? So put minus is equals to c. And if you see x square minus 1, then put x plus 1 by x is equals to c. Yes, the reverse strategy. Okay? है ना? So for this x plus 1 by x, so for that you have to take out x common. So suppose we are talking about the positive sign, x square common. So 1 minus 1 plus 1 by x square and x square common. So x square plus 1 by x square plus 1 integral dx. Now you have positive sign. So I already told you, if you have positive sign, take x minus 1 by x is equals to t. So yes, the moment you differentiate it, it will become 1 plus 1 by x square dx is equals to dt. Now you know why you have taken minus sign as t, why you have put x minus 1 by x as t, because the moment you differentiate, it will become plus 1. Right? So 1 plus 1 by x square dx. So this is what? Dt. And what about this x square plus 1 by x square? So for that, square both the sides. X square plus 1 by x square plus 2 is equals to t square. So basically this will become t square by 2 minus 1. T square minus 2 plus 1. Yes, so this is it. So dt upon t square plus 1. Do I need to tell you the integration? Tan inverse t, where t is what? X minus 1 by x plus c. That's how you go about it. Yes? Yes? I guess integration done. Okay, let's now talk about the by parts formula. So by parts formula, so whenever you have two functions involved and you have to figure out the integration of this, so you have to take first and second function. You have to identify function who is function number 1 and who is function number 2, right? So first function and second function का integral is integral of, okay, so the formula, let me just show you the formula. So first function we have to keep it constant, integral of second function minus integral of derivative of first function and integral of second function. ठीक है? ठीक है? So in the formula itself you can clearly see that in knowing integration of second function is very important. You should know integration of second function. If you don't know, you can't apply this formula. So that's why on the basis of that you have Eilert rule, wherein inverse function should be on the first, should always be the first function. Why? Because you don't know the integration of sine inverse x, right? So whenever you wish to integrate sine inverse x, na, let's integrate sine inverse x. You don't know the value. Let's integrate log x, right? So you take this as first function and 1 as the second function. Always. This should be first function, this should be second function. So Eilert. So inverse function has been always given the priority of being at first function, then logarithm, then algebra, then trigonometry, then exponential. Okay? That's how it is. Or in some cases you can purely go on your intuition basis. Okay, I need the integration of this particular function, so I can solve it this way as well. Okay? So suppose I have this question for you from April 2023, which says integration of e की power sin x square, and this is given to you I of pi by 3. Basically you have to figure out the value of I of x. Okay? So I of x is, let me just write it down. I of x is integral of e की power sin square x cos x sin 2x minus, okay, dx. Let me just multiply this, minus integral of e की power sin square x sin x dx. ठीक है? I of x sin square x cos x sin 2x dx. ठीक है? So I of x is equal to what? Now you know what, you can just actually rewrite it, e की power sin square x 2 sin x cos x and cos x dx minus of this something. Okay, minus of this something. Let me just leave the second part. Let me just focus on the first part. Now you know what, the moment I plug in, just take e की power sin square x and 2 sin x cos x. Let's keep this as a different function. So integral of this, if you want to figure out, put this as t. So the moment you put this as t, differentiate sin square both the sides, 2 sin x cos x will become dt along with dx. So it will become integral of e की power t dt. That will give me e की power t, that means e की power sin square x. Right? So what did I do? Understand, realize. I actually, so this is a huge expression, but I know the integration of this. E की power sin square x 2 sin x cos x. I know the whole integration. How? Because the moment I put this as t, this became dt, and the integration is, so the whole, this should be my second function, because I know the integration of this chunk, and this should be my first function. Now let me just apply the by parts. So I of x would be what? First function ko constant, so cos x is as it is. Second ka integration we have already figured out. Second ka integration is e की power sin square x minus integral of derivative of first function. So cos x ka derivative is plus sin x, and integration of second, the whole chunk, is e की power sin square x dx minus of the same quantity which is given to us, e की power sin square x sin x dx. Can you just see this, that these two expressions have beautifully got cancelled out and we are left with our I of x, which is this. Obviously there is plus some constant c, which we will figure out by this initial condition. The moment you put x equals to 0, you will get 1. Put x equals to 0. The moment you do that, so 1 is equals to, x is equals to 0 will be 1 plus c. So c is coming out as 0. Okay? C is anyway coming out as 0. Now plug in pi by 3. So cos pi by 3, that is 60 degrees, half. And this would be e की power root 3 by 2 का square. So e की power 3 by 4. Half e की power 3 by 4. Option D entered and we have got the answer. Yes, what's going on in the chat box? The chat box is like from the different planet itself. It is not happening on the Earth. It is happening in the Pluto. Pluto is also not in the counted in the planets, right? So the chat box is from the different world. I thought I have opened some another YouTube video and the chats are running. Kundan is saying, ma'am, one question. Question also we were doing. Question only we were doing. Now this is the classic integral which you should remember. So wherever you see e की power x, fx plus f dash x. Right? Whenever you see e raised to power x, fx plus f dash x, you don't need to integrate it. We have done that for you as well. You just need to identify this. Once you have identified, just directly write e की power x, f of x. Suppose you have e की power x log x plus 1 by x. This is written. This integral you need to find. What you will do? Okay, ma'am. E raised to power x. This is your fx. This is your f dash x. So final answer would be e की power x log x plus c. That's it. Right? So the whole sole thing, the whole sole USP of this particular formula is that you have to identify the form. Because out of the blue, if I give you this question, there will be very few students who will be actually applying this formula. What some people will do is they try to integrate it by using by parts or some other things, right? So you are going to do that. Don't do that. Just figure out, okay, this is that classic integral whose ready-made answer is available to us. Okay? Right? Okay. Now trigonometry, some formats basically, some format. So if you have these type of format where let's say sine raised to power 4x and cos raised to power 5x is given to you and you have to integrate it. So you know what, at this moment, whichever is the odd power, no, don't put that one as t. Rather, put sine x is equals to t. Leave that odd power. Leave that odd power function. है ना? Whatever there is besides the odd power, put that as t. Moment I put sine x is equals to t, it will become cos x dx will be equal to dt, right? So now, how to integrate it? So t की power 4 is already there. Cos raised to power 4 would be what? 1 minus t square raised to power 4. How do we do it? How did I do that? Okay. So let me just write it down nicely so that you understand this. So this is what sine की power 4x. Then we have cos square का square. And then we have cos x dx. Can I write it this way? Yes. So this is what t की power 4. And this is 1 minus t square का square. And this is nothing but dt. Now can you not integrate it? Who is going to leave this question? So this is what t की power 4 minus 2t square plus 1 dt. ठीक है? So just multiply it and integrate it. Okay? So that's how you go about these kind of formats. Now what about this format? Whenever you see the function of linear of sin x is available, or only cos x is there, or a function of sin x and cos x, whenever you see it, just put tan x by 2 is equals to t. है ना? And you know what? Convert the sine and cos with the help of this formula. 2 tan x by 2, 1 plus tan square, and 2 1 minus tan square x upon 1 plus tan square x by 2. Right? So this is your sine x, 2 tan x by 2 upon 1 plus tan square x by 2. I already gave you this formula in trigonometry. Cos x can be converted into tan x by 2 using this formula. So these two formulas you remember and put tan x by 2 is equals to t. Automatically in the numerator you will get sec square x by 2 dx. So that will become dt. Right? Because see now 1 plus tan square x by 2 is sec square x by 2. So automatically you will get this. Okay? Alright, next format, whenever you see, this, the function of cos and sine in numerator and denominator, okay, or if you have any constant as well, what you need to do is express the numerator like this. So some constant times denominator plus some other constant derivative of denominator. Yes. So suppose I have 3 cos x plus 4 sin x, and I have 4 cos x minus 3 sin x. Okay? So what I need to do is, I need to write this numerator, which is 4 cos x minus 3 sin x is equals to a times 3 cos x plus 4 sin x plus b times derivative of this, which is minus 3 sin x and plus 4 cos x, right? Now just try to collect the coefficients, get the value of a and b, and this numerator will become what? Numerator will become a times denominator plus b times derivative of the denominator upon denominator to denominator. Hey, separate it out, a times denominator by denominator. So a dx का integration, this is a constant का integration, plus b times denominator का derivative upon denominator. So if you take denominator as t, it will become denominator ka derivative will become dt. So again this is again integrable form, right? So you know what? Everything will fall in place. If you study integration, everything is going to fall in place. You just have to remember ki acha, the moment I get sin x cos x ka function upon sin x cos x ka function, express numerator as a times denominator plus b times derivative of denominator. Okay? Now we have another form in which we have what? We have squared quantities in the denominator. We have squared quantities in the denominator. So basically for that what we can do is, we can divide the numerator and denominator both by cos square x and put tan x is equals to t. That's it. Okay? Right? Perfect. This is format number 4. Okay, let's just move ahead. Yeah, so this was all about indefinite integration. Let's talk about definite integration. Now you know what, indefinite integration will give you only like one question can appear in your shift, but from definite integration I would say that 2 questions in each and every shift will be there majority of the time. Right, there are high chances that you will get 2 questions from definite integration. Yes, so we are left with definite integration, and then we are left with area under curve as well. Okay, so definite integration, area under curve, both are left. Let's just dive into it. Okay, so properties of definite integration, then we will figure out okay, so this though is removed from the syllabus, we are not studying it. So we have properties and Wallis formulas. These two are important things. Let's just understand this. So first property is First property tells us that, okay, if you have to integrate a to b fx, then this x does not matter at all. Right? X, t, y, you can absolutely replace the variable in case of definite integration. Okay? Another thing is, if you wish to flip the limits a and b, so a to b, here you can see b to a. If you wish to flip the limits, minus sign will be there in the picture. Third thing, if you wish to break the limits, if you are like integrating something from 1 to 3, then what you can do is break the limit 1 to 2 and then 2 to 3. So you can break the limit in between. So 1 to 2, 2 to 3. Eventually you will go to from 1 to 3 only. So these are the three basic properties related to definite integration. Now we have King's property, which says that if you have this a and 0 as the upper and lower limit, so what you can do is you can replace this x by 0 plus a minus x, and here you can replace by a and b, so x would be replaced by a plus b minus x. ठीक है ना? So this is what is King's property, which is very important in your upcoming JEE Mains 2024. And now what about this? If this is your fx minus a to a, okay? Fx minus a to a. Now if your function is odd means like this. If your function is odd, then minus a to a, if you integrate, then this will become negative and this will become positive. Overall, if you add, this will become 0 if your function is odd. But if your function is even, just like this, so basically minus a to a, so both will get add up. These two will be identical, both will be positive, both will be adding. So twice of 0 to a. Can you see? Double of this will be the answer. Okay, so this is your property number 5. What about the property number 6? If you have to integrate something from 0 to 2a, right? And you know what? So 0 to 2a. So this will become 0 if your f of 2a minus x is equals to minus of f of x. So what you can do is you can apply the King's property to prove it. I will show you. So King's property, if you apply, it will become 2a minus x dx is equals to, so 0 to 2. This is your I, this is also your I. If you add these two things, you will realize that my fx and f of 2a minus x are actually what? Opposite signs. So these two will get cancelled out, you will get a 0. But if you realize, no, these two are exactly equal to each other. So the moment you add these two, right? Moment you add these two now, so it will get actually added. So twice of 0 to a f of x dx if your f of 2a minus x is equals to f of x. This is the property. Yes? Okay. So this is the question. Shall we do this question? Okay, let's do this, because this property, King's property, is very important. Consider the graph of f of mod x. So I remember the graph. So it is given in the question, by the way. I couldn't plot it in the PPT, so I am giving you right away. This is the part of the question only. Okay. So this is minus 1, this is plus 1, this is your fx. Right, and the question is asking you to calculate integral of 0 to 2. That means the positive side. X is always positive. Right? X is always positive. So you just need to remember. You just need to write the f of x for this value. So can you see this is a straight line? जिसके पास 1, 0 and 0, minus 1 are 2 points. 1, 0 and 0, minus 1. ठीक है? So fx you can write it down as y minus 0 is equals to x minus 1, and this will become minus 1 minus 0 and 0 minus 1. So this will become 1. Okay? So y is equals to x minus 1 is your function. Okay? Your function is what? X minus 1. What you can do is you can just put the value x minus 1 की power 2019 upon 1 plus x minus 1 की power 2018 plus x minus 1 की power 2020. Integral and dx is also here. Now what you need to do is you need to apply King's property in here. So this is your I. Please apply King's property. What is King's property? 2 plus 0 minus x. So x will be replaced by what? 2 minus x. X will be replaced by 2 minus x, right? So just replace this x by 2 minus x. So 2 minus x minus 1, it will become 1 minus x की power 2019. What about the denominator? So 1 plus 2 minus x. So this will become 1 minus x की power 2018. You know what? 1 minus x की power even is same as x minus 1 की power even. So you know what? This will not get affected. This will be same. Plus this is also even. This will also be same. Add these two i's. So the moment you add 2i will be equal to what? So denominator is same. But what about the numerator? So denominators are same. But if you add the numerator, it will be x minus 1 की power 2019. And this will become minus sign take common. So minus x minus 1 की power 2019. Can you see this? Both are getting cancelled out. And option D 0 is getting correct. Option D is absolutely correct. ठीक है? There are some actually. So this remark I would like to tell you. So whenever you actually see this type of question, whenever there is an algebra and trigonometry is involved, always apply King's property. Always apply King's property. When algebra and trigonometry is involved, always apply King's property. The moment you apply King's property, algebra will be gone. I will show you how. So just apply it. So x will be replaced by pi minus x. So this is pi minus x. Sine of pi minus x is sin x. 1 plus cos square x integral dx. If you add these two quantities, what do you get? 2i will be equal to, now you can see x sin x minus x sin x, both will get cancelled out. You are left with pi sin x upon 1 plus cos square x dx. Now you can take sin x is equals to t. Sorry, cos x is equals to t. So cos x is t. So minus sin x dx will become dt. So this will become what? Minus pi dt upon 1 plus t square का integral. So this will become minus pi tan inverse t, where t is what? Cos t. And cos x, sorry. And you can apply the limit as well. ये by 2, you can apply the limit 0 से लेके pi. So it will become what? Minus 2. 2 cancel. So pi. Okay. So tan inverse, so minus pi by 2. ठीक है? And why 2? Because I is coming out as, because 2i was there, no? So I is minus pi by 2. Moment, so tan inverse minus 1. Tan inverse minus 1 is minus pi by 4. And you know what? 0. Tan inverse 1 is pi by 4. So yeah, this will be your answer. ठीक है? This will be your answer. So whenever you see, the whole point was not about the solving the question. Whenever you see algebra and trigonometry, apply King's property and then proceed. Once you get rid of this x algebra, na, then you can just proceed with the normal trigonometric functions and definite integration properties, right? Now we do have some properties related to periodicity as well in indefinite integration. What are those properties? So 0 से लेके nt. जीरो से लेके nt. ठीक है, from 0 to nt. Now if a function, if you are integrating any function, suppose you have 0 से 100 pi and you have mod of sin x. You know what? Mod of sin x. How does mod of sin x look like? Mod of sin x look like this. The period of mod of sin x is what? Pi. ठीक है, right? And yes, So you are integrating 0 to pi, pi to 2 pi, pi, right? You are integrating up to 100 pi. So pi is the period. So what you can do is you can just remove this 100 from here, apply it here. So what you need to do is 100 0 se pi sin x dx. And this, if you integrate it, you will realize this is nothing but coming out as 2. So this is 200. This integral is what? Minus sine ka integration cos x. Cos pi minus cos 0. So it will become 2 into 100. So it is becoming what? 200. So that's how it is. Okay, this is the property. N will come in front if t is the period of the function. Now this is from starting from a to a plus nt. A will get cancelled out and nt will be left out. Right? So again, a cancel out, nt will be left out. Same thing. So this is coming same. Same as first. Right? Okay. Now, alright. So we have this as an observation. So mt to nt. Right? mt to nt. So it will be nothing but n minus m 0 to t. N minus m 0 to t. Right? fx dx. Okay. This is the next property. And in here, can you see nt and nt is here. So nt will get cancelled out. It is simply b integration from a to b. Yes, a to b. Clear? So these are the properties related to your definite integration. Now let's talk about Wallis formula. Let's talk about Wallis formula. Okay? So Wallis formula mein you have got sin ki power m cos ki power n dx and you are integrating 0 to pi by 2. Remember 0 to pi by 2 where m and n both should be integers. Right? So whenever you see that m and n both are even numbers, suppose we have sin ki power 6x and cos ki power 4x. In this case, can you see both are even? So when both are even, you have to put p as pi by 2. So you have to write final answer as pi by 2 multiply. Now, how do we write an answer? Let me just teach you, let me just make you understand this. So 6 and 4 are here. So write down a number which is less than 6, that would be 5. And then reduce the number in the in the gap of 2. So 5 is here, so 3 will be here and then 1 will be here. Right? So reduce the number less than 4, so less than 4 which is 3 and go up to 1 only. Right? So numerator will be having 5, 3, 1 and in here 3 and 1 only, that's it. What about the denominator? In denominator add these two numbers, that will be 10. Starting from 10 reduce to 2. Right? So it will become 8, 6 and then 4 and then 2. Then it will become 0, we don't need to write it. So this is the whole sole answer of the Wallis formula. That's why we apply. That's how we apply Wallis formula. Alright? Yes? That's how we apply the Wallis formula. Okay? This is the Wallis formula. Let me just, okay. Application of integration. So last topic of calculus we are having area under curve, or you can call it application of integration. I can see hashtag Ninja Ma'am in the chat box. Kya baat hai? Everybody is awake, I guess. Yes, nobody is gonna sleep. Okay, application of integration. So how many chapters are completed? Tell me. So we have completed quadratic, complex, sequence, PNC, binomial, matrices and determinant. Calculus mein we started with sets, relations, functions, limits, continuity, differentiability, methods of differentiation, and then application of derivatives, then indefinite integration, definite integration, and here we are, area under curve is going on. Area under curve is going on. Right? After area under curve, we will start with straight lines, circles, ellipse, parabola, hyperbola. Then we have statistic. Okay, we have vector, 3D. We have vector, we have 3D, we have statistics and probability. Actually a lot is been pending, right? Vector 3D is pending, and statistics and probability is also pending. So what do you think? Are we going to complete that today? Will we be able to complete that today, or shall I need another session for this? What do you think? Shall I complete in this session only? Yeah, I'm okay. I'm absolutely fine, but I'm worried that how will I be able to complete it today? I can complete it today, but will you be awake? It will take more time. Like we will have to be awake by 2 o'clock maybe, or shall I push it to another session? Shall I keep it to this as a part 1? Do it in another session? Yes. Shall I do it in another session? Harsh is saying within this session. I'm worried that will you be able to sit this longer? 2 o'clock. Harish is saying okay. Okay. Music box is saying we will stay, ma'am. Next session or now? Okay, let's just decide this later on. Okay? Okay, let's do one thing. Let's keep conic section. Let's keep the conic section for the next session. Let's finish area under curve, vector 3D, statistics and probability. Okay? Let's do one thing. Let's keep that conic section as a next session, and let's finish it off the vector area under curve, vector algebra, and what? Yes, probability and statistics by today. Okay? है ना? So it will also take some time. So 1:30 will be able to finish that whole thing. Conic section we will be able to keep another session. Okay? Let's do one thing. Conic section, let's keep a separate session for the conic section. ठीक है? Application of integration or area under curve. Let's start with this and we'll take a small break. ठीक है? After this. Okay, so area under curve, so we all know that area under curve involves some very basic concept, which is what? So basically, if you have this particular situation, this is y, this is yu, okay, this is fx and this is gx. If you wish to figure out this particular area, so a to b f of x minus g of x dx. So basically area is always upper curve minus lower curve if you are integrating with respect to x. But you know what, there will be some situation where you will be given this kind of area, right? Can you see? You are looking for this area basically. Okay, and this point is your f of a, this point is your f of b. Okay, which point? So basically this value and this value. This is, let's say, y1, y2. This value is y1, this value is y2. So here what you need to do is integrating with respect to y this time, right? And you will need, so this is your right curve, this is your left curve. So x right curve minus x left curve. Can you see the difference? This is upper curve minus lower curve. This is right curve minus left curve. This is integration with respect to dy, because you have you are integrating with respect to the horizontal strip, and the strip is varying from y1 to y2. So the upper and lower limit are nothing but y1 and y2. So these are the two classic cases. The whole basically area under curve will get involved in this only. Okay? Okay? Alright, let's just start this. Now this is the question: y square plus 4x is equals to 4, y minus 2x is equals to 2. So basically what I'm trying to say is, area between a line and a parabola is very famous, very pretty famous, right? So these type of questions are quite popular in your JEE Main. So y is equals to, so you can clearly see that you can just simply make this as 4 times x minus 1. So you can see that 1 comma 0 is the vertex, 1 comma 0 is the vertex, right? And this is leftward facing parabola. The moment you put y is equals to 0, you get x is equals to 1 over here, minus 1, sorry. Y को 0 put किया, तो you are getting what? X. 1 comma 0 is your vertex, rightward opening parabola. Y is 0, your x is coming out as 1. So this is minus 1. ठीक है, चलो. So this is how your parabola looks like at least. Now y is equals to 2x plus 2. Y is equals to 2x plus 2. So this is a straight line, right? So let me just show you the graph itself directly. So this was the parabola, ठीक है? Where, oh oops, I have drawn incorrect. So basically 1 comma 0 क्या हो गया है? हाँ, 1 comma 0 lie over here. So 1 comma 0 is the vertex, and this is how my parabola look like. The moment you put x is equals to 0, y is coming out as plus minus 2. So this is minus 2, this is plus 2. This is your parabola. So y is equals to 2x plus 2. Y is equals to 2x plus 2, and y square is equals to 4 minus 4x. Let's just solve these two. Shall I solve these two? Definitely. So yeah, here 2x plus 2 if you put, so what do you get? 2x plus 2 ka whole square is equals to 4 minus 4x. Okay. So 4x square plus 4 and plus, okay. So basically 2 2s are 4, 4 2s are 8x is equals to 4 minus 4x. 4 4 gone, and 4, this is 2, this is 1. So x square plus 3x is equals to 0. X is equals to 0 comma minus 3. So basically 1 2 minus 3 will be the point. So minus 3, the moment I put minus 3, what do I get over here? Minus 3. So it will become y minus 6 is equals to 2. So y will be equal to what? So the point will be what? Minus 3 comma minus 4. The moment you put minus 3, you will get minus 4. Okay, so minus 3 comma minus 4 is the point where these two things will intersect, and x is equals to 0 is also the point. The moment you put x equals to 0, you get y is equals to 2. So this is the point. So these are the 2 points of intersection, and you are looking for this area. You are looking for this area. Now tell me, what will you apply? Upper or lower or left or right? So basically which thing you will apply? Horizontal strip or vertical strip? Will you integrate it with respect to x or with respect to y? It is very obvious that you should integrate with respect to y. So minus 4 se leke 2, can you see that? And right curve is this, okay? So the value of x right minus x left, dy. So x, the value of x would be y square minus 4, or rather, let me write it this way, 4 minus y square by 4. So this is 4 minus y square by 4, right? Minus left curve. Where is the left curve? So left curve would be y minus 2 by 2. Y minus 2 by 2. And this is dy. The integral limit is minus 4 to 2. So right curve minus left curve will look like this. Okay? I'll show you the final the expression. So minus 4 to 2. This is x right. This is x left. This is the value of x right. This is the value of x left. You just need to integrate it, plug in the values, get the answer. Yes, this is your application of integration area under curve ka classic problem, wherein you are involved with a line and a parabola. So questions related to a line and a parabola you can see in your JEE Mains 2024 as well. Now we have another question. I would want to give you this as a homework. I will just help you in the curve plotting. Okay. So we have actually three curves. Can you see we have three curves? Xy is equals to 8, y is equals to 1, y is equals to x square. Now these two curves, so I can plot it nicely, right? Y is equals to 1 will look like this. And then y is equals to x square will look like this. Okay? These two तो we know. What about xy is equals to 8? And what is the relation between these two? So basically let's just solve these two. The moment you plug in y is equals to 1, you get x is equals to 8. Right? So x is 8 and y is 1. Right? Is the point on this rectangular hyperbola whose graph looks like what? Looks like this. So basically this is the graph of xy is equals to 8. So let me just show you. Xy is equals to c has this graph. Rectangular hyperbola. Can you see this is how it is going? And this is the point where this parabola and this hyperbola are getting involved. So xy is equals to 8 and y is equals to x square. When you solve these two, what do you get? Put y is equals to x square over here. So x square is equals to 8. Can you see x is coming out as 2 and y will be 4. So 2 comma 4 is this point. And you are looking for area between this region. This point is what? 1. And this point is what? 8. And this point is what? 2. So basically you have to integrate 1 to 2. Upper curve is x square. Lower curve is 1 plus 2 to 8 you have to integrate. So upper curve is your 8 by x minus lower curve is 1 dx. So this is how you have to integrate it. Right? This area and this area. This is the middle thing. Okay? So upper curve is x square, lower curve is 1. Upper curve is this rectangular hyperbola, which is y is equals to 8 by x minus 1 dx. Okay? Alright, perfect. Now we have differential equations, right? So shall we take a quick break? Hindi I know Hindi but I cannot speak Hindi on this channel. So I will not be doing that. है ना? Differential equations. Shall I just give you a 5-minute break and then we will discuss differential equation quickly. And yeah. So actually I am planning, what I am planning, let me just tell you. That after differential equation, we will be solving vector algebra, 3D geometry, statistics and probability. Okay? 1, 2, 3, 4, 5. 5 chapters we will discuss it today. We will be ending the session in an hour or like 1 hour 15 minutes maximum. Okay, we will do the next thing, which is the conic section, straight line, circle, parabola, hyperbola, ellipse, all these 5 chapters in the next session. Okay, let's do this. Okay, let's just finish it off. Let me just give you a 5-minute break. Okay. I am back. I am back. Come back, come back, come back, come back. Okay. Differential equations quickly, ठीक है? So differential equations में what is important? So differential equation में homogeneous equation is important. Linear differential equation is important. Reducible to linear differential equation is also important. And along with that, what else? Exact differential equation is also important. So first form is variable separable, very easy. So in here you have to just separate the variable. Let's suppose x square dy plus y cube, x cube dx plus y cube dy is equals to 0. So in here you will be separating the variables. Clearly x square dx can be integrated separately, and y cube dy also can be integrated separately. Integrate it, you will get the final answer. Okay? This is very easy, variable separable form. Then we have homogeneous form, wherein dy by dx can be represented as a function of y by x. The moment you see this, you have to put y is equals to vx or y by x is equals to v. Okay? Y by x is equals to v. Okay, clear hai? So and you have to proceed with this. So dy by dx will be replaced by v plus x dv by dx. Right? Yes? Okay. Now linear differential equation and reducible to linear differential both are extremely important. This is how your linear differential equation look like in dy by dx in y. It could be in x. They can give you linear differential equation in x as well sometimes, right? So you have to identify both ways. If LD in y is not working out for you, LD in x can also be a thing. Okay? So linear differential equation in y, linear in x. So dy by dx plus py is equals to q, where p and q are functions of x, right? And the solution is given by y into integrating factor is equals to integral of q into integrating factor dx plus constant, right? Where integrating factor is equals to e ki power integral of p dx. So you don't have to solve a differential equation. The solution is already ready for you. You just have to calculate a specific integrating factor, plug in the value and then proceed with the solution. Same goes with this linear differential equation in what? X, right? So it will be x multiplied by integrating factor is equals to integral of q into if dy plus c, where integrating factor this time is integral of p dy. Here p and q are functions of y this time, right? Okay, so all the things can be. Conic section one shot. Yes, that's what my agenda is. Yes, Bharat. Yes, that's what I was thinking about. Conic section one shot. Let's do it. Okay. Now let's consider reducible to linear differential equation. Okay. So reducible to linear differential equation. Okay. So suppose you are not having any linear differential equation, but this type of equation is nothing but reducible to linear differential equation. The moment you see this, you will realize, okay, dy by dx is here and function of x is here, but in 2 tan y is not matching with our format. This x cube is fine, but what about this 2 tan y? So take 2 tan y is equals to, or you can say 2 tan y. Tan y can be taken as t, so that sec square y dy by dx can be equal to dt by dx. Okay, so this is what? dt by dx plus twice x. Now tan y is t is equals to x cube. Now can you see the linear differential equation in t now? You can simply just calculate this t into integrating factor is equals to q. What is q? X cube into integrating factor dx plus c will be the final answer. Can you see this? T into integrating factor. So t into integrating factor over here would be what? So e ki power 2x ka integral dx. So e ki power x square is your integrating factor. So t e ki power x square is equals to integral of x cube e ki power x square dx plus c, right? x square को मानो t and x square का x, हाँ, so this will get resolved. Yes, ठीक है? This I am not solving it for you. This is normal integration. You will be able to solve it, right? Now exact form. Exact form is something which NTA is showing extra favoritism towards this exact form, right? So basically, what is exact form? It's purely intuitive. The moment you see that x dy plus y dx, what do you feel? Don't you feel that somebody has kept x constant and differentiated y? Somebody has kept y constant and differentiated x. So what does that mean? Product rule. So derivative of x and y, right? Now differentiate it. So keeping x constant, differentiating y, keeping y constant, differentiating x. Now again, same. X dy plus y dx is what? D of xy upon xy. Integral of this will give you what? Integral of d of log of xy. Right? Yes. Perfect. Now what about this? X dy plus y dx upon xy का whole square. ठीक है? X dy plus y dx upon xy का whole square. So can you again see that? So d of xy upon xy का square. So this is nothing but d of minus 1 upon xy. ठीक है? What about this again? Same thing. Now this is something else, by the way. Now this is x dx. This is unlike the first three things. X dx, y dy. You know what? So x dx and y dy. So if I multiply 2 over here and divide it by 2, so can you see that this is nothing but derivative of x square? This is derivative of y square, right? Derivative of x square, derivative of y square. So this is nothing but 1 upon 2 derivative of log of x square plus y square. Why? Tell me. Because the moment you differentiated, it would become 1 upon x square plus y square, and x square plus y square again if you differentiated, x dx, y dx will be there. So this is how exact forms are. ठीक है? Now let me just show you this. D of y by x. Apply the quotient rule. So x square will be over here. Then x times dy minus y dx. So the moment you see x dy minus y dx, try to think about quotient rule. Or y dx minus x dy, try to think about quotient rule again. And same thing, right? Y dx minus x dy upon x square plus y square is equals to this. Think about the quotient rule only, right? How to think about the quotient rule? Y dx minus x dy upon, we have y ka square, upon we have 1 plus x by y ka square. Yes, x by y ka square. Can you see that now? This is d of x by y, and this is 1 upon x by y, 1 upon 1 plus x by y ka whole square, right? So this is what? D of x by y, and this is 1 upon x by y ka whole square. Integral of this would be what? Tan inverse x by y. Yes? So this is, yes. Reading the differentiation formula in reverse give exact differential equation. Yes, luxury clear. So you have to think the opposite way. Okay, what should I think about the value whose differentiation is this? Think about some value whose differentiation would be this. Think about that value whose differentiation would be this. So reverse process, you have to apply the reverse brains. Okay? So this is all about the exact differential equation, right? And yeah, so we have an exact differential equation just like this. So x cube plus 1 dy is equals to x dx minus 3xy dx. This and this. X cube plus 1 dy, ठीक है? Shift this towards the left hand side. 3x square y dx is equals to x, sorry, this is dx, x dx, x dx. Can you see this now? Can you see this whole thing? Can you see this? If I take x cube plus 1 into y, x cube plus 1 into y and differentiate it, what do I get? If I keep x cube plus 1 constant, I have to differentiate y. Plus, if I take y constant, then 3x square dx will be a thing. Can you see this? This is the exact same thing written to us. So this is x cube plus 1 times y ka derivative, which is equal to what? X dx. Now integrate it. So it will become what? X cube plus 1 times y, and this is x square by 2 plus constant, and you know what? Initial condition f of 0 is given as 0. That means 0 comma 0 will satisfy this. If this is 0, this is 0, this is 0, we can clearly see my constant is 0. So y is coming out as what? X square by 2 x cube plus 1. Right? So this is your y. So x square upon fx. fx is this only, na? X square by 2 x cube plus 1. So this will become what? Twice of x cube plus 1, where obviously x tend to 0. So x को 0 जैसी रखेंगे, we will get option C as the correct answer. Yes? Yes? Okay. All right. Now this is basically LDE. This is a homework question for you. LDE homework question, basic one, JEE Main 2023, right? So the moment you divide it by x log x, now it will become your basic one. I'll show you the solution. Okay, so I have actually removed the solution. Divided by x log x, you will get dy by dx plus 1 upon x log x. Y is equals to x log x se kar do divide, so it will become x. Can you see? This is your p, this is your q, and this is your basic linear differential equation in y. So you can solve it, right? This is your homework. ठीक है? All right. Let's just move towards the equation reducible to linear differential equation now. Yes. So this is something equation reducible to linear differential equation. So it is not the direct one. Not the direct one. You have to form this as equation reducible to linear differential equation. So just divide whole thing by what? By y actually, because you don't want to see y over here, right? Because that's how your LDE is. This should be purely a function of q. So 1 by x dy by dx plus dividing it by y, so x log y and x, so basically y log y. No, you are dividing it by y, right? Sorry, you are dividing it by y. So 1 by y, dividing it by y, you will get x log y, right, is equals to x cube, right? This is your equation. The moment you put log y is equals to t, so 1 by y dy by dx will become what? dt by dx, right? So this whole thing will become dt by dx plus x times t is equals to x cube. So this is LDE in t. Linear differential equation in t. Yes. Linear differential equation in t. That's it. That's about it. Okay? So now you just need to solve it. Okay, I'm not helping you in this. You just need to solve it, and you know how to do it. So t into integrating factor is equals to integral of where is q? X cube into integrating factor dx plus c, right? So that's how you solve it. I'm just leaving it for you only. This is x cube plus c. What is integrating factor? E की power integral of x dx is your integrating factor. So e की power x square by 2 is your integrating factor. Solve it, get the answer. ठीक है. So now this is what, so basically this is a conic section, and you know what, conic section we will not do it today. We are keeping this conic section yes, okay. Slideshow from the beginning, right? Okay. Not from the beginning, okay. What is happening? What is happening? File, insert, draw. क्या करूँ इसमें? View, view, normal outline view. हाँ, this is the view maybe I wanted. Okay. So we'll switch towards the vector algebra, and yeah, let me just. Okay, so where are we? So we have done this already. This is okay. Straight lines, no. Conic section we are skipping for now. Conic section we are skipping for now, and we are approaching the remaining things. Okay. Let me just figure out. Yes. Slideshow from current slide. Yes. Yes, let's start with vector algebra. Let's begin vector algebra. Yes. Are we ready? Are we ready for the vector algebra? ठीक है, let's do the vector algebra, and the conic section will take it up later on. Okay. ठीक है, तो vector algebra, let's quickly understand the basic of vectors. We will study section formula, addition of vector, and product of vector, scalar and dot and cross. ठीक है. हाँ, yes, Diya, conic section basically so it will basically take me another 2 to 3 hours for conic section, and we are still left with vector, statistics and probability. So what we can do is we can push the conic section part towards the next session. I'll take a completely different session of a conic section. ठीक है, let's do this. Okay, चलो. So सबसे पहले two products are extremely important. Scalar product, that we can call it as a dot product. Vector product, we can call it as a cross product. ठीक है, let's talk about dot product. So you all know that A dot B is equal to what? AB cos theta, right? Okay, and you know what, cos theta, this cos theta will be what? A dot B upon magnitude of A, magnitude of B. We can write it this way. So A dot B is equals to what? A dot B is equals to AB cos theta, and A dot B will be equal to, so cos theta will be A dot B upon magnitude of A, magnitude of B. This we all know. So sine of cos theta will depend upon the dot product actually. So if A dot B is positive, that means your cos theta is also positive. Cos theta positive मतलब theta lies between 0 से 90 degree. ठीक है? If your A dot B is equal to 0, what does this mean? That your cos theta is becoming 0. Cos theta becomes 0 when your angle is 90 degree. And if your A dot B is coming out as negative, this implies your cos theta is coming out as negative. So theta belongs to what? So 90 degree to 180 degree because your cos theta becomes negative. So basically A dot B, the dot product tells you about the sign. Basically dot product sign, positive, negative or 0, tells you about the angle between both the vectors. That is one thing which we should notice, which we should all notice, right? Okay. And if you are given two vectors, suppose A vector is given as A1 I cap plus B1 j cap plus C1 k cap, and B vector is given as what? A2 I cap plus B2 j cap plus C2 k cap. Then your A dot B vector will be A1 A2 plus B1 B2 plus C1 C2. ठीक है? Alright, so this is all about the dot product. What are the properties of dot product? A dot B and B dot A both should be equal. That is one thing. And A dot B plus C would be A dot B plus A dot C. ठीक है? And you know what? L A vector plus dot M B vector. So L and M can come out and this will become A dot B vector. ठीक है? Okay. Alright, so this is what the properties of dot product. What about the geometrical significance? Now this is something which will gain you marks in JEE Mains 2024. Projection is something which is coming since 2020, 2019 or before that. Basically past 5 years projection is there consistently. 2019, 20, 21, 22, 23 and 24 you will also see projection, question based on projections. Okay? So what does it say? That whenever you need to figure out projection of A vector on B vector. So projection of A vector on B vector is what? Tell me. A dot B upon B vector. Yes. So जिसके ऊपर, so basically vector you are taking projection on. So can you see on B vector? So you need to divide it by B vector. If it is on A vector, then what would be? A dot B divided by magnitude of A vector, right? So projection of B vector on A vector would be what? So upper the dot product, in the denominator you will have to divide by on A, so A will be in the denominator. On B, so on B, if there is on B, B is in the denominator. That's how your formula is. Okay? So projection formula, I hope, I assume that all of you will remember it. Okay? Alright, have a cup of coffee. I can't have a cup of coffee. I don't want to have a cup of coffee because again, because it's already night and we will be finishing off in a few minutes, in an hour at least. So after an hour I want to sleep. That's why I don't want to have a cup of coffee. Okay? Because after having a cup of coffee I'll be awake whole night. So if you want me to teach till 5 AM in the morning, then I can have cup of coffee. You tell me, will you sit with me? Will you sit with me till the very morning? Okay? So cross product. Now let's talk about the cross product. A cross B. The value of A cross B is AB sin theta n cap. The value of A cross B is AB sin theta n cap. And the determinant you can see over here. So that's how you calculate A cross B, by solving this determinant. And you know what, one very important thing which is very, very helpful in JEE Main 2024. This is the moment. You know what is the moment? So whenever you see this statement in your JEE Main examination, na, so the statement is vector perpendicular to two given vectors. And you know what? This statement definitely is there in 2023, 2022, 2021. Every year they tell you this statement. There is a vector which is perpendicular to two given vectors, and that is given by lambda A cross B. Yes. So what I am going to tell you is, so this A cross B vector is perpendicular to A and B vector both. That's the basic definition of A cross B. What does that mean? That simply means whenever you need any vector which is perpendicular to two given vectors, just take cross product of it, apply any magnitude. Maybe they have given in the question, maybe you have to assume it, and you will get your answer. Okay? Let's understand some properties. Let's understand some properties over here. A cross B is equals to minus B cross A. So basically A cross B, the direction of A cross B and direction of B cross A is exactly opposite to each other. That is first property. What about the second property? This shows the distributive nature of cross product. So A cross B, A cross C, and A cross B, A cross C. It will be there, right? And you know what? Whenever you see some scalars, na, take out scalars out, and then A cross B, simply you can do it. Okay? And one more thing, one very important thing. Whenever you have to take cross product with its own vector, it will become 0. That is one thing. And you know what? A cross B, whenever you take dot product with either A or B, it will again become 0. Why? Listen to me carefully. Can you tell me this particular vector is perpendicular to A vector, right? This vector is perpendicular to A vector, right? And this is A vector itself. So basically this is A vector, this is perpendicular to A vector. So dot product between two perpendicular vectors, these two are perpendicular vector, will become 0. Are you getting my point? Yes? Okay? Alright. Again same thing. If you dot it with B, then it is also 0. Now I cross I, J cross J, K cross K will become 0. Why? Because angle between these two is 0, and it will definitely involve sine theta. Sine 0 is 0. So cross product between two parallel vectors or two same vectors will become what? 0 only. Right? I, J, K. Now I vector, J vector, K vector. Okay, I to J, J to K. Can you see I cross J is K, K cross I is J, and then I cross J is K, right? I cross J is K. I already told you J cross K is I, and then K cross I is J. So this is what cyclic order is, right? Yes. Okay. Now let's talk about area of parallelogram. So whenever you have a parallelogram whose one side is A vector, another side is B vector, so simply write magnitude of A cross B. That will give you area of parallelogram. But by the way, one more thing, area of parallelogram is also given by both the diagonals. So half diagonal number 1 cross diagonal number 2 will also give you the area of parallelogram. So if you know the diagonals, D1 cross D2 by 2 will give you area of parallelogram. So this was all about area of parallelogram. Okay? Right? Okay. And now let's talk about, yes, let's talk about area of triangle. Area of triangle OAB. So area of triangle OAB or area of any triangle will be half side, so vector related to side 1 cross vector related to side 2. So basically half A cross B. So this is area related to any triangle. So in triangle half is there. In parallelogram only A cross B is there. Okay? Let's just talk about this question which was asked in 2023. Okay? So this type of question has, they ask regularly, frequently from each year, past basically 4 years. Past 4 years I am seeing this type of problem, even more than that. So the problem statement say they have given, okay, A vector, then B vector, then C vector is also here. But then this equation is something which is repeating. This type of equation is repeating. And you know what, in 2023 there are more than 3 questions just like this. The same equation. Okay? Let's just focus on this. I can clearly see D cross B is equals to C cross B. Right? Let's shift everything towards the left hand side. So D cross B minus C cross B is equals to 0. Take B common. So D minus C cross B is equals to 0. Now who was there with me in vector algebra session? Who was there with me in vector algebra session? Who will tell me? Cross product between two quantities 0. That means these two quantities are parallel quantities, and you can write D minus C vector is equal to lambda times B vector. Or what you can do is D vector will be given by lambda B vector plus C vector, which is lambda times B vector, which is 3, minus 2, 7 plus C vector, right? Plus simply C vector. C vector is what? 2 minus 1, 4. Now you can calculate D vector very easily. It will become 3 lambda plus 2 minus 2 lambda minus 1, 7 lambda plus 4. And what is the A vector? A vector is what? 1, 4, 2. If you take dot product between these two vectors, it will become 3 lambda plus 2. And you know what? 4 times this. So 4 times minus 2 lambda minus 1 plus 2 times 7 lambda plus 4. So it is given that D dot A is coming out as 24. Right? Can you see this? Now you can calculate the value of lambda from here. I'll show you the direct solution. So the moment you do that, the value of lambda will be equal to 2. Yes. So the value of lambda, let me just calculate it anyway. So 3 minus 8. It will be minus 5 and 14. So 9 lambda. Right? And this will become 2 minus 4. And 2 minus 4 is minus 2. So this will become plus 6 is equals to 24. So can you see lambda is coming out as 2. The moment you plug lambda over here, you will get the exact D vector. And the moment you get exact D vector, you will be able to calculate D ka square. Done, done. Right? Done. So now you have lambda is equals to 2. This is your D vector. And you know what? D square is what? 64, 25, 324. This is 413 is your answer. Yes. Okay. Last question from the vector algebra. Why last question? Because this I already told you related to cross product. I will show you right away. Who was listening to me 5 minutes before I told you that there is a vector which is perpendicular to the given vectors. This statement, who is going to tell me about this vector? Who is going to tell me about this statement? Every time, every year I see this line, and you know what? Very few students are able to decode it. Many students are not able to decode it. It's just written purely AB cross AC is written over here. That's it. This is AB cross AC. Yes? Let's understand the whole question. OB the origin, position vector of point P is given to you. Position vector of point A, B and C, all 3 points are given to you. Projection of vector OP on this vector. So projection of vector OP on AB cross AC vector is what we need to figure out. So mod of, basically that's what we need to figure out. This is what they are asking. OP vector, who is going to tell me OP vector? So OP vector is this only, minus 1, minus 2, 3. Right? What about AB cross AC vector? So AB vector, so basically AB, AC. So AB and AC are this only, right? So you just have to make a cross product. 2, 4, minus 2, minus 4, 2, minus 1. Just figure out the cross product. So minus 4 and plus 4. Minus 4 plus 4. Okay? AB cross AC directly I will show you. AB cross AC. Yes. So AB cross AC is 431 minus 212. यही लिखा है ना मैंने 431 नहीं AB cross AC, right? So AB is 24 minus 2 and minus 4 to minus 1 respectively. AB and C. Sorry, AB cross AC. Oops. Sorry. This is AB cross AC, right? So AB cross AC we need to figure out. Yes. So this is A, this is B. So AB cross AC, 2 minus 2, this is 4. This I am looking for AB. 4 minus 1, this is 3. Minus 2, so this is plus 1. This is AB vector. What about AC vector? So C minus A. So minus 4, minus 2, plus 2. 2 minus 1, 1. Minus 1, minus 3, plus 2. Now take dot, they take cross product. The moment you take cross product, 3 minus 2, 5, comma. 4 2s are 8 minus 2. So 8 minus 2 is 6, so minus 6. And 4 minus 6 is minus 2. This is your AB cross AC, which is what? 5 comma minus 6 comma minus 2 upon square root of 25 plus 36 plus 2. So this will give you the dot product. This will give you the final answer. Okay, this will give you the final answer. What is the final answer? Yes, so 5 minus 10 and plus 10. So sorry about this. 5 minus 10 and plus 10. Is it coming like this? 5. Okay. Maybe 5 minus 10 and plus 10. 5 comma minus 10 comma plus 10. Or what you can do is you can simply write 1 comma minus 2 comma 2. Okay, 1 comma minus 2 comma 2. So you just write 1 comma minus 2 comma 2. 1 comma minus 2 comma 2, and this will become 4 plus 1. So this is what? Minus 1 and then plus 4 and then 3 2s are 6 upon 3. So this will be 9 by 3. So the final answer would be 3 only. So 3, that means option B is absolutely right. Minus 2 and then minus 1. ठीक है, AB cross AC 431 minus 212. So 3 is the correct answer. Perfect. Yes. Okay. So now 3-dimensional geometry, I will be covering this in geometry as well. So let's just do the part 2 now. Okay, so let's just wind it up. So we will discuss the rest of the things in part 2 only, right? So we will need a part 2, I guess. No matter if we push it 2 or 3 hours, it will take a lot of time. Let's do it nicely. Let's make a part 2 of it. So complete mathematics revision part 2. I'll be bringing up part 2 with you guys. Okay, so I guess I'll be actually ending up the session now. Let me just end this now. Okay, and yes. Let me just tell you about this, which is क्या हो गया ये? slideshow. Okay, from current slide. Yes, okay. So we are ending the session now, guys, because it's already too late, and you know what, we have a lot to cover. So no matter if we stretch 1 or 2 hours, we will not be able to finish. So let's just finish the next part, the rest of the part in the next part. And you know what, regarding this, so basically we have a session, basically we have something in Janakpuri, right? And there are some sessions going on which will guarantee you personalized attention. And you know what, to know more about it, what you can do is you can reach out to on Saturday and Sunday both, January 20 and 21. If you are staying in Delhi, then this is for you people, right? So you need to reach out to this particular address, which is Vedantu Offline Center, the newly built, and you will get to understand that how to get personalized attention by Vedantu teachers. Okay? So this is me, Namrata, signing off. I'll see you all in part number 2. Bye bye. See you. Good night.